एक ही। हाँ। और जो आपका रूल है वो हमें रिस्पॉन्सिबल लगे तो ठीक है। आप बोल रहे हैं। आप बोलते ना वो। आपको कितने असाइनमेंट्स तो आएंगे किताबें वो बंदी हो कोई म्यूट है ना। Hello?
Good morning, Professor C. Am I audible?
Oh, yes.
Yeah. Sorry, we are getting delayed by 10 minutes. We will start shortly. Yeah. Sorry for the delay.
Don't worry.
Yeah. Thank you.
A very good morning to everyone. And I'm Rajendra, a faculty member in the Department of Electrical Engineering. A very warm welcome to the second day of the Industry Day and this session on augmented reality, virtual reality, and metaverse. So, in this session, we have two interesting keynote talks. First talk is by Dr. Simon C. From NVIDIA, and we have the second keynote talk by Mr. Pardeep Khanna, who is from Global Mindset. And after the keynote talks, we'll present the progress of the institute on this theme on AR, VR, and metaverse. And thereafter, we'll have a panel discussion. And for the panel discussion, or panel members are Mr. Pardeep Khanna, Dr. Lokesh from NVIDIA, Samsung. We have Mr. Bharat Kumar Sharma from NVIDIA. We have Professor Jain and Professor Santanu Chaudhary. So I once again welcome all the keynote speakers, attendees, and the panel members. So now I invite Dr. Manish Narwaria to introduce the speaker of the first keynote, a keynote talk. So, so let me introduce Dr. Manish. Dr. Manish Narwaria is an assistant professor at the Department of Electrical Engineering, IIT Jodhpur. Dr. Narwaria completed his PhD from NTU Singapore, and his research interests are in multimedia signal processing and spatial sound analysis. Over to you, Manish. Please introduce our speaker.
Yeah, very good morning to all of you. So we are delighted to have Professor Simon with us as a keynote speaker. Professor Simon is currently the Solution Architecture and Engineering Senior Director and Chief Solution Architect, Global Head, NVIDIA AI Technology Center, NVIDIA. He's a professor at Shanghai Jiatong University, professor in Beijing Universities of Post and Telecommunication. He is being conferred as a distinguished scholar in 2018 by the Fudan University, Shanghai, China. He was previously Chief Scientific Officer at BGI China and has held positions at NTU Singapore and several other universities in Asia. He is currently overseeing a number of international projects in the area of AI. He has published over 200 papers in these areas of AI and has won numerous awards. He is a fellow of the IET, chairman of task force of IEEE CIS Neural Networks Technical Committee, a member of several professional bodies such as IEEE, SIAM, AAAI, and he's also on the International Advisory Board of Institute of Operations Research Analytics, Advisory Team of Machine Intelligence and Data Analytics Research Center, School of Computing Sciences in India, and several other places around the world. Professor C has a PhD degree from Salford, University of Salford in the UK. Prior to joining NVIDIA, Dr. C worked for SGI, DSO National Lab, Singapore, IBM, International Simulation Limited, Sun Microsystems, and Oracle. So he has a vast experience in the industry, and we are delighted to have Professor C with us. Over to you, Professor C, for your keynote address.
Oh, thank you very much, Professor. It is a pleasure for me to give this presentation. I was hoping that I could be in India at this point in time, but unfortunately, travel doesn't allow me. But let me get started off with my presentations. I talk about digital twins, the crash of data, mathematics, simulation, and high performance computing. I would say that I am my background is in applied mathematics. I'm a trained mathematician by training, and I get stepped into artificial intelligence only pretty recently. So let me get started off. Now, many of you would have already heard so much about Metaverse. In one way or another, it's being used in many aspects, from gaming to social networks, to graphics, industry factories, and whatsoever. And one of the very important thing, especially from an industry perspective, being a scientist myself, I'm always interested in doing how can metaverse be used in a more industry and scientific manner. So we look at how metaverse is being used in that space. Now, metaverse and digital twin is not a new idea. It is very much a very old idea that has come up, that has been born many years ago. In fact, since computer was being designed, people have been thinking about how to have a digital twins of almost everything, right? But one of the biggest success of actual fact twins is in the mission of Apollo 13. And many of you will remember that in the early days of the Apollo program, the Apollo program basically is to send men to the moon. But Apollo 13 is a success in the sense of how twins is being used. Now, many of you will remember that the Apollo 13 didn't actually make it to the moon. The actual fact had to do an emergency detour and bring the man back to Earth. And basically because of the explosion of the oxygen tank, as you could see on the screen. Now, like I said again, the original idea was to fly to the moon, land the landing modules on the moon, and then send people back. However, because on the a couple of days after the thing was launched, the mission was actually abandoned. There was a big, huge ruptures on the service module, and then the entire mission would have to be changed. Now, this was a very, very interesting part of Apollo 13. It is dangerous because no one has know how to bring a damaged spacecraft from which is so close to the moon to bring back to Earth. And the make worse of that is that many of the system actually starts to fail over that. Now, during that time, they were on Earth itself. So one of the very important thing was also is that because the oxygen was leaking, they have actually shut it down. And also, when they shut it down, the fuel cell was all not working because they need the oxygens whatsoever. There is not enough power whatsoever, and things like this. They have to shut everything down. Now, so the question is that now how to bring the man back to Earth? So one of the things is that on Earth itself, inside the laboratory, they have exact twins of the landing module, the service module, and the command module. All this being is the exact duplications of the spacecraft. Now, they have to simulate how to actually bring the thing back, where the damage is, and how to bring the thing back. Many of you will have seen the movie Apollo 13 before, and I would not need to drag on it, delve on it too much, as you could hear about the story. But very important thing is that you have a digital twins over here. And the thing is that the twins itself, the duplication system, there is a computer system that simulates the environment. So with that, the engineers were then able to simulate the things and how to actually bring the spacecraft back onto planet Earth. They know they know what are the modules to actually turn it on, which power circuits to turn on at the right time, how to actually fire the engine and whatsoever, right? Now, this cannot be done if they do not have the twins. So they have the twins together with it. Now, the twins, of course, consist of the spacecraft and the exact environment, and it's computer simulated. Now, at the point during that time, of course, as you know, the mission was they managed to bring all the 3 men back to planet Earth. So this is basically a hardware in the loop, the success of it, and then as you guys will know, many of the industry actually uses this, what we call hardware in the loop. And this is basically what we have is that you have the duplication of an aircraft, and then you have an environment that actually connect to it, computers that connect to it that simulate the environment. They are being used in aircraft, used in cars, used in spacecraft like this, and it is a very, very common thing. Now, during that time, this is examples of a full-blown simulation, hardware in the loop simulation environment where you have the data collection, visualization, you have the generator, you have airframe, simulation, and IR scenarios, and so forth. Now, during that time in 1970, one of the things was when we want to simulate the environment, you have to simulate. It is described by a set of differential equations, and this is a very simple set of differential equations. In order to solve that, there was at the time you need to solve it with analog computers, and this is how the analog computer is being set up. Using transistor, using resistors, inductance, capacitance, or whatever to actually solve the differential equations. So this is a analog computers at the point in time. During my time when I started working as a simulation scientist, we built a system like this to simulate and to solve a differential equations. Of course, things get better, and this is still an analog computer. This is actually, in fact, a GUI computer for hardware in the loop simulation, or what we call, and in the moment right now, what you call a digital twins. But at the time, it was an analog computer. Of course, now, fast forward in time, now you have supercomputers. This is a supercomputer that is in Facebook or Meta that has 4,000 over GPUs to simulate the entire environment. And that's where Metaverse is being, they can do all sorts of things in the Metaverse. Now, remember that when I say when you need to actually do the solve the environment, and the environment is solved by a set of equation, the environment of space, climate, whatever, and this is examples of a Navier-Stokes equation. It's pretty complex, and it is very, very difficult to solve. For those who have done in CFD, you will know that this equation itself, in order to have 5 fidelity, require a pretty large computer to actually solve this after discretization. Now, mathematics comes into play, very important. We actually do have to do some form of model reductions. We got to reduce the problems to a size that is enough for us to solve this equation in real time. Not just solving it in fast enough, but having to solve it in real time. So we have to reduce it to a space, to a set of equations that we can actually solve this. So there are a lot of work being done over there over the period of time. And if those who are interested, these are some of the books that are actually available. The another approach recently has been taken on is to find a fast surrogate model. Remember that we look at the reduced model as a surrogate model, but can we do it in a very different surrogate model? And we look at artificial intelligence or machine learning, so to say. There are many types of machine learnings. As you could see over here, you got the DNN and whatsoever. And let me show you examples of where NVIDIA has
twin of
used
BMW's assembly system, powered by Omniverse. For the first time, we are able to have our entire factory in simulation. Global teams can collaborate using different software packages like Revit, CATIA, or point clouds to design and plan the factory in real-time 3D. The capability to operate in a perfect simulation revolutionizes BMW's planning processes.
Are those gaskets still in the right place for you?
Yeah. BMW regularly reconfigures its factories to accommodate new vehicle launches. Here we see 2 planning experts located in different parts of the world, testing a new line design in Omniverse. One of them wormholes into an assembly simulation with a motion capture suit, records task movements, while the other expert adjusts the line design in real time. They work together to optimize the line as well as worker ergonomics and safety.
Can you tell how far I have to bend down there? So we'll get you a taller one, but it's perfect.
We would like to be able to do this at scale in simulation.
That's exactly why NVIDIA has digital human for simulation. Digital humans are trained with data from real associates. You can then use digital humans in simulation to test new workflows for worker ergonomics and efficiency. Now your factories employ 57,000 people that share workspace with many robots designed to make their jobs easier. Let's talk about them.
You're right, Jensen. Robots are crucial for a modern production system. With NVIDIA Isaac Robotics platform, BMW is deploying a fleet of intelligent robots for logistics to improve the material flow in our production. This agility is necessary since we produce 2.5 million vehicles per year. 99% of them are custom.
Synthetic data generation and domain randomization available in Isaac are key to bootstrapping machine learning. Isaac Sim generates millions of synthetic images and vary the environment to teach the robots. Domain randomization can generate an infinite permutation of photorealistic objects, textures, orientations, and lighting conditions. It is ideal for generating ground truth, whether for detection, segmentation, or depth perception. Let me show you an example of how we can combine it all to operate your factory. With NVIDIA's Fleet Command, your associates can securely orchestrate robots and other devices in the factory for mission control. They can monitor in real time complex manufacturing cells, update software over the air, launch robot.
So this is examples of how digital twins is being used in factories. And I'm going to switch topics a little bit and talking about digital twins of the human. Over the last couple of years, you guys will see that there are a lot of research being done into devices and devices that's able to measure our heart rates, measure the sensitivity of the skins, blood pressures, and so forth. All this new technology is coming out, and now we are able to implement that onto a smartwatch. So there are devices right now that you can almost monitor every single part of our body, from the heart to the blood pressure, like I said before, to many other things. So the wearable bioelectronics are now to stay. One of the very interesting thing is to interface to the brain. Now, you guys may have heard of Elon Musk's Neuralink. There is also another company called the Secotron. Now, Neuralink is basically both of them are a bit intrusive. In Neuralink itself, you're going to actually operate on the brain, put the device into the brain, and then connect to a device that's able to communicate out to the rest of the world. In Secotron itself is a device, as you can see over the video over there, is that basically is a device that actually go through the blood, go through the arteries, push it up to the brain, and then embed it onto the brain. Of course, again, in order to communicate with the rest of the computers, there is a device again to connect out, and then able for the computers to actually attach to it. This allowed you to do a lot of different applications, right? So for people to actually control computers and so forth and stuff like this. So all these technologies are now coming out, and we are going to realize it pretty very soon once FDA has approved it. So the human digital twins are slowly building into space. Now we are, like I say again, we are able to have devices to actually do the measurements. We are able to monitor, we are able to simulate, and so forth. To extend that further, there are some, which is very controversial, is to start simulating the disease. And for some of you who have watched the movie called Black Mirror or goodbye for now. And basically, is about the data that are being collected, and they are able to simulate the person who has actually passed on. And this is basically been already experimented in many places. For example, in the Holocaust Museum, they have captured a lot of data from the Holocaust victim, and then they digitize them, and then it becomes like a real human, simulating the real human to able to answer and articulate what they have gone through during the Holocaust. Um, in Korea, there is an experiment where the mother actually have interactions with the kids that actually pass on. So these are some of the examples of how the thing was being experiment on, and there are also experiment that uses GPT-3 artificial intelligence software to simulate a chat with a deceased girlfriend, Jessica, by using GPT-3 and fine-tune it with her data from Facebook and many other things to simulate how she's going to react and whatsoever, right? This is examples of a company called Meet AI, which is, let me see. So it's called internal IM, and what you do is that you actually it actually pick up and learn about what the person is a pass on person that you're able to interact with it. Now, in fact, this is now become such a interesting thing that actually Microsoft actually patent to how to revive the loved one as a chatbot, and this was being filed as a patent recently. Now, let us switch topics a little bit and go on to take a look at the state of the arts of AI algorithms. As you guys would know, mathematically, and one of the famous theorem by Jaboge in 1989 is that neural networks can almost mimic any function. And on top of that, it is if you look at the theorem, this theorem itself, basically it can, using optimum transport is solving the discrete mode problem, it can actually mimic all sort of equation that is continuously smooth. So what it means is that it's a universal approximation for all neural network for almost not just a continuous function, but also able to express probability distributions. Now, the neural network itself has become very mature. Because of that, the neural and the recent research itself and make neural network become very mature. It's no more just a science experiment. It's being used in many places, for example, like facial recognitions, in the life sciences, medical images, and so forth. The recent generative AI has actually developed a lot of interesting application. This is GilGang 2 and GilGang 360 developed by NVIDIA research groups. And you can see over here by combining text and images, you're able to generate out from text to image. Like I say again, the generative AI has actually also recently been a lot of development. One of them is stable diffusion technology. There are a lot of diffusion technologies being developed recently, and as you could see, there are a lot of applications that's been developed. So this nerve where we have able to actually fact text by taking the photograph, we are now able to generate 3D instances, which is a tremendous tools when you use it for the for creating contents in the metaverse. Now, switching topics a little bit, we go over the natural language processing. Now, recently, the transformer have actually changes the entire natural language processing scenario. Now it's being used in many places, for examples like video conferencing, call centers, retail assistants, and so forth. Many of you would have used Siri or Google's Home, and which is using some form of natural language processing, right? Examples of it is Samsung Neo projects. It is the human AI chatbot, and you guys will hear of a couple of years where GPT-3 was being launched. It has caused a controversial, many much controversial and scare. And it's not just about natural language processing, producing translation or whatsoever, but it's also being used as a tools to actually generate out the software. This is from OpenAI Codex, and you could see over here is that by using natural language, by typing in the natural language, you actually generate out codes, which means that we are now going to transform how software engineers is going to write software. Now, moving ahead, of course, I'm just going to skip on this. The Chinese Wu Tao is not, also able to develop all these things, a much bigger model. And as you guys know, the Chinese language is much, much more complex than the English language. And that's why this model is almost 1.75 trillion parameters. Moving forward, this is a map of where the entire transformer is. From the vanilla transformer, over the last couple of years, it has many different variation of transformer. And you guys would know that, in fact, many of these transformer are using very large model. And this is just a timeline of it, where recently you see GPT 3.5, and which is part of Chat GPT. Going forward a little bit, we look at reinforcement learning. Many of you will heard of the AlphaGo itself. The AlphaGo technology is actually based on something what we call reinforcement learning. The reinforcement learning has progressed on very quickly over the last couple of years. They have many new algorithms, from classical deep reinforcement learning to distribution reinforcement learning, and many other form of reinforcement learning was being developed over the last couple of years. It has been applied into experiment into many things. Things will be like Atari Go, from Go game to StarCraft, and to many first shooters games and whatsoever. What it does is that it means that you can now we are trying to experiment with how to use reinforcement learning for many different types of scenario. The reinforcement learning is being used in many things, especially in robots like autonomous vehicles, factory robots, warehouse robots, and many other things. So the reinforcement learning is being used in this, but of course, it's not just that, it's being used in many other things. The examples over here, this is the examples of where reinforcement learning being used. This was developed by Berkeley, and in fact, this was done a few years ago, where the robots are being asked, not programmed, to asked to actually put the red pig into the hole. And what it does is that it will try again and again and again, and finally, it's able to put the red pig into the hole by using reinforcement learning. Going forward, there are many other things where multi-modality type of things together with reinforcement learning. One of them is Goto, and it can do multiple tasks and so forth. So I'm not going to dwell on it too much, but this is show that where all the new technologies is coming about. And of course, you guys would have heard of this. This is basically DeepMind, where they use deep reinforcement learning to develop new algorithms, faster matrix computation. As you guys will know, the structured algorithms is one of the best in the world, and these algorithms, by using reinforcement learning, able to produce another matrix algorithms that is better than the structured algorithms. As I mentioned earlier, one of the things was how neural network is going to combine with physics. This is the examples of a computational fluid dynamics, a CFD, a Navier-Stokes equation, and in 1999, Pinkers actually approved that we are able to actually approximate high degrees of derivative using a ping approximation. Using that, we are now able to actually design algorithms, what we call physics-informed neural network, that's able to solve physics equations that it describes in a partial differential equation or ordinary differential equations. So these are some of these are examples.
Total worldwide wind energy capacity currently exceeds 750 gigawatts and is growing faster than ever, with an additional 650 gigawatts to be added in the next 5 years. For companies like Siemens Gamesa Renewable Energy, optimizing the configuration of each new wind farm is critical for getting the most out of their investment and reducing costs for consumers. When designing a wind farm, it's critical to place each turbine so as to minimize the effects the turbines have on each other due to the wake that they create. Accurately modeling the wake requires high-resolution, high-fidelity simulation data that is specific to that wind farm, such as the geographic location and the terrain. The gold standard for generating this data is the large eddy simulation shown here. But to run just one iteration for a single turbine can take 40 days on a 100-core CPU. And with so many iterations needed to develop an accurate model for a specific site, using CPUs is impractical. Using NVIDIA Modulus and NVIDIA Omniverse, Siemens Gamesa has been able to reduce that 40 days to just 15 minutes, approximately 4,000 times faster. This is accomplished by running the model at a lower resolution, and then, with a physics ML model trained using Modulus, to enhance or super resolve the data. And the results are functionally equivalent to having run the model at full resolution. Let's take a look at the same data presented in a way that clearly highlights the coarseness of the low-resolution simulation. Here, they look like pixelated blobs. In the super-resolved flow field, you can see the finer vortex structures. Now that we have the simulation data, we can build an accurate weight model for the site and optimize the placement of each turbine. Thousands of iterations, accelerated by NVIDIA GPUs, are run as part of the optimization to achieve the maximum power output for each farm while minimizing the cost. And the impact is huge. When using NVIDIA Modulus and Omniverse for a typical 1,000 megawatt offshore wind farm, optimization can provide power to supply up to 20,000 additional homes, and to do it at 10% lower cost.
So I'm going to switch topic a little bit. We look at the state of the art of AI. We look at the digital twins. We need the processors to actually able to process the AI and the digital twins itself. One of the challenges in doing that is that we have to take into consideration when we design our systems, the computational speed, the scalability, and the power consumption. As you guys know, actually Moore's laws is actually comes to a standstills. We are not able to keep on increasing the frequency of the processor, and thus we are not able to scale it up any further. We have to look at alternative, right? And you could see over here that over the last period of time, the number of number of flops that require for AIs is growing tremendously. Now, when we look at the artificial intelligence itself, one of the things is that if you just look at deep learning itself, the basic fundamentals of the computation, in actual fact, is a matrix computation. And one of the things is that the GPUs was originally designed for graphics manipulations. It is a matrix computation by default. And this is one of the reasons why the GPU is a perfect fit for matrix computation for AI. Of course, there are many other companies building up AI chips. As you could see over the landscape over here, some of them has already collapsed or disappeared, basically because of the ecosystems, which is extremely important. There are also other approach using, like, for example, like light metal bars, photonics for building up AI processor. NVIDIA research is also experimenting with this kind of technology. Right now, this is a very interesting one where in a company called Cortical in Australia, where they actually uses human brain cells in a dish to learn how to play ping pong faster. And of course, this is connected to a computers, then able to actually play Pong. And this is basically one of the very early version of how a biological and a digital brain can actually works together. Now, as you could guys see that we could took the two different approach. One of them is the standard CPU. The other one is the GPU approach. We have thousands of different cores, very simple cores to do the computation. So our earliest version of it was Fermi, and it's proof that the matrix computation can be accelerated very quickly, as you could see over the graph over here. And because of that, we continue on to build experiment with it, and it could show that on the different types of GPUs, such as the K40s and whatsoever, it continue on to improve in terms of its performance. Now, one of the very important things when we design anything is that we do know that the computations, actual fact is the cost of computation is varies from an 8-bit add to all to a 32 bits DRAM rate. Is the amount of energy used is difference is humongous. 8-bit add is about only 0.03 picojoules, and all the way to a 32-bit read is about 640 picojoules, right? So you do not want to move the data as much as possible, and also you want to use as less bit as possible to do your computation. So one of the things that we learn in deep learning is that, can we actually afford less precision? Do we need to actually use 64-bit? Can we actually reduce down to a much smaller bit? Because of that, we have learned a lot of this. NVIDIA starts to experiment something what we call a tensor core. And basically, it's a 4x4, 16-bit plus a 32 bits. All these things able to compute all in one cycle. And we are able to build hundreds of them in our earlier version of Volta. And you could see that the performance of it against a CPU was humongous, right? And you could see the performance over here using ResNet, and this was the earliest result of it. Now, moving forward very quickly, we have the A100, which was launched a couple of years ago. Increase the number of SM, the bandwidth, whatsoever. But very importantly, again, because of the increased number of cores and able to do matrix computation very quickly, we could see that it can do many of these computation very quickly. We together using tensor core. And in the use of artificial intelligence, again, it has a leaps over water. Now, move forward quickly. We have announced a year ago of our new architecture called the Hopper, and this is a new system where we increase the number of floating point. And very important thing is that we also increase some of the things what we call BF 16, floating point 8, and so forth. And floating point 8 is pretty new. It is a basically, if you think of it, is that basically doing floating point in 8 computation, and you have 2 different formats. One is called E5M2, and then the other one is called the E4M3. Each of them can be used for different purpose in area of in the area of artificial intelligence or deep learning. Let me just skip on it too much quickly. There's something that we have inside the Hopper is called the transformer engine. The transformer engine basically is that if we able to recognize and look at the statistically look at the algorithm was running to see that it is a very transformer-like, automatically it will run on the transformer engine itself, which means that it will run very fast using the tensor core, using the new FP8 and so forth. As you can see over here, this is basically a graph showing the perplexity of it versus the thing. And you can see that there is not much difference between the FP8 and the FP16 performance. So together with that, we could actually increase the number of SM by about 1.2 times. The new tensor core, the transformer engine increase in frequency. We're actually able to design a new processor that's almost 6 times as powerful as the A100. So this is the new technology that NVIDIA is driving. Now, the challenges in going forward is that we see a lot of challenges in artificial intelligence. These are challenges that you guys are able to recognize. Data labeling, limited amount of data, and so forth. One of the challenges that NVIDIA want to solve is actual fact in the area of climate science. Now, as some of you may have solved work on climate science problem. At the moment right now, we are doing a computation on the planet Earth at about 1 kilometers resolution. With the current high performance computing or supercomputer in the world, there is things we like Summit, which is a 10,000 GPUs system. Now, in order for us to reduce the resolutions to 100 meters, we need a compute systems of about 10,000 times. Because don't forget, it is a 3-dimensional thing, plus a lot of new physics that's coming in or whatever. If we want to do a 1 meter resolution, which means that we need a system of 1 billion. And this is not possible because just by leveraging on the semiconductors, it is not possible to do a digital twins of the planet Earth based on the semiconductor technology. So we need to look at new way of doing it. One of the things is that we are looking at using the earlier I mentioned before, using pins, physics-informed neural network. One of the things we are also looking at using Fourier operators, neural operators, and the combination of Fourier neural operators, things like forecast nets to do all these things. We have to look at new math to do this. So we need new math. We need new neural network algorithms to do things in order for us to actually improve or rather able to accelerate those problems to a billion times faster than what is it current right now. We cannot base on the current semiconductor technology. So NVIDIA right now is working on many various front of it. And let me show you one of the videos that what we are working on.
High-resolution weather simulations, as provided by DKRZ's ICON code, and vast amounts of observational data, allows us to determine the state of the Earth with unprecedented fidelity. But exploring and working with this data can be a challenge. Technologies like the NVIDIA Omniverse ParaView connector allow scientists to interactively analyze weather and climate data in 3D, to combine information from multiple sources, and to explore what-if scenarios. This takes us ever closer to a realistic, interactive digital twin of the Earth. Let's look at 2 examples. In August 2019, Hurricane Dorian developed into a massive Category 5 hurricane, causing over $5 billion in damage in the Bahamas and the southeastern US, with sustained winds of 185 miles per hour. Viewing high-resolution simulations like these integrated forecasting system simulations in Omniverse allows scientists to analyze the behavior of storms such as this in detail, interactively, and in full 3D. This not only aids in understanding the physics of weather systems, but also allows inaccuracies in models to be identified and refined. With the Omniverse ParaView connector, visualization modalities of ParaView, like streamlines, become available within Omniverse and can leverage the RTX renderer or be fused with data from other sources. These sources can be static or computed on demand, such as mapping service, surrogate model, or an AI-informed physical model. Here we show AI-based image segmentation of satellite data, which was used to detect flooded areas and to classify land use before and after Dorian hit. The network performing the segmentation can run as a service and be triggered on demand. Once we have interactive access to all this Earth science data, a next step is to play through different scenarios. On-demand evaluation of surrogate models or access to real-time physics engines can help exploring the impact of our actions in this virtual world. With access to real-time physics models as enabled by Omniverse, we can not only explore pre-computed data, but also simulate on the fly. Here, we use real-time fluid dynamics simulation to show the vapor plume emerging from a cooling tower. A user can quickly explore the impact of the plume, depending on the wind conditions or the steam output. Similar models can be used to interactively explore the dispersion of aerosols or contaminants. NVIDIA Omniverse is a powerful platform for massive-scale digital twin simulation. We're excited to see where it takes us next.
So with that, I end my presentations. Thank you very much.
Thank you, Professor Simon, for a very interesting talk. So we'll see if there are any questions from the audience for Professor Simon. So please go ahead.
Any questions? Thank you, Professor, for the fantastic talk. So I just want to ask about that topic of scalability. So we know that right now we need lot of power, lot of memory to to run these neural networks, right? So now if we are talking about working in mobile platforms, we need to reduce the parameters, right? And one of the topics that you touched upon is that can we also look into from this point of view of accuracy if we can make it lesser? Like let's say if we have a pre-trained network, then if we want to let's say make it work in a mobile platform or edge devices, right? We need to what do you call it? In CNN also we need to remove the filters, right? So how do I know what will be the impact of these removal of filters in terms of accuracy? How we can map this up? And we know right now there are many methods to do it, but mathematically still it is very unknown how these parameters are connected to the accuracy of the system over there. So do you have any comment on that? Thank you.
Oh, this is a very good questions. I come from applied mathematics background, and I must tell you that I share the same frustration as you do. That a lot of this thing right now is all empirical. We experiment with it using different. There are, of course, like you say, there are different methods. We experiment with it, and we think that such a methods would able to think, but it's no guarantee. There's no upper bound, there's no lower bound. We do not know whether this thing will work on different type of applications. This method will work on different type of application until we experiment with it. Even when we experiment with it, we do not know when it will fail, right? So this is something that is challenging because we do not, at the moment right now, there's still not enough mathematical foundation for understanding the neural network. And that's one of the reasons why in my tech centers, we are now initiating a globally with various researchers. And for those professors who are interested in this audience, would like to join us, is to collaborate and study about the foundation of deep learning, the mathematical foundation of deep learning, from the Gaussian processors within inside there, the smoothness, the consistencies, and the expressibility, and all the other characteristics of the deep learning. Study it mathematically. And I think this is one of the areas that we need to put in effort to actually study those things. Does that answer your question?
Yeah, thank you. Thank you, Professor Simon. Any other questions? Okay, in that case, okay, there is one more question.
Thank you, Professor, for this nice talk. So you mentioned data transfer is an overhead for today's data centers, and I've seen 60 to 70% energy is wasting on the data transfer. So people have tried to put those cores close to the memory, Cortex core and all that. So how do you see this proposed transformer engine? Is it can it be integrated close to memory in terms of area, power, and thermal budget?
Well, not at the moment right now. The transformer engine is actually built inside the GPU processor itself. As you would know, the GPU processors is actual fact is we use a HBM memory to sit on top of the GPU, so that we have very high speed transfer from the GPU memories into that. But that is very, very limited, because basically you have a limited of at the moment right now we are looking at 80 gig and maybe larger. But as you know, there'll be bigger model will require bigger memory. So when we require bigger memory, you need to actually fact connect to another set of memory or GPUs that connect to it. NVIDIA have done something what we call NVLink, and basically is for the GPU to GPU communications that allow you to actually transfer the data between GPUs. That would reduce the latency, increase the bandwidth, and that improve the performance. But it does not, and I might state that it does not remove the needs for memory data transfer between them. We need to look at new algorithms. We need to look at new ways of doing it. How do we actually fact make sure that the data are being reused more and more often, so that we can reduce the amount of data that's being transferred. So that is my answer right now.
Okay, thank you.
So let me then thank again Professor Simon for this interesting talk.
Thank you.
Thank you.
Thank you, Manish. So now I invite Dr. Gaurav to introduce our speaker of the second keynote talk that will be delivered by Mr. Pradeep Khanna. So, Dr. Gaurav, please.
Yeah, good morning to all of you. It is indeed my pleasure and privilege to introduce our next speaker of the day, Shri Pradeep Khanna ji. He is the CEO of Global Mindset and having multiple global roles in the Metaverse and XR ecosystem. He is also Global Co-Chair Education for the Global Virtual Reality and the Augmented Reality Association. He is also an advisory board member of Global Metaverse Fashion Council. Pradeep ji has more than 30 years of executive experience and has been a leader for IBM Australia and New Zealand. He is adjunct professor in various universities across Australia and Asia. Pradeep ji is also co-founder of a social enterprise named In Square and convener for global chapters and emerging technologies for IIT Delhi Alumni Association. Pardeep ji is also on the advisory board of a number of companies. And again, with this note, I will not take much time, and I would like to invite Professor Shri Pardeep Khanna ji on the dais to deliver the next keynote lecture. Pardeep ji, please.
Gauravji.
Thank you very much, Gaurav.
Okay, so I would like to first invite Professor Jain just to give a Professor Jain to facilitate the speaker.
Folks, from the world of transformer algorithms and computational power, let me get you back to Earth. Virtual reality, augmented reality, and when I speak at conferences, I do quite a lot, but 2 or 3 times a week. On average, 75% people do not even know that so there is just at the top people. Evangelists. Leading the drive to the Metaverse. And I want to kickstart the discussion today by getting you to October 2022. Sorry, 2021. What happened? Any idea? And this is related to XR. And there's a chocolate also. Mind you, if you give me indirect answer, you have to give me 2 no. What happened in regard to XR in October 2021? Something happened with it? What did? What happened? Well, I can't give you Slides engine. He or she has to give the answer. Fast enough. So that is what happened. Facebook rebranded as Meta. And soon Metaverse was in our life. Everybody wanted to know what a Metaverse is. What a Metaverse is, I can speak louder. What a Metaverse is, even cats and dogs, as I mentioned here. So, is the deck ready? Oh, fabulous. How do I get this onto the main screen? No?
They will get it.
Oh, they'll get it. Okay. So that was October 2021. And fast forward to October 2022. What was happening to Facebook? Facebook's stock price had dropped from $365 to $93. Their market capitalization was down from $1 trillion to less than $300 million. Sorry, $300 billion. Okay, this is just one insight. Let's look at what else was happening.
We see investment in AR, VR over a 12-month period drops to less than half. Meta stock price we've already discovered. Crypto market cap drops from, wow, $3 trillion to less than $1 trillion, 1/3. So is the metaverse dead? So let me ask you a question. Which country in the world is now going to be reborn in the metaverse? I'll give you a hint. It starts with T. Come on. You can't Google. Make a guess. Okay, I'll give you an easier question. When did the first wedding happen in VR? And was the wedding kiss real or virtual? Make a guess. Okay, I'll tell you it was in 2017. You only have to say the month. I'll give you another hint. It was in the first half of the year. There are only 6 months in the first half. Come on, folks. Who said May? So 25th May 2017 was the first wedding in the metaverse. And how did they get married? Their avatars got married. But the wedding kiss was real. So while we look at all these challenging times as we may see it, these are the companies who are active in the metaverse. And this is just a sample. And I know that you can't read it. And that's exactly the purpose. So that there's so many of them. Today, it will be difficult to find a company which is not having a play in the metaverse. There are 3 categories of companies which are operating over there. One, which are building metaverses. Number 2, who are engaging in the metaverses. And number 3, who are helping companies and individuals to engage in the metaverse. This is industry sectors where more than 5% are heavily involved in. Now, look at which is number 2, education. This is where the world is heading to. While the shape of the metaverse may become clear only in about 5 to 6 years' time, there is no agreement also onto the definition of the metaverse today. But the journey has already commenced. There is a massive amount of investment which is currently flowing into the metaverse. This is the country, Tuvalu. Even I had not heard about the country before until it reimagined itself in the metaverse. It's a small country. Area is 9.9 square miles and population of 10,400 people. You know. But yes, it's a country. How many of you are active on Robotics? 1, 2, 3. The monthly active users on Robotics are 200 million. 40% of US's youth below the age of 16 are in Robotics. And what is Robotics? It's a gaming platform. And look at in comparison, how many monthly active users does Facebook have? 200K. 200,000 as compared to 200 million by Roberts. This is what is happening in the metaverse. There are three companies that you can see: Horizon, which is Facebook, Sandbox, and Roblox, which are making waves. Forecast by McKinsey's that on average we will be spending 4 hours in the metaverse in 5 years' time. This will vary across different demographics. Obviously, the baby boomers, people who were born after Second World War, after 1945, people like me, will be spending maybe 1.5 hours. But the younger ones, 4.7 hours. Another survey by Gartner, 25% of the people will be spending time or engaging with the metaverse in 5 years' time. So is this the diamond rush or the gold rush? Well, who knows? I think it's time now to come back to basics and to look at how does AR, VR fit into the metaverse. In the good old days, we all knew there was something called augmented reality, there was something called virtual reality. Metaverse was, yes, defined in 1992, but after that, nobody thought much about it, except for a couple of movies which covered the metaverse. It was only during COVID times, when all of us were spending time in technology platforms, that the big tech rediscovered the metaverse. One of the challenges that I face when speaking is always to identify what is the level of knowledge of VR, AR of the audience. And there are multiple ways to look at the knowledge span. So I do spend a little bit of time going back to basics. And I'm sure that all of you know the difference between AR and VR. But I'll simply just walk you through some of the basic concepts. Let's look at that VR now in the real world. I am standing in front of you and talking to you. And let's look at landing on Mars. Can we do that physically? No, we cannot do it physically. So we have a virtual environment. And that is virtual reality at the other end. This is the academic environment. Let me give you another analogy. If I was talking to you in a classroom, this would be face-to-face learning. And what you were doing during COVID times was online learning. That's similar to real world and the virtual world. And the in-between world in the learning environment is called blended learning. Why it is called blended learning? Because it is some combination of the real and the virtual world. Likewise, the spectrum in between the real and the virtual world is called mixed reality, because it is some combination of the real world and the digital world. So we've understood what is VR, but what is AR, augmented reality? Who can help me now? Can anybody explain what is augmented reality? Yes, young lady over there. You? Yes. So I will give you 78.634%, Over to you. A chocolate also? So I'll give you 98.645%. Yes. I'll give you 34.35%. But anyway, now we had enough. Let's get back. As the gentleman and this girl said, augmented reality is when you're augmenting, when you're adding in the real world. Let me give you an example. You are going from IIT Jodhpur to the city. You don't know the way. You put on your GPS and you follow the GPS. Let me give you another situation where while you're driving, on your windscreen, that directions come. Now, what you're doing is you're augmenting digital objects in the real world. That is an example of augmented reality. So, now herein came the confusion. Then what is the difference between mixed reality and augmented reality? So mixed reality was any point in the spectrum. And there are quite a few points in that with different combinations. But the confusion continued. So then people decided that why don't we just call it XR, extended reality. So that, anything which comes under some other real reality or virtual reality or anything, we just put it under the broad name of XR. From XR, we have now moved on to the metaverse. This gives you actually the different spectrums. The immersive world starts with 360. What is 360? Who can explain me what is 360? Yes. So I give you minus 0.46%. But by the way, did I give you the chocolate for the last question or no? Now, .360 is the span that you have taken a shot from a 360-degree camera. And that's exactly as the word says, you're taking a span, photographic span, across 360 degrees. That is stage one of immersive experience. On the other hand, you have multi-sensory immersive experiences. Today, we are talking about mostly visual and to a certain extent audio experiences. But what about touch, haptics? What about taste? What about smell? Oh, there's a lot of work which is happening in all this. And that is where we're heading towards in terms of multi-sensory experiences. And in between, you got, VR, AR, and there's also a whole lot of other ones, but I don't want to, go down to that level. But this is broadly what the spectrum is. In my discussions yesterday over dinner, some people asked me about how do you access VR and AR, So at the bottommost level is what we call as mobile VR. If you remember, there used to be something called Google Cardboard. Now maybe costing 10, 20 rupees or something like that. You used to put your mobile phone in that. That was the cheapest level and the lowest level how you access virtual reality. Next level was again mobile VR by a device most popular called Samsung Gear VR at $100. Again, a mobile VR experience, which means that the processing power is also within the mobile phone. One step up is a standalone VR device like Oculus Quest 2, where the processor and the visual are both in a single device. And at the highest level is desktop VR, where you've got a separate PC or a laptop, and you've got a separate head-mounted device, and that is the upper end and can cost more than $2,000 US. And of course, you've got another variant, which is web VR. Likewise, in the case of augmented reality, the base is mobile or tablet, where all you've got is an app, and you scan a QR code, and a digital image or digital objects come in front of you. Next stage after that is a smart glass. And the smart glass is going to be the holy grail insofar as immersive experiences are concerned. Over time to come, it will replace our mobile phone as a primary communication device. But we are still far away from getting a good smart glass. So giving you the same example when you're driving, so you will be having smart glass like this, and you'll be able to see the directions through your smart glass on the windscreen. And then, of course, you have the full-blown HoloLens by Microsoft. They call it mixed reality, but it is nothing but an augmented reality device. And just like web VR, you also have web AR. Now, let's look at the ecosystem insofar as VR, AR, XR, Metaverse, etc. are concerned. There are different ways to look at it. One is to look at who are the different stakeholders. Industry, academia, government. But there's yet another way to look at it. That is, from a business perspective, from a technology perspective, and from a design perspective. And the business, I also include consumer. And what I mean by business is the actual user, who's only interested in the functionality and not so much in terms of how technology is kind of developing and so on and so forth, or how is UX or UI being kind of designed, or how is the content being designed. The third is, and this is again a follow through of a kind of discussion that I was having last night when people asked me some of the questions on these. From a solution provider perspective, you will have hardware, you'll have software, you'll have rendering engines, Unity, Unreal, etc. You'll have platforms, content, apps, etc., etc. Now, the word platform, yesterday I had a lot of questions about the platform, but every content provider today calls themselves a platform provider. So you have to go into the next level of what do you mean as to what all are the services that you are delivering. Also to get a perspective of the ecosystem, especially from a solution provider perspective, it's a very fragmented ecosystem. In India alone, there are 3,000 entities in the VR AR ecosystem, out of which 80% of them are startups. 75% of them tend to be bootstrapped. And look at some of the numbers. In Australia, there are 1,500 companies. In Korea, there are 1,000 or 1,500 companies. In India, there are 3,000. In China, there are 4,000. That's the kind of ecosystem. But the challenge is nobody knows these people outside the niche that they are operating. It's a very opaque world at the moment. It's a bit like the Wild West. Yesterday at dinner time, again, somebody asked me, is there a catalog that I can see for health offerings, there is no catalog. It is still an emerging tech. So this is in summary where we have gone from AR, VR to the metaverse. Like I said, that metaverse has been around since 1992, has been rediscovered. And at the moment, there's no agreement that what does metaverse really mean? And some of the perspectives are that is it just the digital world which is overlaying the physical world? Or is it the digital world and the physical world both taken together? And there are a whole lot of other questions to play. When we look at what is happening with Facebooks and Microsoft and Nvidia and so on and so forth, everybody is building their own metaverse, which you can call as mini metaverses. So do we define metaverses sum total of all these mini metaverses? Hang on a sec then. What happens to Web 3.0, where we are talking in terms of data decentralization? So what is going to happen in the way forward? It's a big question. All of these are going to exist. But interoperability between the various systems will become the key. Standards, taxonomy are still developing. Some of the issues which are there in the case of VR get amplified many times. Issues like cybersecurity, sense of isolation. There are so many such kind of issues. It's not just a hunky-dory, brave new world. But there are people in the world at the moment who are talking, discussing to look at this kind of, there's research happening all over the world in this. And as we discussed also in the earlier presentation, the reality is that we will need much more stronger computational power. Maybe quantum computing. We are talking today of 5G because of latency, etc. But the reality is that for a metaverse experience, we will have to go to possibly 6G. So there's a whole lot of hardware developments which have to happen for metaverse to become a reality. Now, let's have a look at what are the building blocks of a metaverse. Metaverse today has now broadly been classified as a basket of emerging technologies. And there are various, as with so many definitions, there are various value chains of the metaverse at the moment. But broadly, it consists of all these emerging technologies. So when we talk in terms of a center of excellence insofar as metaverse is concerned, that it needs to have offerings related to all of these. That means separate entities which are operating in emerging technologies now need to blend together in an integrated manner and looking at it from business, technology, and design perspectives. At the infrastructure level, you have Web 3.0, blockchain 3.0, 5G or higher. But there is a very, very strong component of gaming coming through, which my friend over here, Rajat Ocha, will also talk about it later on. And we'll also look at why that is becoming important. But also, what about commercial activities? Now, NFTs are becoming the drivers for commercial activities within the metaverse. And of course, experience centers. Because whatever the value chain, the bottommost layer will always be infrastructure and the topmost layer will always be experience. Now, moving on to, we looked at what are the industries which are having a good take-up of VR, AR, Metaverse. My next question is that which was the first university which started offering or which had a class in VR? And I'll give you a hint. It was in Canada. So, any guesses or any answers? Which one? No. Okay, I'll even tell you the university. It was University of British Columbia. Any thoughts about which course was it? No, this is much earlier. But it's a very, very subject that you wouldn't normally think about, you know. No. It is in the arts domain. I start with L. No. Okay, LA. No. There's a chocolate. Quickly. No. So it can be either, next word can be either G or W. So it was law. And next question is, which university in the world is at the moment offering a course to be delivered in VR? I'll give you a hint. It is in the US. I'll give you another hint. It is in the West Coast. MIT is on the East Coast. It's in Boston. Not Caltech. But it is in California. Incorrect. So not too many are left. Come on, guys. Yes. So Stanford is now offering a communication course in VR. So I've taken an example of education and training because we are in an academic environment. So where all is VR, AR, Metaverse applied? First and foremost is, okay, I've just given in this, what are the various components of education? When we look at education and training as a bucket, you've got K to 12, school education, you got higher education, you got early childhood learning, and you got the skill side. Now, if you were to look at how to club these together, education really is K to 12 and higher education. Of course, I'm not referring to the new education policy where you can get linkages all over. But in the conventional sense, this is what we are talking in terms of the education world. That is high school, K to 12, and higher education. While education and training have the second highest takeover, training is much ahead of education. When we look at education, you can have application of VR, AR, Metaverse in blending with pedagogy, which means in terms of teaching. You are using virtual reality, augmented reality, Metaverse for teaching different subjects. Just like Stanford is doing in the case of communication, just like UBC did in the case of law. Number two is research, which our lovely friends over here are doing quite a bit. Number three is in building up a lab or a studio. Number four is in teaching VR AR skills like Unity, Unreal, 3D modeling, UX, UI, and the likes. And number five is in teacher training or faculty training. There are many, many more use cases, but these are the most popular ones. So when we look at an integrated approach of a higher education institution, it has to blend, like in the case of IIT Jodhpur, it has to blend iDrishti Hub purely because 80% of the content providers tend to be startups. It needs to blend all of these elements over there. But not only just as a separate VR AR offering, but there should be a process of articulation that anybody doing anything can take a subject of this thing of relevance for this kind of a stuff. And all of these should have heavy industry involvement because so that there is no mismatch between jobs and skills. When we look at training, and I'll give you a very simple example. Let's say that we are teaching people or training people how to lift a log, a heavy log, properly. That is, you've got to harness it on both sides. And what happens if the harness breaks? Now, that is a very, very clear example of why skills training is so easily adaptable in the AR VR environment. So what about onboarding, especially in global organizations? In the pandemic, Accenture bought 60,000 head-mounted devices. All their employees all over the world were onboarded using VR. Regulatory training, like in the case of pandemic. If you wanted people to follow the COVID norms, what better way than going through VR, AR? Soft skills training, DIY is do it yourself. You buy something from IKEA, you have to assemble the table. Now, I know that once when I bought that computer table for my home, I was struggling for about 4 hours, where to put what screw and all that kind of a thing. But if there was, and again, there's a very, very simple example. In the COVID times, somebody, a Pune-based company, came out with a AR simple application of how to use an oxygen cylinder. Now, just imagine that if the app was very popular. So these are just very, very simple examples of how it can impact at the layman's world where we can make a difference. Manufacturing training, maintenance training, oil rigs. You got oil rigs and something goes wrong over there, and you require electrical skills, mechanical skills, different kind of skills, but the cost involved, the skills available, when you send somebody across, he may not be able to solve the problem. So simply by remote access, he can be provided support from 3,000 kilometers to 4,000 kilometers by using AR. So these are some of the advantages that why we use these is in those environments where the cost is very high, the risk is very high. And let me tell you that if you were to train firefighters in fighting fires, how can you do that? One is in a classroom setting. Second is by getting them to watch YouTubes. Third is by getting them to actually go and fight fires. But can you do that? They'll burn themselves. But how about getting them to do it in VR? So these are some of the high-risk environments. Like other ones, like I mentioned, was in the case of landing on Mars or moons. These are, possibly not possible or very expensive. So these are cases, where it's a no-brainer to use immersive technologies. This is very interesting. This is the forgetting curve. Our attention span is 8 seconds at this particular point in time. And this is as per Microsoft, and I don't know, it may be 9.5 or 10, I don't know, but it's not that order. Our brain keeps oscillating of, wavering at different. As per established research, information is quickly forgotten 56% in 1 hour, 66% in a day, and 75% over a week. On the other hand, you've got this 70-20-10 rule of learning, where 70% of the learning happens outside the class, where you're doing things yourself. 20% happens when you're collaborating with others. Only 10% learning happens in the class. So in a VR environment, you're actually doing things yourself. And that is why when you combine the forgetting principle along with the 70-20-10 rule, you can see the power of immersive technologies. And this is also borne out by research. This is a World Bank report. And you can download it or read it from the web link which is given over there with clear statistics in terms of what is the benefit in terms of using immersive technologies. Now comes the gaming perspective. Do you know that in the metaverse today, the fastest take-up is happening in consumer gaming and entertainment? The world has a population of now 8 billion people. Do you know how many gamers are there? It's 38 point some percentage. 3 billion people are gamers. It doesn't mean that 3 people are hardcore gamers, but 3 billion people are involved in gaming in some form or shape or the other. Even in India, the number of gamers in a population of 1.4 billion is estimated to be somewhere between 300 million to 400 million. That is a large number. So there is a very big impact of gaming which is coming through, because gaming is by nature, they have been used to the metaverses, the avatars and all that kind of a thing, and they're a natural fit. So that is why you're finding such a big link up in terms of gaming and the metaverse and the consumer and entertainment. Now, this is where a lot of discussion has been happening on chat GPI and so forth. Now, the thing is not so much in terms of the AI, but it is AI, that element of AI which is called generative AI, which means that you are going into creative content. You are creating a image from a text, you are creating a video from a text. So that means all what we thought was not in the realm of AI is now happening. And just as an example, this is what the current range of avatars is. All these cartoonish kind of, figures that you see over there. But the real difference comes in when you have photorealistic avatars, which means that, what I look like is what my avatar looks like. And that's already happening. There is Ready Player One, but I mean, there are so many engines at this particular point in time for photorealistic avatars. But more important than then, along with that, is the rise of what we call as digital influencers. Now, what are influencers? Now, they are all the people who have a bearing on, or they have an impact on large number of people by their style or their way of thinking and so on and so forth. But imagine that if you knew that somebody, this is not a real person, but a digital, can that person be can we have digital influencers? And my answer is yes, and I'll show you examples, but my question is, do you know which is the most famous Indian digital influencer? Yes, absolutely right. Can you come forward, because it's too far to throw? The chocolate. No, it is. I've got the chocolates only for this purpose. So Kyra is the most famous Indian digital influencer, but not the first one. And let me walk you through who are the other ones. Oh, really? Oh, lovely. Very good. You should connect up. So Lynn McKellar in the US is the first known digital influencer, was created in 2016, and in February 2022 had 3.1 million followers. But it's not only US. Here you have this is Kyra. This is the Indian digital influencer. And I often wonder that why did they have to create, when we've got 1.4 billion people? Well, couldn't they find somebody to be, and do you know that there is no real person by the name of Kyra? This is totally generative AI. And this already had in June 22, 100,000 followers, And this is what we have talked of already in terms of generative AI. Cybersecurity. This is the biggest bugger. Can you tell me that if you were to take out all cyber crimes, what? Oh man, the answer is given over here, so I can't ask the question. So the value of all cyber crimes is $6 trillion. That means it is the third biggest economy after USA and China. That is the scale that we are talking about in terms of cybercrime. And this gets amplified n number of times when we talk about using IoTs, when we talk of using 5Gs, when we talk in terms of using the metaverse. The deepfakes in the metaverse are just a prime example of somebody taking on somebody's identity. But why IoTs and why 5G is because the large 5G works on small cells. And all of these massively increase the number of devices connected to the network. And the risk profile jumps up like this. So this is one of the biggest issues, but not only cybercrime, but safety. There are so many issues which are kind of merging insofar as this particular aspect in the metaverse is concerned. Sustainability. We briefly touched upon this yesterday in the case of AI. And this is where it is, This is the graph, and you can see in terms of electricity generation by data centers. And this does not take into account the metaverse. This was made before the metaverse. Imagine the number of data centers that you're adding on for getting the metaverse experience. The energy consumption is becoming absolutely massive. And also to summarize that, you see, when we talk of sustainability, it is not just about climate change. It is about all these 18 UN SDGs. We talk primarily in terms of that climate change because that is impacting us. But when we talk in terms of sustainability, we have to look at all these factors or all these goals in the overall metaverse equation. Also, just imagine what happens to e-waste. What happens to all your devices? You are multiplying the devices n number of times. How do you dispose them of? These are some of the challenges from a sustainability perspective from the metaverse. And in terms of way forward, as I mentioned earlier also, it is moving towards multi-sensory immersion. There is a lot of work which is happening, especially in the case of, so for example, smell. Just like you have printer cartridges, you've got different smell cartridges. But you need another device to put on your nose with those different cartridges. So what happens? You got a device for seeing, you got a device for smelling, and how many devices will you have, But work is happening. Haptics has matured quite well. We've got jackets today, we've got a whole lot of this thing. In 2016, I was in University of California at San Diego when I saw that in their lab, if you went into the VR environment, you put on a glove, there was a piano which came up, and when you touch the piano, you would get a sensation. I'm talking of 6 years back. Today, haptics has progressed fabulously well. And the recent discussions that we have seen about crypto, I think the central bank currencies will play an important role insofar as financial transactions in the metaverse are concerned. So these are some of the future trends as we head towards the metaverse, which will get discussed or sorted out. And I think that is the end of my session today. So, folks, I still got some couple of chocolates, and I've still got a lot of questions, but it's okay. I've passed my time. So tell me any questions, further questions you have, and now you get a chocolate for asking a question. Come on, you don't even want a chocolate. Come on, what about you? Yes, you. That is a very, very good question. And just like the AI and just like the GDPR kind of discussions, there are a number of discussions happening, but it will take time to evolve because at the moment there is no agreed taxonomy on photo metaverses. So These things are already very well flagged and big question marks, but unresolved at the moment, but will get resolved in the next about, what, 6 years or so? Because I estimate the time for the metaverse is somewhere around, you see, you've got to remember that there are different demographics. Now, people who are below the age of 16 at the moment, 50% of them are on Roblox. They are the digital natives. Now, in 6 years' time, they will be 20 plus. They'll be earning, well, they're making more money in Roblox now than they could have possibly made, when they start earning. But that is the rise of the digital native, which will really take the metaverse to the next level. People like me will be just kind of, trying to fumble around and see, what is this, what is that, and worry about safety, etc. But these people have gone ahead. But to answer your question, it'll take about 6 years or so for metaverse to take some form and shape. So here's the chocolate for your question, and I can see that there are, yes.
I'm Sri Prakash Tiwari, and actually my question is only for chocolate. This some somehow when I see AI and metaverse whatnot, what I see people are so much into their devices and data and everything. Very common intelligence is lost actually. The way we communicate, the way we walk. Right now I'm listening to talk and still trying to do certain things. Moreover, as you mentioned, I have a very small laptop, but I have a connector which has a big pen drive and so on. So what I'm seeing, it's more like there are many things which AI is certainly taking care of, but there are areas when you talk about sustainability, and many times whenever I travel in this ATR 72, I'm actually scared like anything. And what I see the technology in that direction, like jet engines, or even air control and so on, they are not progressing the way like you see from say probably 80s to 2000 there was no development in engines and maybe some kind of more cosmetic kind of things, software kind of things have developed. So I don't know whether these AI and anything which is related to data can actually help to invent some of those technology like the engines, the way they are made. Most of the times when you see they are very old, like 20, 30 years, there is nothing happening in that direction. So what is your opinion
So I'll tell you,
on these things? Yes.
There are a couple of aspects that you mentioned in your comment. Some of them are very, very to the point. And this, I want to give you another example. That a couple of years back, I was interviewed by ABC TV. And on TV, they asked me a question that will there be a time when India will be outsourcing to Australia? So I responded by saying, at that particular point in time, the New Zealand wages were about 30% lower than Australia. So I said that it is not a question of whether country A or country B is outsourcing. It's a question of where is the value being driven to the customer. Wherever it makes sense, so will it happen. And after that, I got, maybe about 900 emails, by different people, either banging me or somebody complimenting me. And one, there was a long email saying, you must be working for Indian companies, and that is why you are saying all this kind of stuff, So I replied in one simple sense, I said that, look, I don't make mega trends. I can only help you solve the mega trends. So, or manage the mega trends. So the question that you are asking me, number one is, you see, this is one of the concerns that we have at the moment is that the metaverse movement is being led by big tech. It should be led by the community. So there is a big, asymmetry in the marketplace at the moment, but the amount of dollars which are flowing in are going to make it tip. Now, the second part of your question was, will they help? Of course, they will help. But the thing is that the cost benefit analysis and what is really happening, we are all losing that physical, aspect of our lives. So, yes, but the question is, look at the digital natives, look at the future. So, we might become the old foggies, but those guys love it, So, that you go to Philippines, you go to Vietnam. I mean, there are people just making a lot of money and careers today, by gaming. So the whole world is changing. Value of higher education is coming into question.
Yeah, correct. And a second question is in fact very small question.
That doesn't mean you get 2 chocolates, huh?
Actually, I wanted to get, but anyway, that's fine. I'll be satisfied with one. Second question is more like many times unknowingly we are losing control of many things. So day before yesterday, I got one message. Generally, I don't put money in this my Paytm, but he said that 8.99. Thanks for recharging this Amazon Prime. And I had never done it. I had never said yes. And probably last time I might have clicked it. Now, how to control these are not only security and privacy issues, but something we have lost control on these things. So
see,
many.
You are again. That's why I mentioned to you that cybercrime is $6 trillion economy. Do you know recently the second largest telecommunication provider in Australia called Optus was hacked, and the personal records of 10 million people were stolen. Now, 10 million is a large number, but put it into context, Australia's population is only 25 million. That means 40% of Australia's population's data is stolen. And you can find it on the dark web. So, I mean, this is a very, very big business. So it is very difficult. I get, maybe about 10 messages or emails, telling me this is this draft and that is, this money, somebody has deposited that money and all this. And I know that is fake. My first response is that, I just look at who's the sender and just delete it straight off my computer, I cannot answer your question, but this is a big, big issue, And here's the chocolate, Come, please. Yes.
So my question is related to augmented reality or virtual reality, the way it is going, and a lot of learning is in virtual labs today. So will the actual labs perish in due course, or how do you see?
In 2017, I was speaking at a conference in New Delhi, and the Telangana Education Secretary was in the audience. He came up to me at that particular point in time, and he said, I don't have money to build labs. How can I use VR for building labs? So you are absolutely right that yes. But you see now, which labs, I think over time, all the labs will get disappeared, But that timeline, I can't say. And being a futurist is a mug game, but you're absolutely right.
But skilling is actually doing, if it is in the virtual lab, is it equivalent to the actual
Absolutely.
skilling?
I'll give you an example that you see somebody who has, let's say, a physical issue. Now, when you say, how does the occupational therapist treat that person? They get them to extend themselves slowly by slowly, like if you got to lift little by little so that your muscles start coming back, But in the VR environment, you can do it without causing any damage to the person. Dementia. Somebody who, people who are undergoing dementia. What about the carers for those people with dementia? How do they understand that a person with dementia, what is he going through? Fabulous example of how you can use VR. Even for the patient, for the doctors. Yesterday, I was talking to somebody, a girl who was a dentist from AIMS Jodhpur, and now she's doing PhD or something like that in IIT Delhi. And an example that we were discussing, and I was so surprised that she gave me the example of, preparing the patient for giving an injection, The people are so scared about the dental procedures, and this is a very, very documented use case, So there are so many use cases. By the way, Ajay, your chocolate. Thank you. Yes, please. Do you want to give them a mic, please?
Sir, as you have mentioned that it is a need of time that we have to incorporate VR, XR in the areas of high-risk environments. So what could be a better example than a fighter aircraft training, the pilot of a fighter aircraft training? But in such cases, the pilot have to be trained for the G forces, like they have to go to Mach 2 or Mach 2.5 speeds and tremendous acceleration. So their bodies have to be adapt to that acceleration. How can we incorporate VR and XR in such cases?
There are great companies in India who are doing phenomenal work in aircraft simulation training. But training is only one aspect that you gave, but yes, you can get that feeling as the aircraft accelerates kind of a thing in VR without any issue at all. So you have to see or experience these things yourself, and then you will realize what all is happening. Today, Maruti showrooms all over the country today are having a VR experience at the retail outlet. So that is for test driving for potential buyers. But your example, it's one of the early use cases which has been there.
But sir, there are some physical aspects like for going to a speed of 2,500 kilometers per hour. So if we incorporate that without getting that actual experience.
So if you happen to go to Bombay anytime, let me know, and I'll speak to that company, and you'll experience it yourself, and you'll realize there is much better. Like I said, this is that 70, 30, 20, 70 is when you're doing it yourself in the VR environment. There are so many, aircraft aeronautical is a big take up, from a troubleshooting perspective, from maintenance perspective, large number of, we are no longer at the stage where, you see, that is where when I talk in terms of VR, AR, the geography becomes important because different parts of the world are at different stages of take up, So therefore, when I look at when I look at from a global perspective, to me, it's just a question of time, as 5G gets rolled out. We are talking today of 5G in India, but I was speaking in a conference in Seoul in 2017 when they had launched 5G, and today 50% of people in Korea are subscribers of 5G. China, we don't like China, but the reality is that they've got 8 cities which are called VR AR cities. There is a tremendous amount of work which is happening. See, the problem in the whole ecosystem is that it's very opaque. If you're not there, you have no idea what is happening, and there's nobody to help you. Yesterday, I had a doctor who was speaking to me, and he said, that I have this kind of, health and wellness kind of a situation. So I had to tell him that, look, you are at what is called as a concept phase. You have to scope it further to define what the opportunity is. That is a very kind of broad term, because people are just, like I said, 75% people don't even know the difference between AR and VR. Today, the issue is that a lot of people are wondering that, is this a next big thing? If it is, should I jump into it? If I should, then how do I go about it? The biggest challenge at the moment requirement is in terms of education, in terms of front-end consulting, in terms of hand-holding, and also in terms of end-to-end system integration. But we can take the discussion offline, but here's the chocolate, Please come forward. Yes. Yes.
Just in continuation of what he said, he mentioned about experiencing the forces and all.
Yeah.
Is there any progress in the direction of incorporating haptics, like using those pressure models or other sensors like these to?
Haptics is one of the other senses which is progressing very, very fast. There is the second highest take up after visual, and to a certain extent audio. Haptics is next.
So what? Just like he
there
mentioned,
are
the
body
example.
suits. There are so many kind of variables which have come out in regard to haptics. Because in a sense, what you are doing is that you are measuring the force in terms of touch and replicating that force, in the immersive environment.
Exactly.
So a lot happening, and that's another chocolate for you. And thank you very much, Gaurav, that at last moment I told you only at about 10 o'clock last night that I wanted chocolates. Yes, please. That's all right. Then you can give me a chocolate then.
So my question is, as a brain researcher, I am a neuroscientist. I do measure different sensory perceptions. Let me finish with my question. So first of all, I don't believe that what you predicted. I go against your predictions, saying that the labs, which are conventional labs, will persist and stay, along with the labs which are in AR and VR. Second important question is that when we look at human data, or like animal data, non-human primates, we specifically measures these, sensory processing both in behavior and brain in much smaller samples. But the data that you have projected during your talk is a much more large-scale experiments, which involves a lot of variabilities. So my question is that what can the traditional research can learn from AR, VR, or let's say metaverse experience and bring that into the research, which would actually kind of, play a role as a catalyst in order to have a more nuanced insight and understanding in terms of understanding human behavior and brain research, and not just, kind of advanced metaverse itself.
So my response to you that you get 2 chocolates, because that is right. You see, this is where I would expect that, that when it comes to research, it has to be the higher education centers, the research centers who have to take the lead in adopting,
So in US, when I did my postdoctoral work at MIT, in MIT, actually, we already been talking with many industries who would come to the labs and look at essentially what is going on in a cutting edge research inside the labs and how much that can be essentially translated in the industry, specifically the biotech industries in Boston areas. Okay. And this has been not new. It's been there 25 years ago as well. Right?
You're right.
Yeah.
See, VR, AR has been around for the last 25 years. It is in a way like India, like India, right now I see a lot of things happening, but India was always like this, that it has the potential to reach, unleash the power of everybody over there. So same thing with VR, AR, it had the potential, but it's never kind of, taken off. But the Eureka movement, actually the biggest driver was Facebook rebook, because that made people all over the world, the common man, want to know what the metaverse is, So today the curiosity level is very high. And of course, we are going through the usual, innovation hype cycle, but this has gone through so many times. But I can tell you by just looking at the investment level, the journey has commenced. There's no turning back. But the other thing that you mentioned was in terms of brain-computer interface. Now, that is a very, very interesting question for 2 perspectives. One is that it has a lot of ethical, points. But do you know that there are devices available today costing $500 for BCI? And when you look at what Elon Musk is doing with all that, animals and all that, I can't believe, that. And I was asked a question in another conference that, would I like to have that chip in front? And I said, no, please, I don't want that in my brain, I'm okay.
So Pradeep, I think we are running out of time. So we will take the last question from you.
Thank you. Extremely mind-opening lecture.
Yeah.
I've been actually messaging live to my daughter in the US.
So by the way, were you the speaker yesterday?
I was a speaker on the neuromarketing part.
So, I told the other girls that I was just briefly listening to what you were talking about. And this is a very natural fit into what is happening in VR. You guys should look at VR,
So I'll give 2 examples to that. Okay. I run a 200 crore company on a beauty and a salon chain. And we engaged with an IIT Bombay startup which had VR because I want to teach a skill. It's so difficult to teach hairdressing, believe me, because you have to practice on somebody. Okay. And if I cut it wrong, that model or customer is going to really screw me up. So we really went into an IIT Bombay startup and worked on this about 4 or 5 years ago, including somebody from Bangalore on the haptic side, because I also teach massage.
There's a company in Mysore actually is doing pretty good work over there. Yeah.
I'd love to. And this is 4 years ago. I think it became too difficult to scale. First, it's too expensive. 4 years ago, it was still too new, probably. But I know that now that I'm seeing your presentation, I probably have to go back and reopen the discussion because it's far more accessible probably nowadays.
So let me just tell you one thing, that today, I know about 10,000 plus entities all over the world. My first question, and I am meeting new entities every day. And first question when I talk to these people is that, are you generating revenue? Because I know that 75% of them are not doing. I know what is happening in the industry. I know where the money is flowing. So I tell the people that this is not the time for chasing revenue if you can survive, because this is the time for building a brand at this particular point in time, and that is where, guys like you have to take, a lead in that.
Which brings me to the second question I started, which is today I see the number of companies coming into the system. One for the digital youngsters, just being present itself gives you the loyalty. But all the examples you gave are more informational use cases, DIY skill building. How can we use this to really build consumer loyalty over a period of time? And if I pick up his topic, ultimately, are you going to start manipulating the consumer?
That's again a very, very good question, and that gets linked to neuromarketing also. But today, brand engagement is one of the, you see, we have presented sessions with where Rajat has been there in one of the sessions. We've presented sessions with Sony, with Cadbury, with most of these people, how they are engaging, how the brands are engaging with in the metaverse. So it's a this is the one area where there is biggest amount of take up happening. Why? Because they're all targeting Gen Z. And, those what I call as Gen Alpha, which is, born after 2010, or I would call Gen Beta, which are going to be born after 2025.
Yeah. And then if you build loyalty over a period of time, as a business guy, I will look at building loyalty over a period of time.
Nike, etc., are classic examples of what is happening, how they are. But you see, this also goes into a very complex issue of intellectual property. And there is a whole lot of IP issues at the moment. But also, remember that we're talking of an overlaying digital layer. What about sovereign boundaries? How's that going to pan out? They're going to say, oh, no, it's okay. I have a metaverse overall. Or in IP, we have to go country by country. So how are we going to establish an IP regime over there?
Exactly.
Still a lot of work to happen.
How do you sue people? How, as a consumer company, I'll think of how do you sue people? What is legal infringement, IP rights? What's the regulatory in that? Nothing.
So
good. Sorry?
Yeah,
that's why that's the blockchain exists.
Here again, I don't want to get started in the interest of time. You see, because blockchain also smart contracts. What happens? If you infiltrate the smart contract, what about the APIs? I can go on and on kind of a thing. But anyway, in the interest of time, thank you all very much. I enjoyed presenting.
Okay, so thank you. So yeah. So thank you, Pradeep ji, for an enlightening and informative talk. We appreciate having the AR/VR metaverse areas explained and clarified. I think some of the things are clarified to me as well in this particular session. We actually owe you a special vote of thanks. Many of the audience, people sitting in the audience may not know that, but Pradeep ji is visiting India just for this particular event all the way from Australia. So thank you very much. We really appreciate your kind gesture. Now, I would like to request Professor Shantanu Chaudhary to please come on the dais and facilitate the Pradeep ji with a gift as a small token of appreciation from the institute side. एक और मिलेगा. That is for the keynote. That is for the. Yeah, thank you, Pradeep ji, for the very informative keynote. Thank you very much. So now I request everyone to please reassemble again within 15 minutes. So we have the tea break, a very short tea break, and then within 15 minutes we are coming back for the panel discussion. Yeah, sure.
Yeah, so in the panel discussion, we have Khanna sir again and Dr. Rajat Oja. So please keep your questions ready for the panel discussion. So, okay. Thank you. So we'll start in 15 minutes.
जब तक नहीं चलता रोबोटिक्स म्यूट कर।
सही है बाकी तो।
अच्छा भारत
Are you able to hear me?
Yes, we can hear you. Is my voice clear?
please settle down. Okay, so good afternoon, everyone. Welcome back to this second part of this session on AR, VR, and Metaverse. So this is the panel discussion session that we are going to start. So before we start this panel discussion, we would like to present the Institute progress in this area of AR, VR, and Metaverse. So for this, I would like to invite Dr. Amit Bharadwaj to present the Institute progress briefly. So let me introduce Dr. Amit Bharadwaj. Dr. Amit Bharadwaj is a faculty member in the Department of Electrical Engineering at IIT Jodhpur, and he did his PhD from IIT Bombay in 2016, and he works in the area of haptics. So, Dr. Amit, please present the institute progress. Application. Screen
Thanks, Rajan, for the introduction. Now I will just provide what we are doing at IIT Jodhpur in this space, this AR and VR metaverse. We at IIT, Jodhpur has a lot of faculties working in this group, and we have many projects in this space, AR and VR. Some of the projects are listed here. For example, object-based 3D spatial audio rendering for augmented and virtual reality applications, medical simulators for palpation and pulse behavior for medical training, for gaming, that to preserve our culture, to promote our culture, we have developed a game, Vadnagar game project. We are also in the space of mental health. Just started, we have just submitted one proposal in the domain of mental health. It means you applications of AR, VR to for anxiety related issues in mental health. Integration of smell and visual perception for immersive multimodal AR, VR applications. In the space of virtual museum also, we are working in that space, that how to digitize that virtual museums and utilize the technology of AR and VR in that space. And human 3D reconstruction for partial 3D scans and animatable 3D surface reconstruction of large scale scenes. There are many projects there, and we have put many posters outside this room in 309. Interested students can go and visit those posters. Apart from our research activities, we are the first IIT in India that has started this MTech AR and VR program, the School of AI and Data Science, in a collaboration with I Have Drishti. And this is a pan-India program, as we might have presented before the IIT community, that this program has been designed and developed by faculties of many IITs, including IIT Delhi, IIT Bombay, IIT Madras, and IIT Jodhpur, of course, and some industry experts also. We took help from Mr. Pradeep Khanna also in designing that curriculum, and he, it means he was the first one who gave a opening address to our students, that the first batch of 2022. There are some salient features that why we developed this program, that to provide knowledge of AR and VR technology, to develop the ability to cultivate solutions for AR VR systems. And it's a dynamic program. It can be done for 2 years as well as for 3 years. And qualifying degree, it means any, since this AR VR space is multidisciplinary, then you and be taken any discipline is eligible to apply. And this program is for working professionals. And there was one concern for our JRF and SRF, that they just come here and what after their 2 years and 3 years time, that we have incorporated this feature that the students working for internal projects at IIT Jodhpur in the domain of AR and VR, they can also register for a part-time MTech in AR VR space, and then while they are working the project on AR and VR, they will get a degree in MTech in AR VR. If you need any further information about this program, you can contact our Office of School and AID. You can contact me or Dr. Rajan, both are coordinators of the program. These are some details about the project that I have just listed, that what we are trying to develop here. This is a haptic-based medical simulators for abdomen palpation and pulse behavior, that I think 7-8 months ago, in a collaboration with IF Drishti, we had an open house with AIMS, 3-4 AIMS, if I know not wrong, AIMS Mangalagiri, AIMS Jodhpur, and AIMS Delhi. And there was a brainstorming session, and then all the doctors realized that there is a requirement of medical simulators, and that was the doctors felt that let's start with a medical simulator for palpation. And based on that, we have this project funded by I Have Drishti. The team members are listed for each project at the bottom. If you have any questions and need any information, please contact the faculties, the concerned faculties. The one game that we have developed at IIT Jodhpur in a collaboration with IF Drishti. It's a gamification of Vadnagar ASI site. Means to promote our culture, to inform our kids or our young generation about the cultural that how we were and all these things through the games. It means that the protagonist here just explore Vadnagar site and just observe that there is some task for her. While playing the game, she explores and get to know about the Vadnagar. And anyone in the audience, why Vadnagar is famous? It's the birthplace of Prime Minister Modi. Okay, now this project we have recently submitted for the grant. It's a mental games for mental health. Here we want to develop a mental health games. I will not go in the details of statistics. There is a huge opportunity requirement to develop games to tackle anxiety, depression, all these issues. Okay, this is a team led by Dr. Ankita. And if you have any questions related to this space, please contact the concerned faculties. I think before that, I forgot to mention this point, that the game that we develop, it's a classic example of how we collaborate with the industry and government machinery. It was developed by IIT Jodhpur in a collaboration with IF Drishti. NCSM was involved here, ASI was involved here, and industry partner was IF Drishti. That industry part, Vijara. Vijara was industry partner who developed this. We at IIT Jodhpur provided our guidance. Then there was an ISI team and an NCSM team who provided feedback that are we moving in the right direction or not. And this is the way we executed this project. Okay, then Mr. Khanna was explaining about that multimodal sense that we should have in AR VR applications. Then the project led by Professor Chaudhary that we need to incorporate the smell in this AR VR space. We are also working that space, that how to incorporate multimodal senses to develop or to enhance the immersiveness of AR VR application. Now, this we have also done this digitization of museums, in particular Rajasthan. 5 museums we have digitized, and again this was also a joint effort by IIT Jodhpur, from IIT Jodhpur Professor Chaudhary and Dr. Rajendra, in a collaboration with IF Drishti and Vijara and Department of Archaeology and Museum, Rajasthan government. And another project in which Dr. Rajendra is involved, that here it's digitizing the art crafts here through AR, VR and Metaverse. And we will have a demo for this game as well as for this art craft thing in our 309. Please visit our demos to look at this thing for a closer look. We are also working in this in this Metaverse and AR VR space, you need more immersive environments, right? And how to reconstruct better in computer graphics way. Then Dr. Rajendra and his team is working for human 3D surface reconstruction. For more details, please contact the team that mentioned in this slide. Dr. Manish and his team is working to incorporate the sound, spatial sound. It means in AR VR space, you have to incorporate the sound 360, right? That the way that 360 camera that Mr. Khanna was explaining, we should also have 360 sound. And that effect Dr. Manish and his team is incorporating in AR VR space. And Dr. Himanshu's team is working on the problems related to computer vision and video analysis. And it's in this problem, he's trying to detect some object detection through occlusion, in case of occlusion, machine fault detection and classification. That's all from our side. These are the few projects that we have highlighted here. If you please visit our posters and demo for more details, and we all are here to explain and to answer all your queries. Yeah, thank you.
Thank you, Dr. Amit, for presenting the Institute progress. So now we'll actually start this panel discussion. Okay, and for the panel discussion, our panel members are Sri Pradeep Khanna sir. We have Mr. Rajat Oja from Gamitronics. We have Mr. Bharat Kumar Sharma from NVIDIA. We have Dr. Lokesh from Samsung. We have Professor Neeraj Jain, who is a professor at IIT Jodhpur, and our director, Professor Santanu Chaudhary, so who would be joining soon to us. So I cordially invite all of the panel members to please come on the dais to have the panel discussion. Yeah, I think yes. Okay, so so chair उसमें करा दूंगा, I'll introduce कर दूंगा. Okay, so now I would request Dr. Amit to introduce our panelist to the audience. Dr. Amit.
Yeah, thanks, Rajendra. Yeah, let me first introduce our online speakers. Bharat Kumar Sharma is from NVIDIA, has 10 plus years of development and research experience in the domain of software architecture, distributed and parallel computing. He has published papers, journal articles, and books in the field of parallel computing and software architecture. He is currently heading the NVIDIA AI Technology Center, India operations. He has expertise in designing software for non-functional requirements and software migration to latest heterogeneous parallel architectures. We welcome you, Mr. Bharat, here once again. Thank you.
Thanks a lot. You can hear me?
Yes, yeah, we can hear you, yeah.
Okay.
Okay. Next, I will introduce Dr. Lokesh. He's from Samsung. Dr. Lokesh is currently the director and heads XR Group CTO research team, Samsung R&D Bangalore. And prior to it, he was faculty at ENC department, MCRIT. He was visiting faculty at UVCV Evening College. He is specialized in computer vision and image processing with product and R&D expertise in security and surveillance, robotics, autonomous navigation, industrial vision. He has various contributions to differentiated vision solutions for Samsung mobile products and other roles. He was leading vision research and solution design and development for AR, 3D, natural and SRI solutions. I'm just listing few of his contributions. And he has also contributed to differentiated vision solutions for Honeywell, R&D products and other roles. And he has also been recognized as Honeywell Fellow for high quality technical contributions over 12 plus years. And he has 15 plus granted US patents, 25 plus filed patents, 20 plus publications and 3 books. He has done his PhD from ISC Bangalore. We welcome you, Mr. Dr. Lokesh. Thank you.
Yeah, thank you. Can you hear me?
Yes, yeah, we can hear you. Thank you.
Thank you.
Yeah, now let me introduce our in-person panelist. I will start with Mr. Rajat. Mr. Rajat Oja is an industry veteran with 27 years of experience in the interactive media industry. Rajat is in the list of top 20 influencers of VR AR industry globally and has been working in this space since 2006. Rajat is behind some of the most successful video games IPs in the world like Prince of Persia, Resident Evil, Battlefield, Final Fantasy, SGS and many more. Rajat has illustrious career where he worked in leadership positions at IBM, Toshiba, Motorola, Gentech, and is a parallel and serial entrepreneur. Rajat is mentoring over 50 startups, incubators across the world, and is advisor to 20 plus companies, including Samsung, Herman, Digital Motives, etc. Currently, Rajat is busy building India ka apna metaverse party night at Gamitronics, which is already considered as top 3 metaverses by Forbes. Party night is boasting 85 million visitors right now, and Rajat is a local guy, a Jodhpurite. Yeah, thank you, Rajat. Yeah, next I will introduce who are not in the morning session. Dr. Goro might have introduced him, Mr. Pradeep Khanna, but let me introduce him again, if you don't mind. Mr. Pradeep Khanna has multiple global roles in Metaverse XR ecosystem and knows more than 10,000 entities globally in this ecosystem. He is CEO of Global Mindset and also Executive Director Asia Pacific, Sydney President and Global Co-Chair Education for the Global Virtual Reality Augmented Reality Association. He is also an advisory board member of Global Metaverse Fashion Council. Pradeep has 30 plus years experience and has been a leader for IBM Australia, New Zealand, leveraging India, China, Philippines, Vietnam, Egypt, Romania, Brazil, and Argentina. There are many things listed to his credit. I will not go in the note list, but there are so many. He is alumni of IIT Delhi, and he has MBA from UNSW, MSc from Computer Science from UTS, and BTech from IIT Delhi. Thank you, Pradeep ji. Thank you. Next, we have Professor Jain. He doesn't need any introduction. We all know him. He is head of the department, head of the school of AIDE. And before joining IIT Jodhpur, he was the director of National Brain Research Center at Manesar. His research interests include organization, information processing, and plasticity of the sensory motor system of the mammalian brain. We are, thank you, sir, for being here. We are waiting for our director, sir, to be here. He will be coming shortly. Meanwhile, we can start the panel discussion. And I invite Dr. Manish Narwaria to be a moderator for today's panel discussion. Manish, over to you. Thank you.
Yeah, good afternoon, everyone. So the way we are going to structure this is, I have a few questions here with me, and we'll have comments from our speakers here. But just to get the ball rolling, I'll invite Mr. Rajat Oja to kind of give his perspective on what we have been hearing about metaverse, AI, and in general about this overall, immersive experience that we are really talking of. So let's get the ball rolling, Mr. Rajat.
Good afternoon, everyone. Thank you for inviting me here, and great audience. I was born and raised in the city, left in 1991. Of course, my family is still here. So yes, you can call me localite. My mom, my brother. I moved to the US after studying in Delhi College of Engineering back in 1991. And yeah, So yeah, you got a bit of intro about me. So let's just talk about a few of the things which I wanted to talk about, especially metaverse, because everybody relates. You know, when they talk about metaverse, they talk about Fortnite, they talk about Roblox, which are extending themselves to be metaverse, not necessarily native metaverse. So that's one of the reason we always call it. How do we stretch it? You know, it's um, so not a child's play anymore. It's because it's getting super busy place where not just the companies but the countries are investing heavily. If you're aware of Seoul, Korea, they came up with the digital twin of the country already. NEOM, on which we are working, it's a Middle Eastern city, and they are coming in the entire governance, and at the same time, you know, a lot of experiences what they want to build, and they call it city of future, and that's coming in metaverse. We also, India is not left behind, and when we are boasting about 85 million users, and why Forbes says that we are like top 3 metaverse company in India, globally right now, especially in the turnkey solution. We are not the tool guys. We don't create tools. We definitely have a lot of tools which actually help our this thing. We are the use cases, you know. So like you started with Mr. Simon, who was the deep tech guy. Then you got the industry outlook. This is absolute use case what we are building here. Okay, so I'll rather use, so very quickly, this is our background. We have been worldwide top 10 charts on PlayStation, on Alexa and Nest Hub. We have done a lot of stuff already. Epic Games, which is behind Unreal Engine, they have featured us over and over again in last 7 years or so. And of course, we have a mobile game. We don't know mobile games, to be very honest, but we did some and we saw some success. This is our contribution. 2006 to 2011, I had been building a lot of defense simulations. So whoever asked for the fighter jets, talk to me. We have trained astronauts also. And Indian defense completely uses all the stuff made by us largely. Every single weapon, every single T-72, T-90 tanks, the missile launchers. We are early adoption always happen in military, and so that's one of the reasons we started our journey in VR AR in 2006 itself. You know, much before Oculus was a thing, much before Facebook was a thing. You know, it was Vuzix headset what we used to use back then. It was more like a helmet. So whoever complains that the VR headsets are so big should actually look back in time and see how bad they were. Then again, 2012, 16, we extended our experiences of building defense kind of thing into theme parks and arcades. We personally own 53 arcades globally, in largely in the America. And 2017 to 21, we did a lot of VR game. One of the interesting things what has been touched upon, especially about the how it can be used for the healthcare and similar things, we created a software VR solution called MRI. MRI, it is to train kids how to behave inside the tube, MRI tube, because it's a very daunting experience once you are there. So the Emma is a fairy character which we created, and she is constantly telling you something while kid is wearing the VR headset. And we are working with Roche and Harman right now to for building solutions for autistic kids. And this is still going on, this project. All the while, we jumped into party night because we thought like and in fact we are not the brainchild of Mark Zuckerberg. And I'll correct Mr. Pradeep here. The first wedding actually happened in 2010 in virtual world, and that was in the game called Final Fantasy and Final Fantasy 14, and that's when the first wedding happened. Invitations cards were digital. People collected those cards, attended. So that was used as a KYC kind of thing back in those days. So yeah, so I think the world has been evolving, and how we differentiate ourselves from the games like Sims and Second Life and all these kind of thing. And we say the new metaverse is a little bit block there, which will touch upon very quickly. Again, if you guys play, I'm short on time, so if you guys play games, you must be aware of Resident Evil for sure. Battlefield, if not Resident Evil. Prince of Persia, if not Resident Evil and Battlefield. and Hot Wheels, if not all of these, and Darts Pro, which is actually used by the darts professional globally. And this is the game which I actually created in Jodhpur in 1994. So I still have. It was called Sea Dogs. Fairly interesting. There's no sound here for because for this thing, but anyways, so this is something what I created using Pascal language. And of course, it was my college project. I came down to Jodhpur because I wanted peace. I wanted to finish that, and I wanted to go back. And so I did this. This is the game from there to now. This is a game which is a VR game, as rightly pointed upon. Like VR and gaming are like kind of made for each other kind of thing. And so this game remained in top charts for 6 months on all the platforms, especially on the Oculus, Vive, and other things, and Steam largely, which is the delivery mechanism. So it's called Speedy Gun Savage. There is no sound, so you don't need to live with this non-glorified version of it. But anyways, I'll jump. So yeah, games left and right brain. This is the big industry, 6 billion every year. This particular game adds $1 billion to the bank, far bigger than the movie industry. In fact, movie industry, comic industry, every entertainment industry put together is smaller than game industry. We know. And WHO, which had been complaining about gaming being sick, symptom of sickness and all that kind of thing, during pandemic said that please go ahead, by all means play games. It's the great social behavior and social and metaverse coming together, right? So this is how India looks like. In fact, while we are talking already 2023, we are boasting upon 510 million gamers in India alone. So the stage is set. We already have gamers. We already have developers. We have 18,000 plus game developers in India, 700 plus studios in India. So the numbers are skyrocketing. And I think the entire interest, so if we talk about, the investor interest dipping down or the market is dipping down, let me tell you, it's the correction. It's called market correction, So whenever a new tech happens, it goes through 3 cycles. First, it's abused when nobody knows anything and just everybody is trying to create something and try to raise fund and stuff like that, and then it happens, then it goes into the category of misuse. When people know what they are doing and they figure out a way to twist the system and to support and to, do what they want to do. And then finally, the actual use cases emerge. So I think we are at the cusp of abuse and misuse right now. And that's why FTX and all these kind of, things are actually coming up in open. And we can always talk about the smart contract and the legalities of smart contract. We are working with Spotify. So you know how important, the whole blockchain piece is for Spotify. But why are we talking about video games here when we are talking about metaverses? Of course, largely built on game technology, as we keep talking about Unreal and Unity. Human psychology is the utmost importance in games because we are constantly playing with your mind, right? When we are building games, how to keep you engaged, how to provide you the maximum experience, how to take your money out. When we are giving games for free, and we are still taking your money, right? And we are making probably 3 times, 4 times more than with $60 games. So how do we do that? So economy is, of course, the backbone. NFTs are cross-platform, so you had been having guns and stuff or whatever in your games, right? Minecraft, you had a lot of things and stuff. But could you actually use it across the platform? No. Could you actually increase the value of whatever you have attained? No. So all these things, and somebody talked about loyalty here. We are working with Starbucks and we are working with Roadies Viacom. And that's exactly what we are doing. We are building a community and we are building the intrinsic value and the loyalty system for them and with various methods, and we can talk about it. The concept of avatar is from games, as we all know, and mythology, of course, again, comes from Indian mythology largely. Long-term engagement and this thing. So they say $13 trillion. I still say it's bigger than $13 trillion. Why? We'll probably touch upon as we go forward. Very simple. Metaverse and Web3 are not synonym to each other. It's confused, this thing. Web3 is largely a process engine for Metaverse. It is a part of Metaverse what you need to push, but that's what differentiates also at the same time. So it's a simple definition thing. So basic building blocks, how we see it. Again, the definition is pretty slippery right now. We see that there has to be a virtual world which needs to be centralized where people come and socialize, and people not just They do not just make money there, like Instagram, right? So Instagram, there are a lot of influencers. They go there, they create their videos, they create their reels, and they make a lot of money. But to buy their shoes or buy their item, they still go out to Amazon, Myntra, Flipkart, and all these places, and they buy. When at Metaverse, not just that you are actually earning there, you're burning from there. We recently opened 20,000 stores mall within our metaverse, and at the same time, we are working with some of the brands like Levi's and Cadbury and in fact Flipkart, and all of these guys to come and create places where people actually buy from there itself. Because 3D experiential shopping is what Gen Z and Gen Alpha are going to do. And they're already committed to that, and we see that number. Yes, just on second, we had a big, huge event with Van Heusen and Paytm, and we were like, it was 20 minutes event. We saw 2.3 million joining in. And not just 2.3 million people joining in, there are like transactions happened. 72,000 plus transactions happened within that period of time only. And larger part of the community, larger part of visitors were from India. So yes, we are already there. These are the layers of metaverse. The logic behind creators economy, that you build it, you price it, you sell it, and you let it flow without the control. And that's what is the decentralization. When we talk about the important piece of decentralized ecosystem, what we are building and what other metaverse players are building, that is an important thing we should do. Again, so it's permissionless, it's distributed, it's open, and there is no authority. And that's the only possibility of letting it flow. We did an event with Mr. Amitabh Kant, ISRO's Mr. Somnath, Chairperson, Mr. Somnath, Telangana government, and some other people. And whoever talked about privacy, we solved it using a lot of KYC methods and a lot of AI built into the system. And again, that is something which we can talk about, because when there is no identity and there is nothing over there, people can come and do anything they want to do. And especially when the government officials are there, especially ISRO chief is there. So you need to be pretty. So we are a full service metaverse. We are built on Cosmos SDK. We are not using any, Polygon or any existing because of our own reasons. We have our own tokenized NFTs and stuff. We created our own avatar system other than using the Ready Player Me and other avatar systems which are in place. We have the world building system using just the text intent. We can create the world. It's not accurate, let me tell you that, but we're working on it. Massive multiplayer architecture, because that's our DNA. We had been doing it, ever since. Then, of course, there is a communication layer, because you talk to people all the time in these kind of places. There is an economy layer, which is not controlled by me. I just monitor it. If you're building something, you're putting it up minting it on my blockchain, and you're putting it up for people to access in the metaverse, and they just access it. And of course, the experience and the engagement is the paramount. So the concert we did when Van Heusen store got opened in our metaverse, we brought a band called When Chai Met Toast, and they did a concert there and dropped some of their NFTs as well. So it was the experience part. So this is the typical blockchain infra we are using. And for again, coming to the avatar, which is an important part in this thing, because one thing which I realized while talking to a lot of people, and especially the kids and stuff, they don't like to be photographed as much. Actually, they want to spend time on creating their avatars. Average time I'm talking about is 17 minutes, what Gen Z spend on creating their avatar. Which means that there are people who are spending like hours and hours. And there's a game called Elden Rings, if you're aware. People have spent 3 to 4 hours creating their avatars or creating their character there. And there is a reason why people do it, because they actually probably things they miss out, in the real life. They want to pose themselves as a warrior and stuff like that. That works, So what avatar system we are using, we have our own thing. So we can convert any pic or video in an avatar in absolutely no time. And we are working with University of Minnesota. for all the research purposes for this and the user behavioral pattern. Then AI-powered gestures, which are again important because without using your this thing, motion capture suit, you can actually do all the gestures, and those are actually translated to this thing, which is very important when you are going with uncanny valley, this thing. AI-powered lip sync. Then we create the synthetic data. So we're doing a concert. I know Lipika ma'am was like little, this thing about like, why are we bringing dead people? We are working with, right now still being structured, but we are doing a concert with Kishore Kumar and Bappi Lahiri. We are working with Bappa and Amit Kumar to get the license and stuff, and working with them to create the synthetic voice of Mr. Kishore Kumar and Bappi Lahiri. So he can literally address and people can experience all the things in person and as if they are actually there. So again, this is something which is already is happening in like 2 months time from now. It will happen. We have the AI powered clothing where you draw whatever costume you want to create and then just try it on, and that becomes a wearable in the metaverse. And this is already there. Chat GPT integration is a recent thing what we did, and Midjourney integration to enhance the apparel design part of our metaverse, which we are focusing a lot on. This is a quick video of Sai. Everybody is aware of Sai, right? So we took his Ellen's this thing and created his own voice and with lip sync. Quick demo of because you cannot hear the voice is not being transmitted, but yeah. So you can see it's just a simple photograph. Everything else is created using the video. And if you don't want absolute realistic one, then we have our own avatar system using which you can probably customize every part of your body and apparels and all those kind of thing, and then enter the world. So, and this is the conversion from photo to avatar creation, and at the same time AI using a very basic camera. So this is the person standing there. It goes directly there. This is whatever he's doing gets immediately translated to Mr. Daler Mendi. And we did his concert also. It was our opening thing. Okay, and this is the collection of the use cases of the things we have done very quickly. Because of WebEx, it's kind of, little, yeah, there should be. I don't know why it's I don't know. So the most important part for us is the economy. If economy is not there, it's not true metaverse. If economy is missing, then we are actually talking about Second Life being a true metaverse, which actually it is not. And let me, I probably, it's okay. I'll keep on explaining. So this is what we did with Ford Shelby vehicle for Peterson Automotive Museum in Culver City. We worked with Pixar and we worked with Ford. This is the Daler Mendi's concert, which was 26th Jan. This is the Van Heusen thing, which recently happened. This is Kichler, one of the premium American brand for lighting solutions and stuff. And this is Dodge Ram launch. So this is MRI, which is a VR solution for kids going through the MRI tunnel. These are some industrial use cases. I don't know if you guys are aware, Bangalore Airport is in Metaverse now, BLR Metaport, and they are going full blown now with this use case with us. Indian Oil, so somebody talked about fire safety and rig training and everything. Visiting Mars and visiting Moon. in our world. It's heavily being used for the governance simulation, the crowd management, what people are liking, what people are not liking, and that's what Bangalore Airport is using it for. So they literally created the entire this thing where people can go tell what they don't like. This is something what we worked with Microsoft. This is onboarding, employee onboarding solution, which is all these are part of our metaverse itself. ISRO owns a land there. And ISRO did an event, and after that, all their launches and other things are streamed directly in the metaverse for people. So they are building a community with us. And of course, the government of Telangana is completely committed to that. We sold, in fact, this was featured in Kaun Banega Crorepati also. Amitabh Bachchan asked this question for 80,000 rupees. That who bought land in, which like pop artists bought a land in Metaverse, that is Daler Mehndi. This is completely ISRO's own. So all their accomplishments, all their things, and not just accomplishment, people can come together and do Mars launch again, that Mangalyaan launch again. You know, it's a simulated experience. Airtel is running a 20-screen cinema hall. Eno owns the land. This is A.R. Rahman sir, who's signed with us on this thing. There are like 25 plus artists. Close to 200 brands are working with us on Metaverse. So these are some of the features. There are like a lot of worlds we have. There's a social connection. You can send friend requests, but before that, you actually engage with the person, not just like you see something and you just send. You can engage and then send friend requests, and you can create a lot of reels and stuff. Try on different clothings. Build your own car. And this is the loyalty part which we talk about. These are NFTs, and these are playable NFTs. So you don't have the same car what you actually bought. You keep on upgrading that and keep on participating in this. This is our way to make metaverse, everyday visit. Otherwise, whenever we are doing an event or whenever something happens, then only people will come. So we created, a meta game around it, so people can keep coming to this every day. And so there are like a lot of ways people connect, a lot of leisure activities, what people are already doing on our this thing. There are like multiple games other than the meta game, which is there. Not just that, we recently came up with our own world building tool where you can actually, create just like Minecraft or stuff like that or Roblox. You can come and create your own spaces. And this is, of course, quick take from the, what we did with Van Heusen and the MetaPlay side of the thing. And I'll just jump. So the seamless part of Metaverse is when you can actually take asset from one place to the other. And that's what, again, is an important thing. Why Metaverse will become much bigger and already is becoming bigger is because STC already launched a, phone. LG has showcased their smart TV with Metaverse built into it. So it's reached your living room now. You switch it on and you are in Metaverse. Another consumer brand company is working with us to bring Party Night as the operating system of this thing. Thank you very much. I'll just go back to my place.
So thanks a lot, Mr. Rajat, for that very interesting overview. So my next theme or next question actually is flowing from that. We have been hearing about metaverse, and we have been hearing about AI, and maybe to a certain extent about computer vision. So the next question is there a way in which metaverse and AI they coexist, or are they going to compete, or how are they really going to basically exist with each other? So why don't I start with Mr. Bharat Kumar Sharma?
Thanks. Hopefully you are able to hear me.
Yes, we can hear you.
Okay, so I think that's a very interesting question, and it has to a certain extent already answered by the previous speaker, because he did talk about using some of the AI features into the metaverse environment. But if I were to summarize in short, I would say that AI and metaverse have a symbiotic relationship. And what do I mean by that is that if I see metaverse, it's actually a big data problem. And as we all know, the big data problems today are being solved with the help of artificial intelligence. We have already seen a lot of demos in terms of the gaming industry, which is definitely a big problem to solve. But if I talk about the industry environment, which was also showcased some time back, like digital twins. Nowadays, the whole factory by BMW or Siemens is completely being converted into a digital twin. And one of the main thing which is required there is the necessity of generating synthetic data. And as it was also brought out, the new ways of doing that is already known. Everybody is talking about generative AI at this time. So the generative AI will be key to scaling these digital twins and virtual environments. Or if I were to say, just as AI is crucial to the expansion of the metaverse, and on the other side, so too is metaverse to the expansion of AI.
Right. Thank you. Dr. Lokesh, maybe if you could, hear your comments on like how metaverse is going to be affected by AI and maybe even computer vision to some extent. So please go ahead.
I think that's like what Bharat said. It's a very interesting question, and many manifestations for this. I think continuing on what Bharat mentioned, it is definitely a symbiotic relation, no doubt at all about that. See, AI has been one of the game changer for computer vision, at least. So, which is my primary area in 3D vision and AR. So what typically happens is, if in case you want to solve some of these hard problems that we have today in terms of realism, 3D realism, specifically with respect to bringing in the depth aspect, which humans learn so easily over the years, I think AI is one of the core which will actually offer solutions, and that in turn would play a key role in many of the realizations within metaverse. So on one side, what Rajat showed in terms of realization of the virtual world, the metaverse, if in case we need to have more realism with bringing in the 3D aspects, definitely the solutions in AI, solutions using AI for the sake of creating some of those. So there are a whole lot of challenges, of course, and like what Pradeep was telling in his previous talk, it may take 6 years to 8 years for certain realizations in the metaverse. I believe that some of these technologies are key in that path of realization, which is where AI plays a very key role. And on the other hand, the requirements or the challenges that are there in metaverse would actually flow back and would definitely pose challenges to those people who are trying to solve those problems. So if so, metaverse and AI are definitely going to go together in that sense. It would not be a competition as such, or it would not be exclusion as such, or it would not be an elimination as such. So it would rather be more towards supporting each other in terms of what technologies would be developed. So there are a host of challenges in computer vision that require AI to go even further than what it's gone now. Specifically, if in case you need to increase the scale of operations to the tune of the metaverse, definitely, like what Bharat was mentioning, generative AI is one of the key over there. And if in case we need to actually create such systems using AI, data is a big problem. So synthesizing data for developing those mechanisms and methods in computer vision and 3D vision would definitely require much more advancement in AI over the next decade. That's my view.
Thank you, Dr. Lokesh. Maybe if we can ask the panel members here, Professor Chaudhary, your remarks on this particular topic.
I think there is what I completely agree with what Lokesh and Bharat had stated, and even in the presentation, what was talked about. I think AI actually is a very enabling technology for metaverse.
Yes.
In fact, without AI, really we cannot have metaverse, and that's absolutely fundamental. And you look into it that what the layer which is there in metaverse, and if the AI, where AI is not there still today in a major way in terms of reasoning, planning, and things being done which are not really pre-programmed completely. In fact, the procedural AI and advancement of procedural AI and the planning, that can add a different level of excitement into metaverse. In fact, that's what is also the future AI, what's being talked about. And that way, metaverse will be getting enriched with AI. If you look at computer vision point of view, the computer vision point of view say that today, can I have a live feed and put into an environment which can provide me a completely different view in real time? Let's say 360-degree view. I'm talking over here, and there are cameras which are capturing me, and maybe 360-degree capture it's happening. But then, can I be replaced in a completely another physical environment? And then you can see the whole event in another physical environment. Now, these are the technologies which are being talked about today. But that's again computer vision and rendering and graphics, because the point is that entire geometry and context with reference to the place and your placement, and even the physics comes in. Okay, because a common sense, the basic physics and common sense physics has to be embedded into any kind of computer vision based transformation in such places. And the last point I want to put across is that when we talk about NFTs, now a very important point is this ownership of NFT. Now, what I have generated can Pradeep transform and start claiming its own NFT. Therefore, there is a challenge today how you integrate. In fact, there are work is happening in this space. How do you integrate biometrics into the NFT? So the NFT gets completely assigned to the creator. So these are some of these related problems and which have huge significance related to the growth of metaverse in this technology space.
Yeah, thank you. And I actually completely agree with what co-panelists have said. If we don't use AI, and already it was talked about how ChatGPT is being integrated into Metaverse will actually stop to progress after a while. Just like what you can see on the screen on a movie or on your computer screen, actually, the realistic experience of it stopped after a while. So unless AI engines are behind it to make it more realistic and taking it beyond visual world, it's not going to progress. People will get bored of it, whatever we might create in the future. So essentially, unless we bring AI technologies, which as Professor Chaudhary also said, it's an enabling technology. It is not something that is going to be separate from metaverse anytime. Just like you can render images, similarly, AI will be just a simple engine behind metaverse. If it's already there, actually, it's being integrated. So these are inseparable, essentially. That's what I think. Yeah.
I already demonstrated it, so it's already there. But other than that, few of the things you should know that there's so much sitting behind what you're seeing, and that's the big data. I think somebody just highlighted that part as well. And the deep analytics, 360-degree analytics, what Metaverse provides, required that tremendous amount of AI to be processed. It's not just the what you're seeing is ChatGPT and clothing and gesture control and stuff. In fact, by the way, we are using Omniverse, so great tool already. Created by NVIDIA there. So yes, so there is a lot of data analysis also behind the scene, which is being taken care by AI. And I think AI is the key, not just enabler, is the chief driver of metaverse, and it will continue to more advancement in AI will provide much better use cases and experiences over the period of time.
Well, there is not much to add after all my co-panelists have mentioned over there. Just want to highlight that the next phase actually is what is called as intelligent immersion. That is where we are heading towards. And just to give examples from both a consumer and an enterprise perspective, from a consumer perspective, we will see a blend of neuromarketing, AI, and the metaverse. And from an enterprise perspective, we need to just go into digital twins, because end of the day, the metaverse is in another form a digital twin of the whole world. So when you look at a digital twin, it has got three layers, Bottom is the physical layer. The second is the digital layer, which is actually called the dumb layer. And the third is called the information layer. So, and there is a feedback loop which is going through both in terms of predictions as well as in, optimizing. So I think there is no discussion at all on this particular point.
Right. Thank you. Any discussion on metaverse? I think it might be incomplete if we don't talk about regulations. Like yesterday, also we had a discussion around responsible AI. So my next question is related to this. Do we need regulations for metaverse, or is it just fine? Like, is it going to inhibit if we bring in regulations? In other words, should we also be talk of responsible metaverse? So maybe we can start with Pradeep ji.
So you see, one of the fundamental challenges of the metaverse at the moment is that we are, first of all, there are as many definitions of the metaverse as the number of people you speak to. But taking at the moment that metaverse is the digital layer which is there, see, one of the challenges is how do the sovereign governments play in regard to the metaverse? Will India just accept that there is some overlying digital layer? So likewise, will US, accept that there is some line over layer where they have no control? So there has to be a global agreement for the metaverse. So to answer it is in two perspectives. One is absolute. We can't let the metaverse run wild. There are so many aspects in terms of safety, security, and so many other things, being talked about. And the second is that global agreement for achieving that.
Yeah, so absolutely, it's a wild west right now. People are having all kind of fun, and there is no regulatory body, and so the onus is on the creators at this moment, like people like us who are building metaverses, like how we provide, a regulated, where the privacy and other things are taken care. But again, there is no standard yet. Of course, there are two bodies I'm part of which are working towards it. And again, as Pradeep rightly mentioned, there has to be a global agreement around it. But till that time, it's a wild west. And of course, regulations and privacy concerns should be addressed. It's the paramount of the society, right? And the de facto standard of how the society functions.
Well, actually, there are a lot more aspects. I wanted to bring in a slightly different angle to the whole thing, which has not been talked about so far. It's how does it affect our psychology? How does it affect our view of the world if we spend more and more time in metaverse? We can spend a lot of time gaming, but we have to come back to the real world, or do we not have to come back to the real world? If Ready Player One, probably all of you have watched, and if you have not, you should actually watch that movie. So this is one aspect of regulation in terms of health of the players, health of the world, health of the universe, whichever way you want to define it, that has to be considered, evaluated, and dealt with right now when we are at the crux of going big way into the metaverse, because we really have no idea. Is it going to be just like another opium or LSD or something like that of the future? Probably, hopefully not, but it's a real possibility. And that is what I wanted to bring up. That's where the regulations actually will need to be coming in a big way to address this concern now rather than 5 or 6 years from now. And that's something that needs to be debated at some point about the ethics and everything else that we need to worry about. So there's no answer to this aspect that I'm bringing about, but I just wanted to bring it to the body. Yeah, thank you.
Thank you. Yeah, Professor Chaudhary.
Comment. Okay, the point is that the reasons for which we are talking about responsible AI, I think those reasons are equally applicable for metaverse. The other part which Professor Jain had talked about, that whether it would become an opium or not, But the question is can we create a metaverse? I think that would be also a research question. Can we create a metaverse which will not be opium? Which will possibly connect people more to reality and true reality and not being a opium and taking to a different world altogether. So it is, I'm inverting the question itself because, see, we have, if you look at the pathway, we have actually moving from real to more of unreal, okay? More of getting into virtual, getting into that space. But actually gaming has that issue. Now, can the gaming world can also include the real world? Okay, so ideally, philosophically, you are talking about the real world and virtual world coming together in the metaverse. But can you actually create a technology where sitting in metaverse, I can really communicate with you in your physical world? Can metaverse allows me to bring in a context for such communication? And that context in the metaverse, and we can talk with reference to that. But there can be also utilities on metaverse. It's not that it can be only gain. Say, for example, there is a project which is going on. I think Deepak, I don't know whether he's around. So there was a project on, we were trying to work on a digital twin of an academic department. Okay, and in a next stage, it was I had also talked with some of the faculty members that can we create a digital twin of an academic institution? Now, the moment you create a digital twin of an academic institution, there are processes, you can simulate, you can plan, even you can run courses on the digital twin, which really gets converted into a metaverse of academics. And if you move to metaverse of an academics, then why it is linked to your regulations? Obviously, that university cannot run, or that institute cannot run without specific legislative conditions of that academics. So therefore, these rules and regulation gets embedded into the metaverse itself. So one part you're looking at controlling metaverse from outside, but on the other side, inside itself, when you have people participating and you are simulating scenarios, you might be offering course on metaverse. Think about it. It's not something impossible today. Why should it be only for Van Heusen store? It need not be. Yeah. So the point is that, therefore, the whole issue is, therefore, inside itself, it can be embedded. And the challenge actually is in this, it's not just the delivery of a course. Challenge is when you create a digital twin, there are lots of other details which needs to be addressed. And so for the translation for digital twin to metaverse is again a technology challenge, which also needs to address regulatory requirements.
Thank you. Dr. Lokesh, your remarks?
Yeah, I think very interesting points brought out by Professor Shantanu. I think I would want to point out to a couple of other aspects which probably would add to this dimension, slightly different dimensions. So if you look at our avatar being the conduit to the metaverse, what are the aspects with respect to intent, conduct, or the behavior which we need to bound while we are defining the interactions, while we are allowing the avatar to be something what we were not in our real world? So those are aspects which are currently not being discussed at all in terms of where are the bounds. So when the bounds are defined, probably we can contain it to be not getting into a mode of an opium kind of. So that's one thing that we need to look into. On the other hand, there we have had instances of the digital SNS platforms causing casualties because of certain extremes that people get into, whether it could be TikTok or any of those things. So they can be good, they can be bad, they can be moderated. So all kinds of aspects with respect to it. So how do we see to it that casualties don't result in the real world because of happenings in these virtual worlds, the metaverses that we define? So those aspects. Then, of course, I mean, what do you term as metaverse crime itself is very hazy and vague at this point of time, because in the metaverse you can do anything and everything, right? So you can actually simulate, you can actually create, it's a like what Rajat was saying, it's a creator's economy, it's a creator's paradise, it's a creator's place. So where is the end, where is the starting? So unless we bring in some bounds for every activity. So if you look at the four pillars typically of metaverse, the virtual spaces, the virtual interactions, the virtual, rather the money part, the and also the very digital assets part. So where do we have the bounds for all these things in terms of what can be a space which is defined as a bound, and beyond which we term it as not uh, what you call suitable for metaverse interactions. So which is where I think the whole lot of debates and discussions have to happen while we are actually making a lot of attempt in terms of putting the technologies in place, right? And also the digital devices that are going to be there for the sake of handling all these things, they themselves need to be curated in a sense. This is my view. Thank you.
Mr. Bharat, your remarks.
Yeah, so I think most of the points are kind of covered, but I might be able to explain it. I think this was kind of covered to a certain extent, but one of the aspect is to give the consumers themselves a very clear choice, right? We all know about different sets of policies like GDPR and all, where it needs to be regulated in terms of how do you interact with the end users and what part of the things, whether they want to expose, whether they don't want to expose, whether they want to get out of the system. Currently, it is all driven more of in ethical sense from the developers and from the community, but there would be strict policies which I would say which may come into the picture in the future, because they all need to be kind of standardized, I would say. And the most important part I would also bring in is the financial part, and especially when there is finance involved, regulations do come into the picture. We have seen that in the recent past, where if it is not regulated, it can result into certain unnecessary impact, not just on the creators but also on the overall economy also, because it's going to be used for the purpose of doing certain transactions, going from the physical environment, say, to a digital currency in the future. So this is something which definitely would come into the picture when all this is there, and I think that's when the government would play a very important role.
Right. Thank you. So, like, we can just open this up. Are there any questions from the audience in the context of the discussions that we are having? So, please go ahead.
Hello everyone. This is Sai Kiran from Electrical Engineering Department. So I have a question regarding to the communication networks which will enable this metaverse. So now going in the future, will the metaverse content providers are going to invest into any of these telecom networks so that the quality of experience for that particular company can be enhanced, or any such policies are being thought of?
You see, you raised an important point in terms of the role of the telecom companies. Telecom companies are going to play an increasingly important role for a couple of reasons. At infrastructure level, they are laying 5G. 5G is very expensive. There's a massive investment at this particular point in time. And the telecom companies are looking at metaverse as one of the major use cases for recovering their money. That's one side of the story. Second is that at experience level, telecom companies are looking to add on to the value proposition to the last mile, which means that just like Jio offered a free phone, you will see in the next couple of years see Jio offering possibly a head-mounted device, a free head-mounted devices along with the services. I mean, they've got a company called Jio Tesseract who was absolutely focused on developing smart instruments for this, So, we see I've seen the same story being played out in South Korea, which are possibly some of the leaders in this. Today there's a government initiated initiative, but more on that later on. But this is my perspective. More on to my fellow panel members.
See, actually, if you look into it, in fact, I think even Reliance is looking into that 60 gigahertz, this local area network standard in a big way, because because they feel that that's what they can exploit for a kind of captive audience with entertainment products. Because the Reliance has got huge amount of entertainment assets, and they would like to push and make use of it in variety of ways. Today, Metaverse will turn out to be possibly a one major consumer of this entertainment contents. And so therefore it has a connect, because the point is, if you look at, as was been stated earlier, the voice to data was a jump in terms of the business of telecom. Now this is today really it's a jump of a kind of a AR VR immersive experience, and delivery of immersive experience over mobile network will actually change the business model of mobile companies, and I think that's bound to.
So running an organization, I can tell you the entire game is of data at the end of the day. You know, how much data you can generate. There is no possible way to get this much of data, you know, about user behaviors and patterns. There's only one way at this moment is provide two-way interaction, you know, and 360-degree, coverage of the user behaviors and patterns. And that's one of the reason, you know, we partner with, educational institutes and all these kind of places, because, that requires some other level of intelligence. And so it's in the interest of the likes of Geo and Airtel and all these guys. Why Airtel opened a theater with us? Why MTEL from Mauritius is working with us? Is largely because their end game is always like, to have the entire this thing. So instead of we creating tools and stuff for, harnessing, we just take the, what they provide. And 5G is basically, it's not just the speed game, right? It's a much bigger, much better, it's much more optimized network. What we are talking about is peer to peer. It's going to revolutionize. And in fact, we keep saying that it's an important part of, metaverse, but actually it's other way around. 5G is, is driving, the entire metaverse and all those things. And metaverse is going to be the largest use case possible for, 5G companies providing this thing. And the second is going to be automobile industry. So, yeah.
Thank you. So in the interest of time, I'll pose one last question. This is related to the word multimodal. So we have been hearing of this word. Basically, we are talking of all the 5 senses being incorporated digitally, that is. So let's say multimodal immersion, which might be quite interesting in the context of metaverse. But the question is, how close or how far are we from this multimodal immersion? Audio visual, I think we are sort of there about, but what about the other sensors? So maybe I can request Dr. Lokesh for his comment.
Yeah, I think this is a very interesting question, because all these years, in the last 2 to 3 decades, a lot of developments happened with respect to voice, speech, and audio, and with vision. So a lot of technologies and maturity has come in. And one of the panelists were mentioning, there's a lot of work in haptics also happening. I think it is very important for getting the multimodal aspects in place for metaverse to be that much realistic. So when your avatar is actually there in the metaverse, and the avatar has to be tuned to behave, like you, or you want to have some behaviors of yours being put over there. It's not just the audio and visual, but the whole mannerism that has to be bring in. When I say multimodal, it also includes the gestural interactions, the facial expressions all coming into picture as well, not just the uh, uh, aspects related to vision, 3D, and then the speech. Now, apart from that, even the sense of smell, a sense of taste, all those need to come in. A lot of research is happening, of course, but these technologies still are far from mature in terms of trials, as what I understand from the literature. So the multimodal, we need to really pull up our socks to make them be ready for metaverse, which is at least what I know.
Mr. Bharat, your perspectives on this multimodal immersion?
I think, as it was brought out by Lokesh, I think multimodal is is what I personally feel is the future. It's already there. Currently, we are talking about multi-models in terms of having, say, audio and video and the other aspects combined together. You are having models like from an AI perspective, we are having multi-models which are few trillion parameters. So that also is one of the key things which needs to be seen is that there's a lot of research which is required as well as there's a lot of backend which is required to even train these kinds of networks, which also comes to the part of having certain data sets which are available. And again, it comes back to the previous question, which is the standards. So I think it's all tied together, but just to clearly state, I think multimodal, I believe personally, is the future, and that what is going to bring the innovation.
Yeah, I mean, I just forgot to add one more aspect over there. So when we say multimodal, one aspect is having the modalities being brought in together. But in terms of the multimodal fusion, to be in effect to create those kind of realism and interactions, the fusion itself, is it a fusion which is done at the sensor level or at the final outcome level? So where exactly do you fuse and how do you fuse? Whereas if you look at a human interaction, the fusion happens so smooth and so unknowingly. How do you actually create this kind of a multimodal interaction given the aspects related to synchronization of the sensors, the different innate behaviors of each of those sensors? So that itself is still to be solved to a large extent. And like what Bharat said, the generation of the data, the amount of data that's required for the sake of creating this fusion at different levels and try to combine and see how we can get the realism. So the data thing is very tricky to solve again, to get the realistic ground truth of the data itself.
So, Professor Jain, any remarks?
Yeah, actually, our integration of different modalities in virtual world follows what we know about how our brain processes those sensory information. We know a lot about how vision works. It's not a proximal sensation. You have something far away, you see it, and your brain processes information. It's easy to understand. It is easy to generate multiple kind of sensory inputs very easily. And that's the reason. The second one, when we talk of audio, is also not proximate. Sound is away. It took much longer for us to understand how brain processes audio information. Tactile information is very proximate. So we are talking of gloves, jackets, things like that. Now this is a problem. You can put earphones, you can put maybe some kind of glasses or virtual reality setup in front of your eyes. But are you ready to be ensconced in a top to head to toe bodysuit? I'm not sure how long people will sit like that. So this is a problem. As far as other two major senses is concerned, which is smell and taste. In fact, again, the following the same parallel, we know even less about how brain processes that information. They're harder to create. And if you ask me as a neuroscientist, I'm sort of an odd person out in this panel. Uh, I don't think having little capsules of molecules to produce certain kind of sense of smell, for example, is going to solve this problem, because there are infinite smells and there's large number of taste and there's a combination between smell and taste which creates flavor. So this is not going to happen this way, in my opinion, as of today, unless some major technology comes up, because you actually have to deliver those molecules, unlike something on the screen. Somewhere we'll have to understand how brain does it, and maybe directly access those regions, those pathways, those neurons in the brain to deliver that experience. How acceptable it will be, we are not going to talk about it. It probably will be. We accept everything eventually. But this is the only path I think this is going to be, in my opinion. And it will take a while, as Mr. Lokesh has said, back back-end information is not there. And I think this is one of the back-end information that will require to integrate into a completely realistic metaverse or virtual reality experience. Yeah.
Right, Mr. Rajat.
Yeah, absolutely. Nothing much to add there, other than the fact that he's absolutely spot on when he's saying that it's impossible to reproduce this way. There's a very interesting conference which happens annually in Orlando called ITSEC, which is the simulation, defense and simulation conference, which I attend religiously I've been attending for 20 years now. And 2003, we bought two devices. One was NeuroSky, which was for neural sensing and stuff, and you just wear it, and it has 12 different spectrums, which actually collects and does interesting stuff, which we thought was very important for drivers training or the gunners training and the snipers training and stuff like that. And then the other thing was a smell box. They call it Smellox, and that was in 2003, 18,000 US dollar back in those days. You just connect it to your PC, it actually releases some fragrance depending on the kind of environment you are in and all that. And it failed miserably, and because you never know what kind of environments you are producing and all that. It has like 12 or 15 cartridges. How many more cartridges will you continue to add, and how you're going to do the chemical processing of everything? However, we used it for, APDS missile, which is generally used in the tanks. So people sense that there, especially for a defense purpose, you need to smell and you need to know where it's probably, what is the proximity of similar kind of, barood and stuff like that. So it was a very, very specific use case. I think in those kind of things you can do it. But other than that, this whole multi-model thing is, it will take its own sweet amount of time. However, haptics has already done amazing. And somebody asked about the pressure and stuff. So one of the use case we are building with the Bangalore airport is when the airplane catches fire, and then there are two things what they use. One is the spreader and the other one is cutter. One spreads the damage area, and then they cut it across, right? So that is very heavy machine. How you actually do it, and that's easily solvable using where the haptics has already gone. But other things will take its own time, and I'm not too sure it's in very, very near future kind of thing.
So some excellent comments by the fellow panel members. I just want to give another perspective, and that is I'm picking up on what Lokesh mentioned in terms of the access point and the experience point. The question is that which is going to be the access point to the metaverse is again a heated topic, and at the moment it appears that the smart glasses are going to be the baseline device for accessing the metaverse. And today we are still a couple of years away from having a decent smart glass. Of course, everybody is waiting for Apple smart glass to come out to see how that is happening. So we are looking at a smart glass coming, kind of getting a great or a good smart glass, maybe in about 7 to 8 years' time is what current thinking is. Now, add to that is a Pew Foundation survey, which was conducted that by 2040, 50% of the population who can access metaverse, will they be able to access? And the feeling was that even by 2040, 50% population will not be able to access. So integrating all of this, you can see the timelines as how they're emerging is that, from a visual access perspective, you will have something, decent, maybe around 6 years from now on or 7 years from now on. That is the time when metaverse starts from a visual perspective, starts, developing. And then right up to 2040 or something, the journey continues. So multimodal is much beyond that. Parallelly, it may happen. But here again, I want to highlight then when we are talking about this, the disconnect or the connect between the digital personality and the physical personality, that is also going to come into question.
Yes, Professor Chaudhary.
See, if you look into it, vision came independently. See, your speech, audio, vision, all of these emerged independently. And if I look at computer vision, and it started with image processing, so your input is image, and you analyzed, and now you have got the capability to generate image. And with the multimodal input, you can generate images, even text. text is also something which is very important. So in that sense, text, image, and audio has been integrated in various frameworks. But you have not actually done the basic research in, say, for example, smell. Now, say the representation of the point that what Professor Jain was talking about, that how do you represent, what is the definition of which smell? If you say there are elemental smells, how do you characterize those elemental smells? See, you can characterize, say, a color with RGB, but you have to actually do the fundamental signal processing. We have to move in that direction. And how do you represent smell? I'm just picking up one example of the senses. This is also equally applicable to the test. If you say in terms of basic VOC sensors, you will be sensing the smell, then you have to first build that VOC matrix for capturing the smell image. So there is enough work is there in sensor technology, in signal processing, and then interpretation, and then putting it through. In fact, there is also a IEEE standard, which is a multimedia standard, which they brought out in 2015, where they talked in terms of representation of these non-visual and non-auditory elements in terms of an XML scripts. So XML scripts are actually representation of those, and you need therefore the translator for generation of these, and that was linked with these kind of modules which can be activated. So you can transmit. Therefore, this question was, it's also linked with the question of communication, that it's not only just creation of this, but it's also need to have mechanism to transmit that. So therefore, it's an open area of research, and it's a very exciting area of research. I'm talking about purely now as an academician. So, and if people are wanted to get into research, and they can actually do groundbreaking work in that space.
Can I just make one last comment for the day? That, we've been talking about all this looking very futuristic, We've been talking about timelines, 6 to 8 years and, 2040 and all that. But what does it mean for us in the short term is that it is going to give a lot of push to AR, VR, and especially mobile AR. So that tipping point journey has commenced.
So thank you. So on that somewhat positive note, I think we'll end today's session. So, but before that, maybe one last question from the audience. Okay.
I just want to make a comment, and all of this is quite new for me. But I want to. There was this German philosopher called Martin Heidegger, and towards close to the Second World War, he wrote this famous essay called "Question Concerning Technology." And in that, he said that when you look at technology, what you ultimately see revealed is yourself as human beings. And one of the problems that he saw with with modern technology was that it converts the whole world into what he called standing reserves. So you see all of humanity as standing reserves to be used. So I was just wondering, seeing all these presentations and the development that we have of generative AI also. So maybe we also need to engage with certain fundamental questions of what it means to be human, because if my voice, my persona, all of that can be alienated or separated from me, what does it mean to live? What does it mean to die? So, I mean, these were some thoughts that were there in my mind.
What we've done now is the broad definition of metaverse, we've also added human reality. Just jokes apart.
So may I go ahead? I have a question which is very related to what Rachel said. I am Akanksha from School of Liberal Arts. So we have been talking about how technologies have been aiding development, but just wanted to understand how inclusive is this development, because we do acknowledge there is a strong digital divide which is eventually leading to inequalities. And so what is your view when we say that this kind of, the new technological interventions are leading to a more dystopian world, and what kind of timeline you are looking at when you say that it actually is going to be an inclusive development, not just development for a certain section of the society?
So I will refer you to a recent McKinsey survey where they looked at inclusion in the metaverse, and what they found was that 65% of people who are working on the metaverse are females. However, in the leadership positions, there are only 20%. So that is, answering your question as to where we are insofar as inclusion is concerned. And this is looking at only one category of inclusion, that is female. We are talking about. Leave aside the other categories. So there is a big journey, to be carried forward in the inclusion side. And there are so many other incidents insofar inclusion and related to inclusion, which is happening in the metaverse, which are a cause for concern at this particular point in time. There are very well documented cases, and that's why the response of Meta, etc. When there was a case of harassment in the metaverse, so Meta came back and said, "Oh, we have created yeah, what nonsense is that? I mean, what is somebody going to keep looking for that? How do I, press the button for the capsule? I mean, it's early stages, but research is already coming out on that."
So thanks. So in the interest of time, we'll sort of end this session. But before that, I'll request Professor Shantanu Chaudhary to present Mr. Rajat Oja with a memento.
Thank you for your lovely ponytail. By growing up, people used to ask me, "Chora hai, chori hai?" When I was little, I have been carrying this ever since I was 18 years old. So,
Yeah, so now we close this session. So the next session, that is on robotics and mobility, that will start here at 2 p.m. So please join back here. आपको फिर थिंक करना होगा तो व्हाट्स द बेस्ट टाइम यूजुअली करेगा कि जवाब दोगे कि नहीं दोगे जवाब देता हूँ मैं नहीं अभी देते ही हो बट ठीक है मैं आपको तंग करूँगा थोड़ा टीच करूँगा अब आपको हेल्प चाहिए नहीं अभी तो बस ये होल्ड करने का है दैट्स ऑल आई थिंक ऑफ दैट क्या पूरा तो आप आईआईटी हैदराबाद भी से हाँ आईआईटी हैदराबाद Okay. Okay. Let's again take the photo.
A very good afternoon to all. I welcome you all to the session on robotics and mobility. Our apologies for starting a little bit late. As part of this session, we have planned for three parts. That is, first is an invited keynote lecture, then there will be an expert lecture, and finally culminating in a panel discussion. As part of this session, we have now a keynote lecture by Dr. A. Pashilkar, Director of CSIR NAL Lab. Dr. Abhay Anand Pashilkar joined National Aerospace Laboratories after his ME from Indian Institute of Science, Bangalore in 1993 and BTech honors from IIT Kharagpur, both in aerospace engineering. He worked as a guest scientist for 9 months in 1998 in the Institute of Flight Mechanics, DLR, Braunschweig, Germany. He has a PhD from the IAC in 2002. Pashilkar was with NTU Singapore for his doctoral fellowship from 2003 to 2005. At NAL, he has been involved actively in the LCA project, which is a very important project for the nation, and development of simulation systems for other fighter aircrafts like MiG-21 and Mirage. He has contributed immensely to the developments in fighter aircraft in the armed forces. He has published more than 70 scientific articles and have guided 6 PhD students. He has also won numerous awards from CSIR and Indian National Academy of Engineering. With this introduction, I welcome Dr. Pashilkar for the keynote address.
Good afternoon, ladies and gentlemen. Professor Shantanu and my colleague, Dr. Murthy, and others. So firstly, it's a privilege to be here at IIT Jodhpur. This is my first visit to this IIT. And when this topic was suggested, so I was wondering how I will present it. So what I have done is basically robotics and mobility. What I understand from it, of course, it's going to be an aerospace perspective, but also in general where it can be applied. And then I will talk a little bit about how some of those concepts we have used in some of the programs that we worked in at NAL. And my colleague, Dr. Murthy, he will talk on the drone projects of CSIR and NAL. So I will not cover that part of it. And I will see how we can connect it to the theme of this particular Industry Day 2023 to the IIT's own programs in this particular area. What is that we knowing or unknowingly did in robotics and mobility in aerospace or in what we have been pursuing. But then how it's kind of comes all together when you talk of an academic program. So that's how I would like to structure the talk. So when you talk of robotics and mobility, I'm sure all of you are well aware of many of these areas. Today we are talking of robots for planetary exploration. You have the Mars rover, Moon rover, all kinds of things. You also have the possibility of sending robots into space. Many of the explorers, interplanetary explorers, are all basically in some form they are robots. Today there is also a need, especially in our country, for having some kind of unmanned platforms for what is known as persistent surveillance. So typically, if you have surveillance, you will have a drone or you will have a vehicle which typically aerial, because then you can cover large swaths of the land. So you have that, but then how do you make it persistent? That means how does it remain there for a very long time? Obviously, that means its power source has to be some kind of renewable power source, typically solar. So we have a project in that. So I'll talk a little bit about that. The other hot topic in today's time is, of course, urban air mobility. It's there everywhere. There are many startups working in this area. So I'll give you a little bit of my perspective, although right now at NAL we do not have programs in that area. it's quite clear that robots have been and will be used for various kinds of disaster managements, basically dangerous and dirty jobs that you would rather not like human beings to perform. So we'll look at it a little bit. And then there is this whole world of assisted mobility, which is related to basically differently abled people, how robotics could possibly help it. It's already helping. And also the other dimension of security where you augment human, whatever surveillance or patrolling or whatever with robotic, shall we say, systems. So I have deliberately listed this down from planetary, that is outer space or outside the atmosphere, to air within the atmosphere, to on the terra firma or terrestrial robotics, and then of course the next logical thing would be underwater exploration. And that is also one area where people have built robots for various reasons, and we'll see that. And today, what is happening in terms of having not just one robot, but a whole group of them working together in collaborative or cooperative fashion. So we'll look at it a little bit on that as well. So when we talk of robots, essentially we're talking of systems engineered to provide some level of, to have some level of autonomy. I mean, you wouldn't have a robot which was completely dependent on, you wouldn't really call it a robot in that sense. So of course, this is well known. So level 0 is of course no automation, and then full automation implies no human intervention, and this is fairly standard, so I will not dwell too much about it. And there are other levels in between. And we know, of course, from what is happening in terms of the driverless cars and things like that, that is where a lot of action is happening. To some extent, most of those ideas or some of those ideas being used in the aerial robotics as well. So obviously, whatever is achieved on that front would obviously find applications in all the three domains. So let's a little bit look at the planetary exploration part of it. I mentioned to you that you could typically have airships, spaceships, which are remotely, typically even today, we basically remotely guide them, and we of course monitor them to make sure that they're working fine and are along the trajectory that you have pre-planned, and that involves astrodynamics much more than flight dynamics, I would say. The other interesting thing which has opened up is not just the vehicle going, but also some kind of rovers which are now being used to send to these, to Mars, maybe to the moon, to planets or satellites uh, of interest to us. So maybe for human habitation or something like that. So it's a low-cost alternative to launching astronauts, and then the expense and the hazard involved and the recovery. So you can avoid all of that by using robotics for this purpose. And clearly, those systems have to last there sufficiently long. So again, they need to have harvest energy in some form, typically solar if you are within the our planetary system or something else. Navigate here, important point is navigate in an unknown terrain, because obviously you would have some idea about the terrain, but not everything is known, and so you have to engineer that particular vehicle. So these are all things that you have to worry about, and of course to some extent autonomy, because you are not, this possibility of repair and that kind of thing is little less. There's no human intervention possible at those distances that we are talking about. So just points which I'm picking off from some of the key aspects related to planetary exploration. Coming to something that we are doing right now, as I said to you before, that we have contentious borders with our neighbors, especially in the northern side, northeast as well. And there is this great need felt to have a platform which will persist in the air, not just for maybe hours or days, but for months together. And obviously, such a platform has to have some kind of regenerative power. So solar power is one candidate, or you could have fuel cell or other kind of things. So typically, it's been found that between this band of basically 17 to 22 kilometers is a sweet spot for those vehicles. You can achieve energy and mass balance there, given today's technology. And this is not a new development. It was thought of almost 20 years back, but today we are starting to see some of the vehicles getting realized. And the reason for that sweet spot is the winds aloft, the winds at those altitudes are year-round are on the average lowest in that range. Anything below, anything above, typically you would have difficulty withstanding the winds. So that's why those high altitude platform, or the HAP as it is called, are targeted to be in that range. And to close the mass and energy balance there, uh, you end up with a slightly bigger vehicle. We'll see why that happens. Simply because the air is less dense, and then of course solar cell efficiency and all of those things. But the advantages are obvious. One is, again, you can also, when you have a disaster where your communications are down temporarily, so you could potentially launch such a platform and quickly provide uh, mobile telephony coverage in that disaster area. So all of those applications are kind of obvious. The surveillance role I am already highlighting again and again, but that is also part of it. And you could, of course, use it for other remote sensing applications to determine land usage, or basically observe an area of interest for long durations of time for various applications. So when you look at the so-called top-level requirement, this is now from a system engineering perspective. You are looking for a platform which is capable of operating within the latitudes of interest to us as a country. So that's listed there. And longitude range, of course. And today we're talking of an endurance of 90 days, simply because there is a charge and recharge cycle. So it's all depending upon the kind of batteries, the kind of technology that you have today. It should potentially be able to operate throughout the year. Typically in the tropics, especially in India, monsoon time is when the winds are very high. So obviously you have to worry about launch windows and things like that. But once you're out of the zone of high wind velocities, then you're locked into those altitudes. You should be able to operate throughout the year if possible. It's effectively a stratospheric vehicle. So it's like 17 to 22 is close to that. And obviously it is not manned, so it has to have certain level of autonomy, maybe at least, if nothing else, just station keeping as we call it. That means you maintain a circuit over a particular point and thereby achieve the surveillance that you're looking for. And due to the challenges involved in the technologies as they stand today, it's really a big challenge even to get 20 kgs of payload on this vehicle. And obviously with the payload will come a power requirement. So, you have to set some targets and then close the energy balance with that. What you see on your right is, of course, a concept of that with 4 rotors. It could also be 2. It all depends. And here is a simulation of a vehicle, which is the Zephyr. Like I mentioned to you, this is not a new project, at least not outside of India. And one well-known example is what is known as the Zephyr, which was developed by a company in the UK. And today it's owned by Airbus, and they are making the next generation of those vehicles. And what we could figure out based on what was available is how does it work? So what is the breakup of the weight? What is the breakup of the energy? How much of it is being stored? Things like that based on open literature. And what you're seeing here is a simulation of a 3-day night cycle just to prove that it is persistent surveillance. So if we continue doing this, and what you see here in the red is of course the state of charge of the battery. So it's a very, very simple performance based model, but with the right numbers as what we think the Zephyr would be having. And the simulation just proves that it should be able to climb up there and consistently day after day maintain that altitude. So the altitude is of course the if you see the green line there, I hope you can see this. It's actually the cyan line. I'm sorry, cyan line. That's the one. So it's from sea level, let's say, to about 65,000 feet is typically the altitudes we are interested in. So this just to tell you that there are models available, very simple ones where you can use to do a system level analysis. Now, I'm not talking just about individual components, but a system level. And so why is it so difficult to do this? And why did it take a long time for even others? So you're actually demanding a lot from this vehicle. Those who understand aerodynamics, there is a quality metric called the lift to drag ratio, which is essentially how much drag you produce and how much lift you produce from the wing. So it's primarily driven by efficient aerodynamics. So if you have a good lifting surface, then you should have high lift to drag. If you look at the aircraft that you travel today, maybe 16 or 20 is what you will get in a typical, the kind of aircraft that maybe I came from Bangalore. And now you are asking this vehicle to do better than 30. So this is a step up in terms of aerodynamics, which needs to be achieved. So you have to carefully design the wing and its surface. And essentially what it means is it needs to, of course, given the slow speeds at which it is operating, and why slow speed? Simply because higher the speed, so the drag, which is proportional to the cube of velocity. So the higher the velocity, the much more power you need. The more power you need, the more power you need to generate on board. And if you look at the solar cell efficiency, today the best solar cells will give you just around 30% of conversion of the incident power to the actual useful power. So that's the challenge. So you're losing 70% there. And if you look at all of that, the vehicle size becomes bigger, but at the same time, you need to make the vehicle structure very light. So you need to use special materials like carbon fiber or carbon composites. Just to give you an idea, like I said, L by D of typical passenger aircraft would be something like 16, and now you're demanding something like 30 or 35. On this aircraft, if you want to achieve the energy balance, you're asking for what is known as the empty weight fraction or the weight fraction of the structure, something in the range of 26%. A typical passenger aircraft will be like 60%. Okay, so you want a very, very light structure, a very large structure, which means it will become flexible, which means it will also have problems for the flight control system. So that's the last point out there. The other important thing, like I said, because you want a aerodynamic surface which is primarily laminar flow, as we call it, and that's how you achieve this L by D, high L by D, which means the solar cells which you are sticking onto the wing, because that's the largest piece of area that you have, and you need to collect as much of that solar energy as possible, which means your manufacturing and the surface roughness, all of that also has to be very good. So that's the other challenge. And of course, you will not get off-the-shelf motors, electric motors, or the propellers, because you're talking of a low-speed vehicle. You're talking of custom-made motors and propellers. So all of this has to be realized. So you look at any field, basically any direction, whether it's the structure, whether it's aerodynamics, whether it's the power plant, whether it's the power system, the solar cell and all of its battery management and all of that, you will find that there are challenges here. And that's why the energy balance works out in a certain way. Again, the batteries typically in such vehicle will be about 50% of the weight of the whole vehicle. So you can imagine, and that's because the watt hour, per kg kind of metrics that we have today, even the best batteries, you're talking of automotive batteries, which are like 180 watt hour per kg or something thereabouts. And we are now expecting to close this energy balance, we need something like 400 watt hour per kg. So this is a complete leap, much higher than what is typically available. So that's the challenge that we have taken upon ourselves at NAL, and right now we are in the process of making a subscale model. Obviously, you can't address all the technologies in one go. It's probably too much risk to carry. So we have divided the program in two phases. One is a 1:3 scaled model, which we will fly, which will prove the aerodynamics, which will prove our ability to design structures which are very light, which will also prove our ability to handle the powertrain, which is a solar, battery, you know, all of that, motor, etc. So that's the thing. So let me then move on to the other part of today's talk, which is on urban air mobility. That's, like I said, a hot area. So it's believed, and most people believe that electrical vertical takeoff and landing vehicle, eVTOL, one example is given there, it's the volocopter. We expect these to be clearly quieter, more reliable. Of course, you're replacing a single large rotor, main rotor of the helicopter with multiple smaller rotors. Uh, so it makes it a little bit quieter, more reliable, because even if you lose one or two of those rotors, probably you can manage to control the vehicle and land it safely. It's safer in that sense and expected to be less expensive. And of course, all of this is aimed toward the last mile connectivity. And probably we are talking of major cities where people want to move in from the airport or from move in from different parts of the city, or even to go from the metro, main metro, to maybe a suburb nearby. So that's the kind of requirement which is driving these kind of vehicles. And there's a whole lot of companies which are working towards that. Of course, the challenges are, again, how do we get the efficiency of the powertrain up? If it is battery based, again, you have challenges of having higher energy density requirements. The other question is a little more interesting. Do you have, like you have in a cab, a driver, or do you make it completely autonomous? And if so, then how do you handle the, you have to operate in a city environment. You have to operate safely with fare paying passengers. So obviously the level of reliability and safety that you need to achieve is going to be much tougher challenge. Today it's not clear how that challenge will be met. So there are clearly challenges there. And if many of these vehicles are flying around, then how do you manage the air traffic? So that's the other part of it. So both autonomy and managing this, given the future, if even if all of the other challenges are met in terms of efficiency and all of that to meet a business case, but even these other technical challenges still remain. So that's the sobering thought. On the commercial front, already people are talking of, having single pilot operation. So we are talking now whether, so if you have 150 passenger carrying aircraft, maybe you can, instead of two pilots, people are saying, okay, can we have it with one pilot? And so what's the backup? So there's somebody on the ground, maybe the traffic controller or somebody who's playing the role of the second pilot. But there are again clearly issues of redundancy. Questions are being asked as to what will be the workload of that one pilot who is sitting there. What if he makes a mistake? How will it get corrected in time? What if he is for some reason incapacitated? What if he is fatigued? What if he is kind of overworked and sleepy? Or if he has, some kind of a, he just needs a biological break, whatever it is. So who is in the cockpit then? So these are all not simple questions to answer. Basically, what is driving all this thought process is, number one is, can we cut the cost, operating cost of airlines? Number two is, there are not enough pilots around. So can we get away with less of them? So this is again a very challenging problem. But again, what I'm trying to say is that urban air mobility is effectively pushing further into that, saying that because you have less number of passengers, right? You cannot amortize the overall cost if you have less number of passengers, and then per passenger cost goes up. So, so these are all the thought process going on, and there are no easy answers. So what I'm trying to say is, while it's good that we are working towards urban air mobility, all of those maybe to relieve congestion on the ground, but there are genuine problems here to be solved. And again, regulatory, all those issues will come up, because ultimately there is a big difference between automotive and aircraft. If something happens to an automobile, you can just maybe stop on the road or go to the side of the road. You just can't park an aircraft in the air. I mean, it will just come down. That's the bottom line. So the level of reliability that you are expecting from those systems, especially if you have large number of passengers on board, is typically 10 raised minus 9. That means you need to show that the chances of fatality resulting from any failure combination is, less than 1 in 10 raised minus 9, which is fairly small number. Let's then move on to other tasks. I mentioned to you that mobility and robotics come together well when we are talking of disaster management. Whether it is something like bomb disposal in the battlefield or things like that, or to enter into a disaster area where maybe the building or whatever is unstable and things, and you don't want further fatalities by to happen to the people who are trying to rescue other people. So that's an obvious place where you could combine robotics and mobility. Both are required, of course. So this is battlefield and disaster area scenario. Of course, then the other aspect is what kind of manipulators you provide so that this robot then functions in the best possible manner. Here, one advantage, of course, you always have is that it need not be completely autonomous. It could potentially be remotely guided, just like you have the spaceships. The other dimension of mobility would be assisted mobility, typically for people with disabilities. And that's already being proven. What I'm showing you here is the work that is going on in DLR in terms of using the brain-machine interfaces for people who are otherwise unable to have motor skills, and then the robot assisting them in some form. And what is there on the right is, of course, a robotic dog of some kind. There are robotic mules as well, which effectively carry a large amount of weight. So it relieves the soldiers of that burden. And I understand that the one on the right is currently being used in the airfields for perimeter security. So, this is where this aspect of robotics and mobility is going. I'm sure many of you know about this, but this is a potential area of use. The other aspect, of course, like I said, is the underwater exploration of various kinds, whether it is to extract or to study the mineral wealth in the oceans, to actually study the biology of all of those animals and plants present in the marine environment, or even to prospect for fossil fuels and, of course, obviously for military applications of various kinds, either for surveillance, for demining, or you can think of any number of those applications. Of course, what you have to deal in this environment is if you are going deep enough, then there is this high pressure which you have to handle and essentially have to make a pressure vessel. And given the mass of fluid around you, so effectively when you move around, you are actually also displacing that mass. So, that also adds to an apparent mass on your vehicle. So your motions, everything, the dynamics of that vehicle, of course, is then governed by what is known as the apparent mass effect. This is also true of other buoyant structures like airships. If you have airships it's basically buoyancy which is keeping them at that altitude or level, and effectively which means that the average density of that vehicle is equivalent to that of the fluid surrounding it, which means every time the vehicle moves, it moves a mass of air or water around it, and therefore, your equations of motion or whatever the model that you have has to be slightly more sophisticated. And clearly underwater, there is no guarantee that you have an unrestricted field of view depending on the turbidity or other conditions. You might have to contend with, or that vehicle might have to contend with the fact that it has got a limited field of view. So that's the other challenge there. Of course, I now come to the project which most of us at NL have been associated with for the last almost 30 years now, which is the Light Combat Aircraft Tejas. And many of the skills or the capabilities that we acquired are essentially based on this one defining project. And today, of course, it has been inducted in the Air Force, and the Mark II has been sanctioned, which will be a bigger and better aircraft compared to the Mark 1A, which is currently in service. So what I want to say here is our experience of working with this vehicle. Flight control itself was a technology which was denied in those days. But today what I can say is it is state of the art, at least for combat aircraft. and I'm sure also for helicopters. And typically, what we have figured is that essentially what we are dealing with here is a mechanical system with 6 degrees of freedom, as we call it, a rigid body, so to speak. And typically in mechanical systems, you have acceleration leading to velocity leading to displacement, right? So you have a well-structured set of equations. And one of the techniques that is straight away applicable is what we call as backstepping, nonlinear dynamic inversion. Because the group of equations are like, you have your inceptors or you have your controls, which is highlighted here in the left side, typically one for each axis. So pitch, roll, and yaw. So roll, pitch, and yaw. So you have those effectors directly driving your accelerations, at least the angular accelerations. Through those, you then affect the velocities, and through velocities, then you eventually affect the position. So there is a well-structured, set of block of equations, and so that automatically lends to this technique of block backstepping, and that's probably the most efficient way you can handle. In fact, all the systems I have talked to till now are basically either rigid bodies or, basically connected, rigid bodies in some form. And so therefore, many of these control techniques are probably straightforward, can be carried, and that's what we've found, because that's been our experience. And of course, you can make it a little bit robust. Backstepping primarily introduces these kind of feedback error terms into the correction, not just a straightforward inversion, and that has its own advantages. So I'll not get into the detail, but this is fairly well understood. And so every fighter aircraft, typically we have what is known as inner loop and outer loop, and it's a fairly well understood cascaded structure, at least for fixed wing aircraft. Of course, helicopters, there are other complications because you have those rotors which are moving and they have those dynamics there. But again, ultimately, it's the body which you're controlling is the fuselage or the rigid part of it. And that's what you are trying to orient or place from place to place. So in a sense, broadly speaking, you will find this for all mechanical systems. There should not be a surprise there. So effectively, that's what I would say we have learned from our work on fixed wing aircraft. The other aspect which we worked on, primarily related again to flight control, and to the fact that one of the good features that you can build into a flight control system is ability to basically prevent departure. Departure is can happen when you aggressively apply the controls and the aircraft loses its basically it essentially goes into attitudes beyond its normal range of flying, and you might have flow separation and things like that, or you could lose speed, and then because dynamic pressure directly controls your control power, so you're effectively losing control efficiency. So one of the things that you need to do is make sure that no matter what the pilot does, you never actually lose your velocity, even though the pilot has not given enough throttle. So the simplest thing you can do is basically take control of the vehicle automatically at some point and put it down in the direction facing gravity, so you again recover the speed. Just a simple exchange of potential energy with kinetic. And for that to happen, you need to know where the gravity is. So, remember, a fighter aircraft can do all kinds of maneuvers. So, at any given point, you need to know which is the direction of gravity. And the two angles which are most important is the pitch and the roll angle. If you know these two angles, you effectively know with respect to your own axis system in the aircraft where the gravity vector is, and you can orient that. And for that, we then developed some kind of a strap down inertial navigation inside the flight control computer. So there is, of course, something outside already available, but that was not sufficiently redundant enough. So what I'm trying to say here is that while solving the flight control problem, we also had to look at how to get sensory inputs which are not necessarily directly available, right? So the sensor side of things. So just an example there. And of course, today it's quite expensive to make combat aircraft. LCA is 4+ generation. The AMCA, which is currently under design, is a fifth plus generation aircraft. And these aircraft are very expensive. So most people are now talking of, can we have unmanned combat aircraft? Here is an example of one uh, unmanned combat aircraft, which is essentially no pilot there. So again, there is a level of autonomy required and things like that. So you have one extreme where you have very expensive manned combat aircraft with all kinds of sensors, which are designed to protect the aircraft and the man. But they are fairly large in size. They have a large range of operation. And by removing the man and all other associated systems like oxygen generation and all of that, can you then have a unmanned combat aircraft? And the other extreme would be to a swarm of drones. So you have, what's the advantage? So obviously you have large number of them. The cost is less, easy to make. They are probably, you don't mind if you lose few of them. So you could potentially cover larger area. And since there are multiple of them in operation, so obviously there is some level of parallelism there, which you can probably exploit in some form. And even if you lose a few of them, if you can have some level of cooperation between them, then they can reorganize themselves and do the original mission that you send them out to do. So these are all the benefits, low cost, and technology is readily available. Maybe you don't mind losing them. So so there's one extreme of a fifth generation combat aircraft with great deal of expense, time, and certification efforts and whatnot. And then the other end is you have low cost drones, large number of them, and with a different paradigm shift. So autonomy of the group in that sense. And of course, what is understood is if we want them to coordinate and cooperate, we basically just need these three things. You just need to ensure that they are maintaining separation between each other. They are broadly aligned towards the direction in which the average is moving, and that any outlier tends to come back into the group. Just these three uh, rules will ensure that the whole flock stays together. I mean, that's been seen typically. So the idea is here is where all of those ideas of AI and communication and coordination can be exploited. So you have one extreme where you have a very expensive piece of hardware, manned aircraft. On the other end, you have completely unmanned a swarm of drones. And of course, people talk of mixed manned and unmanned. There are obvious advantages. Maybe you send these unmanned systems first. They are smaller, difficult to detect, and their sensors are coordinated with your sensors. So you get a quick look ahead before the enemy knows what is happening. You have had a look at their defenses. And even if a couple of them are shot down, your manned aircraft is safe. So there is this whole, mix of manned and unmanned. So you have one extreme of manned, you have the other extreme of completely unmanned, and then you have a combination. Obviously, it requires a certain level of communication and coordination among those things. So this is all being done, and I'm sure you will see it in our country as well in due course of time, just to give you an idea. And this is where robotics and mobility probably will play a very big role, all of those concepts. So just to summarize, basically, what we are essentially dealing with here is multi-body dynamics, at least, or in many cases, it's primarily a rigid aircraft, especially like the combat fighter aircraft that we talked today. One example I showed you was the high altitude platform system, which was kind of flexible simply because it was very large. But primarily all of them in some form are mechanical systems where there is a clear relationship between the degrees of freedom. Acceleration leads to velocity, integral of that is displacement. So you have a structure to it which you can exploit, and that's where I suggested that probably backstepping or nonlinear inversion in that form makes sense to use, and we have found it very effective for fixed wing aircraft. In terms of autonomy, you still have the challenge of guidance, navigation, and control. So backstepping control only addresses the control part or the inner part, but you still have to worry about guidance and navigation. And here is where you could consider some kind of multi-sensor fusion, where you have sensors on board, inertial sensors, which are protected otherwise because they are inside the aircraft and are therefore able to, you can use them if they are sufficiently accurate for long periods of time, but they tend to suffer with drift. So you augment them with other systems maybe optical, electro-optical, infrared, radar, LiDAR. All of this is there in the domain of terrestrial vehicles, also in some of the aerial vehicles. And of course GPS, but there is always the chance that GPS is denied. So you must augment with some other form of sensor so that you are able to locate yourself and conduct the mission from a known point to some intended point where maybe you do surveillance, maybe you drop a weapon or just drop some supplies and come back and stuff like that. So all of those issues will have to be solved if you're talking of some level of autonomy. And of course, depending on the application, you would have to design actuators and manipulators of some kind to do that. And I think when you're talking of coordination and autonomy, AI and ML will enter into all of this. So therefore, I'm just listing out things which I thought is a common thread across all of those systems that we talked about. And I showed you some examples of what we have done as part of the effort for the LCA, our own aircraft. I'm sure Dr. Murthy will talk about how they are doing it for the drones. And ultimately, the system complexity has to be handled. So like I said, these are all multi-body dynamics. So we have fairly good mathematical models available. And so therefore, a control system design and all of the associated prototyping can basically be done based on those models. So today, model-based system engineering is very much available and possible to engineer these complex systems depending on the requirements. So you map the requirements and design the systems to meet that. So that's basically what I had to share. I had a quick look at the kind of courses and the themes that you have. I'm sure you're teaching all of this. I don't think there is anything new. The argument being that if you learn that well, then all of these potential applications are out there. Maybe there will be specializations depending on what the real application is, but this is all possible. It's in the realm of possibility. And at NAL, we of course, like I said, realized some of those things. So that's it. Thank you. And be happy to answer any questions. Yeah.
If there are any questions, you may ask.
Nice talk. So I'd like to know what are the major challenges in physically building drone swarms and deploying them in real life critical scenarios?
Yeah, typically I think maybe that is best for Dr. Murthy to answer. But what I can say is, I think in the recent Republic Day, last year's Republic Day, there was 1,000, the size of drones, and there was about 1,000 of them which were flown in formation and all that. But that it was shown, yeah. So basically, but that is a level of autonomy. If you see that SAE scale, it is orchestrated. So they had every drone knew exactly what it was doing. It wasn't basically doing sense and avoid. It wasn't dynamically doing anything. It is like a static program which, and of course there was a limited level of, you could see some of them falling off the sky and then switching off and coming
Yeah,
down.
that's some sort of predefined patterns they need to follow.
Yeah.
That's
So
just...
that is one type of technology which is already out there. The question is, what about the next level of autonomy? So today, for example, if you're talking of, let's say, you want to send out a set of drones, what we today call as loiter munitions. So you send out drones with the explosives on them, and they are just loitering around. Okay, if they find a target of interest, then they will attack it. So this requires you to have good endurance, as we call it, the ability to stay up in the air for a reasonably good period of time, maybe 1 hour, 2 hour, whatever you can have. The ability to actually detect and identify. You might detect, but then you need to know whether it's something which is a target, which is of interest, to us, and then act on your own to actually then attack it. So it involves now all of those steps that we saw, detection algorithm possibly based on computer vision, positive ID. You don't want to create an international incident. You don't go and hit somebody who's not supposed to be hit. So all of those things potentially is being done today, and I think in our country also it will happen. There are already people who are able to prove swarming of various kinds, schooling, foraging, and all of that habits of multiple drones. They're able to coordinate the drones in a dynamic fashion, not just a static program. That's happened already. In fact, there was a competition called the Meher Baba Prize where 3 of those people were able to show some level of capability in that direction. So that's already happening. So I would say that it's just a matter of time when you will see that capability being used. And you've seen, I think, in the recent war, it's just basic harassment you can do, right? I mean, because it doesn't cost you much.
Yeah.
That was the point, that when you have large number of these and they're acting autonomously, you don't have operators controlling anything and they are working. So in a sense, you are sort of the collateral damage that you would suffer if you were to send a manned vehicle in the same scenario, you are sort of removing that part of it. So it's probably easier to convince your people that, right? So all of those things where you have these, the one which was there about 10-15 years back is uh, the drones which the US was using to flush out militants in Afghanistan and things like that. So now things have become much smaller and much more capable. So so all of that is happening and it's already there.
So where do you see India in future in this industry, like making autonomous drones and all those things?
I would say uh, the capability is there, but whether we are able to indigenously do it, because the minute somebody knows that you have that capability, they'll start denying you the sensors.
Yeah.
They will start denying you certain other critical equipment. Uh, so that is where the challenge now lies. That are we able to be Atmanirbhar in the manner which allows us to pursue our policy without somebody intervening? So there is that challenge of microprocessors being available in sufficient numbers, high quality GPS or INS sensors being available for you to be precise in terms of navigation and all of that, having the optics and the the sensors for the computer vision part of it, which is
and batteries also.
Batteries as well, things like that. So that's so realizing that vehicle, like I said, it's already been shown to some level within the country,
yes.
But all that hardware or much of that hardware would be still bought from various sources, and you obviously don't want to buy from a certain country. Let's put it that way, which is readily available. So those are the next follow-on challenges from. You can prove the concept obviously in a lab or anything using those components, but you have to insulate yourself from the consequence of that.
Yeah.
That they might deny you next those technologies.
Thank you.
Yeah.
Sir, are there research in alternative propulsion systems like other than rotatory wing or fixed wings like?
Yeah, at NAL for smaller vehicles, we have a pulse jet engine which we have developed. We have a Wankel engine which is like an IC engine basically, but based on the Wankel, the trochoid and all that. We've made a small gas turbine which is like, I think it's 5 Newton thrust. We also designed one which is currently operating, which is like, I think one kilonewton thrust, so about 100 kgs and things like that. But very critical would be an engine, a turbofan, the core jet engine. If we master that with its associated challenges, then we need not build an aircraft around what is available. We have the flexibility to design the engine the way we want the aircraft to perform, because both of them have to be matched up, right? I mean, if you have a motor you need to match up with the vehicle performance as well. You can't have a underpowered engine or a overpowered. Both ways it doesn't really work. One case your efficiency will be poor, the other case you will just not have the performance. So here is one technology which if we master the gas turbine technology, then lot more opportunities open out for us in every type of aircraft, whether it is an unmanned aircraft, whether it's a manned aircraft, it's a commercial aircraft, it's a military aircraft.
Sir, one more question. Like, is there technology that we are developing and world has not developed? Like, we are first in that.
That is a difficult question. Off the bat, I cannot say that, but there are certain areas where probably we are equal, if not better in terms of that. Mostly our challenges are in terms of handling specialist materials typically required for like for example, engines could be a case where the turbine blades, for example, require very good manufacturing and ability to handle high temperatures and pressures. In probably when it comes to all the algorithmic side of things, I think we are probably equal to anybody else in the world. When it comes to the hardware side of things, probably we are not doing that well. Like I said, the potential always exists that once you develop the system and prove it, you will not get the components that you need. So that is where I think the challenge really is for all these systems that we need to do. But I would say on the software side, I don't see any reason why we can't make equal or better software than what is already being made anywhere else.
Sir, do you have any proposed solution or like in which way we should go forward to address this challenge?
So what happens is if you look at the way we work essentially or we are trained is to have domain knowledge in a certain area. But like I said, when you want to make a product, it is the coming together of different things which will make that product work. You may have to compromise and arrive at something which works rather than to do best in one discipline and then compromise something else to the point where the whole system doesn't work. So this is where managing the multidisciplinary aspects of a project, probably project management. I would not even say project management. The way we think about the product, not just the technology. Every technology we have people who are specialized in that. But when you try to put together one or more technologies, what is the correct optimum for that vehicle to be realized? So I give you an example of a solar vehicle. Because of all those constraints, you have to find out what will make the whole vehicle work. So you have to look at it at a systemic level, not just at technology level. I think those are the skills we need to develop, which means that large number of teams working together with different specializations should know how to talk to each other and not, basically to arrive at what would be a realizable vehicle rather than keep insisting that you do this way and then I will do this way kind of story. So that is where teamwork probably will make a difference to all of those projects where there is complex set of technologies which need to work together.
Thank you, sir.
We may have one more last question.
Good afternoon, sir. Sir, my question is regarding how do we decide on the degree of autonomous nature that is to be there in the system? For example, we have a system which is performing surveillance, or the example that you just now gave, like a drone which is accompanied with explosive. So, how do we decide how much autonomy it should have?
So sometimes the level of autonomy depends on the level of technology that we have. That means if I define a certain level of autonomy, whether I can reliably achieve it and prove it. That means I gave an example of 10 raised minus 9 is what a commercial airliner will have to show whoever is designing that airliner, whether it's Boeing or Airbus or anybody or in India. So if your components or if the systems are not designed and you are unable to prove, then obviously that is not a realizable level of autonomy. So you have to settle for something less because there is a technology constraint. In some cases, the use case, as we call it, or the requirement itself doesn't demand autonomy. Because always when you build in more hardware and software, it costs money, right? I mean,
Yes.
it'll cost time, it'll cost money. And so your window of opportunity for that product is a function of, like, if it's required now, and if you are not able to provide it, then the customer will go and buy something else or substitute something else. So you have to, that's where I said the system engineering piece becomes important, that how do you match the user's expectation against the solution side. So there is a problem statement. The user will say, I want something which will do this, right? So he will couch it in terms of what he wants. And you will have limitations. You can't, put the most costly thing. There may be cost implication, time implication, or we simply may not have understood. Like, in the morning, there was a discussion on whether we understand smell itself and things like that. So obviously asking for that in an autonomous framework will not work because that solution doesn't exist. Even with the solutions which do exist within the cost and time, how do you build a system together which brings all the various disciplines? And sometimes you may just have to tell the customer what you're asking is not possible. So, can we have something else? So this is a dialogue which has to happen between the user and the designer. And, you have to figure out where the limits lie. Otherwise, you will end up either prolonging the program in the great hope that one day it will happen and you just keep doing it, which is okay for research, but it's not good for business because, or for the end user. So this is where product development is different from research and development. So somewhere the project director has to take a decision saying enough of this is what we are going to build, right? And he has to tie up with the customer to ensure that he will accept that and ensure that the design team doesn't slip the goal. Otherwise, even that will not get realized. So this part of the process where you dialogue with people, different teams, and you dialogue with the end user, if we get that right, then the system will be there in time, within cost, and so that's really something which probably all of us who are trying to make products should learn.
Yes, sir. Thank you, sir.
Right now, we're actually running out of time. Dr. Pashilkar has a flight to catch also. So we express our sincere gratitude for having visited IIT Jodhpur. As a token of appreciation, we would like to hand over a memento to you. At this moment, I would invite Professor Shantanu Chaudhary to hand over a memento to Dr. Pashilkar. After the interesting talk from Dr. Pashilkar, we will now have an expert lecture by Dr. V. Satyanarayana Murthy, Head of UAV Division, NAL. Dr. Satyanarayana Murthy has been working in the Flight Mechanics and Control Division of CSIR NAL since 1992, and in 2016 he took charge of MAV unit, which is Micro Air Vehicle Unit. His current focus is to bring out a mini UAV. His main interests are in flight dynamics, flight controls, and in developing UAV-related technologies. He is associated closely to the LCA control law development, which was developed for the Tejas LCA Air Force and naval versions. He has been involved in the design, development, and testing of flight control laws for civil and military manned aircraft, as well as unmanned aerial vehicles for civilian and strategic applications. His interests are control law, image processing, product design, LCS, flight simulation, design of rotary UAV for agriculture and mining application. With this introduction, I welcome Dr. Murthy for the expert lecture.
No, already go. Just close it once. That is once. What is one? It's fine. Good afternoon. It's my privilege and first time I'm coming to IIT Jodhpur. And actually, Professor Venkatesan is the one who has asked me to come and present it here. And I sincerely thank Professor Santanu Chaudhary, whom I know from his Siri days, and Professor Sai. And you can, I'm audible, right? Okay. So, as you know, post lunch, after my boss has delivered that lecture, I have to now talk about something which is a little difficult. Anyway, I'll try to cover what we have done rather than getting into what it could be and all those things. Let me just say what we have done and where we can collaborate each other and go forward. Rather, I would restrict my talk there. If you see it here, in this slide, you'll see a fixed wing mini UAV. Way back when I had taken this charge earlier, I was working happily on the flight control algorithms for the light combat aircraft group member, going on very well. Then they made me to make something like this. So Indian Armed Forces were looking at aero environments, Raven unmanned air vehicle, a small 2.5 kg weight class vehicle. So a lot of talk was happening in the newspapers, it is coming and all. Then we also started. Okay, let's make. So we made it and we have proved for some applications and all. And I will tell you then what has happened. After that, we moved to multicopters. So here we have good success in this. Then the obvious thing is combining both of them. So the third one where you see is the fixed hybrid vehicle where you get the vertical takeoff and landing and the crew is, the forward flight is fixed wing. So that's where we are. If you see the third one is not a real picture, it's from the CAD we have taken because we have completed the hover and forward flights we are under testing. So I'll talk most of these vehicles and all how we have gone about. So my talk I have arranged like this. The drones, what are all available at NAL? Then the second one, anyway, our director has already talked about high altitude platform, but I will give you a little glimpse what is going on. And I will talk about the facilities where you can come and use in NAL, maybe students or faculty who are doing the research work. And a little bit on the subsystems where we can collaborate and go in this direction, because institutes normally we look for some kind of technology. So that is where we can do a collaboration. So I will talk a little bit about that. Then we have conducted a lot of beyond visual line of sights. So visual sights, if it is going, if you can't see the flight, there is the beyond visual line of sight. Of course, line of sight should be there for the communication. So then if you are conducting the visual line of sights, the UTM services are mandatory. That way I will, just one slide, we are working with another startup company. I will talk about that. And our future program, just a thought process I will give. If you see this, as I talked, my first project was this, the Suchan Mini UAV. It's a sub 2 meters wingspan vehicle, is about 1.85 meter span and 1.47 meters length. We could carry a payload of 500 and 700. Mainly it is hand launch and belly landing aircraft like Raven class, as I told you earlier. So we have designed in such a way that we can take off, launch it at higher altitudes also, maybe at Leh or something like that. So we have designed our flight control, hardware, software, everything we have done. Then after doing this, we have to show, market the aircraft. So we have gone to some institutions to show the perimeter monitoring, then target tracking. So if you see it here, the target tracking is a little bit, though image processing algorithms are working this, because smaller smaller vehicle, wind always tries to throw it. Again, we take comebacks. Therefore, you see a little bit of, not little bit, good amount of jerk in the video what we capture from that. So we thought we can improve based on the user requirements. Here one thing. The second application where we have done is, we went to Asansol, where the Coal India excavates this from the mines. So we have done a survey there, tried to estimate the amount of material they have taken out from the land and all that. So the simple way is, just on the Google map, we used to map the area where we have to survey, and then do a raster scan with good line of, good mapping, overlap and all that. After acquiring the pictures, we were using this AG software or Fix4D, anything. Then created the orthomosaics, then digital elevation models, and try to estimate the excavation quantity and all. All this we have shown. I thought we are good for the marketing. But everybody says good. But by the time multicopters have become more popular, and these vehicles, they need a little bit of airspace for clearance for takeoff and landing and all that. We are out. So nobody was taking. I was also disheartened. I thought, let me not do all these UAVs and I'll go back to our original work. But then our sister laboratories from IHBT, that Palampur, they said they are doing some agriculture work. Anyway, you people are working on UAVs, can you do a multicopter which can work, take off and land at their altitudes, about 2.5 kilometers is there from the sea level. So and then said, okay, fine, at least some user is there, now let's work. That's how we again continue to work on this one. This is the multicopter. We have also procured one multispectral camera. If you see that from the Alta Sense, it has 5 bands RGB, red edge, and near IR. So it has a capability again about 700 grams, 500 grams to 700 grams. And so we did good amount of survey there with this vehicle. After that, again, the same process. After you do the survey, you acquire all the 5 bands, then mosaic them, create the false composite figure image, and after that, using that NDVI formula, we used to supply them the NDVI graphs to our agronomists. And with the truth table, they used to compare how good it is and all. They could categorize this Latin name and all I cannot pronounce. This is Rose Garden, that is. So After that, they could, with the truth table, they were comparing and all. They were very happy with this one, and they continued to work on this. And we have published one journal paper on that, lot of citations and all. At least we are happy something is coming out from what we are doing. Then another laboratory of ours, this is the National Geophysical Research Institute in Hyderabad. They are doing a lot of aerial, from the helicopter, they do a lot of survey, magnetic survey or electromagnetic survey to identify the resources in the beneath the earth. So the first one is they have bought one magnetic magnetometers from Canada. The one whatever is flying there, they bought it. Then we developed one hexacopter for this because the payload requirement is about 5 kgs, 4 to 5 kgs. So the requirement is the payload has to be attached to it as a slung load because it should not. It should be little away from the magnetics of the aircraft motors and all. That is the reason why it is slung. So we have done successful flights with that. So again, one user is there, so we are doing, if not to the outside, at least for the CSIR laboratories, we are doing some service. So near Hyderabad, they have identified a place where there is a magnetic anomaly. So they said, let's go and do there and try to. This is the first time in the country anybody is doing with a drone and the magnetic survey. Helicopter things are there. And it's a good experience. Same thing we have done. They have carried, 2 people were carrying, and the line you can see on the left hand side, the dotted graph, that was from the manual survey what they have done. Whereas the UAVs, it was so smooth and quite good. And we repeated a couple of times to say that whether our procedure is good or not. They are also happy, and again one journal paper has come from this one. We are going on well, we thought. Then we had an internal discussion with my team members, what we should do. This is all fine. We should find a little bit more. Then most of these startup companies, you will be finding 100 plus companies, drone companies across the country. So that time when we took up this project, they're all about 10 kg payload and all. Okay, let us increase the payload 20 kgs because little investments are more and flight control algorithms are little tougher and all those things. So we took up that because we have that mathematical background, control design and all. We are good in that. So we took it up. So this is what the vehicle we have realized. This is our right now the work hours. Including the payload is about 56 to 60 kgs is the max weight. Payload it can carry about 20 kgs. With 20 kgs, I can give you 20 minutes endurance. The flight speeds up to 14 we are flying because that is where we are finding the optimum power efficiency. Again, if you see the central hub is composite plates and all those things, and the remaining are composite rods, and it's a fully autonomous. BV loss, as I told you earlier, the beyond visual line of sight operations we have taken on this aircraft, and we have introduced some mechanical coupler so that joints so that we can fold it for carrying easily, and we can tolerate 2 motors values and all that is a digital sky complaint or blah 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 is everything we have done. Then we have approached some farm produce organization FPOs whether is it good for the pesticide spraying and all. Actually, it turned out to be really good. So we could carry about 18 to 20 liters of pesticide and spray autonomously. There's no manual interaction. Yes, that is what no one can afford to have pilots everywhere. In case of failure, something is required. Otherwise, they were all very happy, this farming community and this one. Yes, a bigger vehicle in 5 acres in 2 sorties with 1 charging, we were able to do that. As I said, so this is for the folding and all. We were using the lithium ion batteries here. Lithium polymer batteries. Ion are little heavier. Foldable propellers. It's about 3 meters diameter vehicle. So that time we were not having a professional tank, so some tank we have attached, and after that we electrostatic nozzles and all we have used it for impinging properly on the crop. So it's a complete autonomous takeoff, and you give an area, calculate the raster scan, and then it does the proper spraying. Then you can control the amount of spray what you want, depending on the agronomist, whatever they want for this crop. Then we said, our director said, why don't we show to minister? Then we have requested them, our Minister Science and Technology Minister, to show something during the COVID operations, whether we can carry the vaccines using this vehicle. So then he said, no, don't do in Bangalore, you please come to Jammu. I think he's from that area. So the next operation what we have done is, we had gone to Jammu. Of course, a lot of trials we have done in Bangalore. Then we have one laboratory in Jammu. This is almost a central part of the Jammu. So from there we took off, and close to the border there is one PHC mud, I think. So that is where we have gone and landed there, and that's the vaccine box what we are carrying. Across the city we crossed, and then you can see the landing. Okay. So after that, again, that Ladakh government asked CSIR what you people can do. So CSIR laboratories are cutting across all disciplines. Then NGRA proposed that we do the hot water springs, thermal springs to map. Again, with the magnetometer, we went there. It's the toughest experiments in the lay, because altitudes are high. As you know, the density comes down quite a bit. Then we reduce the payload, and the kind of power what we have designed for this vehicle, it could sustain the huge winds. Normally in the afternoons, it becomes very, very tough, and the terrain is also, suddenly one cliff will come and becomes a valley, and I have to fly close to the earth to get the data. Otherwise, if I'm away, it is not. So terrain following was another major problem here. So we have successfully done this flight test both on the Magnetic Hill and Chumtang area. So of course, this has paid us a lot. After all these things, when we publicized, about 6 to 7 companies had come, though I thought a lot of companies are there, nobody wants this. But 7 companies had come and taken our technology. Now they are building their own vehicles. Ooty, the hill terrain, the carrot and all those things, autonomous spraying, one company is doing, and another company is a lot of applications. Now, after seeing, we sent this video to Army. So somebody is asking for the last mile delivery. Probably next week we may have to go there. So though a lot of companies are there, some demand still we are seeing for this vehicle for high altitude operations. Some USP has to be there in the design. This is the landing. Okay, anyway. So in Wings India, we were asked to demonstrate a lot of aircrafts were not there. So our director said, you bring the 3 drones you bring and fly. So in the formation we have flown. I'm not finding the cursor here. Let's leave it. So the obvious thing is we like to combine, because a lot of people are asking our range, even we are giving 10 kilometers going, coming and all, they are not happy. Border security, all these people are now asking for a higher payload, higher range. So the way is I can't keep on increasing the battery. It doesn't work out. So we have now we have designed a new vehicle which combines both vertical takeoff, vertical landing, and then fixed wing. It can carry about 5 kgs payload. It's about 4-meter wingspan vehicle. And out of 120 minutes of endurance, 10 minutes wherever he wants the hover will give, the remaining 110 minutes to reach the 30 kilometers and come back and all. So the two payloads currently what we are envisaging is a gimbal payload with the camera. It could be EO, IR combined, and some kind of emergency drop payload. So our director has talked about this HAPS. Little bit, I will not cover too much because anyway he has covered it. The idea is it flies at 20 kilometers and tries to see the, observe the Earth for the ISR operations. So you can put a payload of 4G, 5G communications in the battlefields and all those things, that's fine. So what is required is a very long persistence is required. Therefore, you need to harvest the energy that is from the solar. A fixed wing aircraft, solar electrical powered, is just simply propeller driven. The important thing is the semi-rigid vehicle. I'll talk a little bit on that semi-rigid because we can have a good collaboration work on that. Today, the only 2 companies who have succeeded out of 8, 9 companies in the world, Google to Titanium, so many people, even the Boeing, all are facing problems. The 2 successful people are FASA 35 from BAE Systems, UK, and a startup company, Kinetic. This is a very small company who have achieved the success. After that, they were acquired by the Airbus. So the last flight they have succeeded is in 2022, and August 18th they have landed. Is about 65 days, I think. 64 days they could be they were in the air. This is the longest what I know. So now, with the kind of borders what we have, so a lot of requirement has come. Government has forced us to take up this kind of project. So I don't deal with, he has told about a lot of things. What are the design challenges? That it should be lightweight structure, because you see the wingspan is about 32 meters. The whole aircraft weight is about 125, something like that. A Boeing span and a motorcycle weight is a rare combination. It's very, very challenging work. So the light structures, then they become, I think a lot of structural engineers must be here. The structural modes will be automatically very excited in this aircraft. So I will come to that one in the next slide. So the challenging available subsystems are high density batteries and high efficiency thin solar films. About 400 watt-hour per kg is the battery what we are looking, and there are suppliers who have supplied to Jeffar and all those things. But in India, anyway, I'm not expecting these things to come. And therefore, they are becoming very, very expensive, and the vehicle cost is going up. I don't know how to solve this problem. Both solar films as well as the batteries. The flight dynamics, little bit. I have not included any equations. If you see this, how do you get cursor here? I got it. So if you see this one, the rigid body dynamics, all that you require is the stability and control derivatives from the wind tunnel you do or CFD you do and get it. And the mass property is for the flight conditions you get from the structural designers, and some propeller data, thrust data you get it. You are good for the rigid body dynamic model, you can do simulation. But what happens is this flexible aircraft. All flexible, the modes generally in a fighter aircraft or the civilian aircraft where we fly, the modes frequencies are quite far. It's about this 9 to 10 hertz, something like that, above 7, 8. even for a fighter aircraft. Whereas in these light structures, they are very close, 3 to 4 heads they come, and they mix with the rigid body dynamics. It is a complex problem. So therefore, generally in this paper, I think somebody has written very neatly. You may refer this paper. And we are also following this now to build our mathematical models. So we are currently doing the GVT, ground vibration test, we call. So with that, the model frequencies, model shapes, and generalized masses, we are creating them. After that, we have to give the combined aeroelastic, the softwares are quite good right now to generate the effect of this dynamics on the aerodynamics. The structural dynamics on the aerodynamics, we are capturing that and then integrating them to be a bigger nonlinear simulation model. This is a good work, and I request some of you to take up this kind of work. It's not going to be solved within a few days or something. We may go ahead, but it requires a lot of refinements and all those things. So that is what I was saying. At a particular, in the aircraft, normally what we have is the short period mode in the longitudinal axis, which is quite faster mode. Is about 2 to 3, 1 to 3, somewhere that it lies. At that frequency, somebody is, if the same paper guy has done, he has increased the Q bar. That is the aerodynamic gain. When he is increased, the structural modes, if you see, it is cutting the imaginary axis. The flutter is happening at the same frequency. This is the complex. That is why this has become the complex problem. And very good research they have done. They have manufactured an aircraft to get excited at those frequencies. The flexible aircraft, they made it like that for their research. So I strongly feel, even if incidentally, I'm the member in UAV panel of AR&DB. If somebody can put proposals in this area, we will be very happy to support there. Coming to the facilities for the low speeds, we have an exclusive tunnel for us, with us. It's within my division. The test chamber is about, if you can see it here, is about 0.8 meters by 1.2 and 2 meters length. And it's the flow is really good, clean, and because the base chamber is quite good, and we have the facility to create the gust. And if you are a student, we don't charge. If you have a project, very, very minimal charges I take, and you can come and utilize our tunnel for this kind of. It need not be, aerial vehicle, anything, wherever you want the characterization, you can come forward and use it. If your students are there, we welcome them. We also have a propulsion characteristic rig where you put load cells and all, try to estimate some people design the propellers so we can test it them off wind, and we can always move this total rig into our small tunnel, and characterized with the wind. So this is another area, because anyway, I'll come back to that. So hardware wise, we were initially designing our own hardware, our own software. If you see the complete model-based design, just generate from the Simulink, you generate the auto code and burn it onto our board, and all that we were doing. And another group was making the autopilots for us. So it was good. During the fixed wing days we were doing. But when we wanted to do everything on our own, the time taken to execute the entire thing is prolonging, and we are unable to maintain the pace with the world. Whereas the sensors are improving, the processors are much more powerful processors are coming, we are unable to maintain that pace. Then we said, okay, somewhere we have to compromise. And then I have moved to the Pixhawk, you must be knowing. This is a popular autopilot hardware. It has everything. Then I thought, why I should unnecessarily spend my time in the hardware. So we generate our code in the Simulink and burn on this. So we control design, still we hold it, but hardware I'm using it because it has duplex sensors, duplex power I can give, a lot of things it has. And for the HAPS, the high altitude platform, this is not good enough because it has to meet the certification requirements and all those things. From the M-mentioned Veranto autopilot we are using. And this is another hardware area with maybe the startup company. We have all the know-how for the software side. And if we can combine and create one hardware for India, I mean, that will be really good. I mean, that should be sustainable hardware development, not like one time you develop and leave, it won't sustain. Yes, changing environment. We have the full setup for the testing. Even if you have vehicles and all, you can come to us, we can do the complete testing. Composites, NL is quite good. We have autoclaves, ovens, everything. So in-house manufacturing is really good. This is another area, is again for the mechanical people. So when we were asked to fly in Leh, I was looking at it, is, you know, as the altitude is increasing, the density is coming down, even for a specific RPM, the thrust generated is coming down drastically. So what is that I can vary? In the aircrafts, normally the active blade angle changes they do. I can't put some more weight to the already suffering vehicles. So we looked at it, whether the initial blade angle itself, depending on the altitude, can we change it? Then we took the bought out propeller, we made the 3D scan, and you can see the lines there. So at each point, critical point, we have generated the aerodynamics to using the open source exploit. And then using the blade element theory, we have optimized the blade angle for different altitudes. You see here in the left-hand side, at sea level, the efficiency is the gram per whatever we consume, so watts we consume on the aircraft, about 9. And as the altitude is increasing, we are reducing to 7. So the performance is coming down drastically. Then with this offline setting, depending on where you fly, anyway, we are not flying from the sea level to 5 kilometers. We are launching at that place. Then we optimized it and tried to get it. Still, a lot of work has to be done. If some students also can work on this kind of thing, I'll be happy. So beyond visual line of sight today, just like that, you cannot fly. The drone rules 2021, they gives their type certification also they are giving from the QCI. QCI is the body now to certify these drones in India. You can fly only in the visual line of sight. Only 400 feet is your altitude, this thing. Lot of restrictions if you want to go beyond visual line of sight. We have gone through the entire process. It took months together with a powerful director at NIL. Previously, he had good connections with MOCA, DGCA, Air Force, and all that. I mean, these are the set of documents we have produced over the time. And after looking at our manuals, our safety features, after this thing, then they have enabled us to fly beyond visual line of sight flights. That's how we could do that vaccine deliveries and all. So these are the permissions what we got first in 2021, then renewed in 2022 for the, if you see it here, there is red zones because after 33 degrees of north, it comes, the whole airspace is controlled by Air Force. So we need to take special permissions for that. That is where that red zone is permission we had taken. So for enabling this beyond visual line of sights, you need some kind of automation in the traffic management. Today, if you see, we were doing all these beyond visual line of sights by talking to the respective ATC in the near area. We are taking the slots and then flying, but which is not possible if everybody wants to deliver something. That mobility, what you are talking in the aerial mobility, if you have to do smaller mobility, anywhere you cross your 200, 300 feet, we are unnecessarily, after 500, anyway, we are entering into the space, airspace of the, for the passenger traffic and all. And lot of helicopters fly close to the ground. Then some automation is required. There are 2-3 companies are working on this unmanned traffic management. We have joined hands with this some particular company, so that it is not right now. It is not helping me. Maybe we are trying to help the agencies to formulate some rules by giving the data, how we can do autonomous management and all. We are working on that. So coming to the future, so we are again asked to carry 100 kgs now. So day by day, my payload requirement is increasing, and you see here the load is about 75 kgs. You see some coils are there. It's a very interesting work. The sensor we have developed, thinking that those days I was not working in multicopters. So they said, like Volacopter, what our director had shown, we can buy one aircraft and give it to NGRA so that they will fly. That was our thought process. Because I said I had no experience that time. But I can tell you, even today, I have gone through the entire purchase process. Nobody is quoting. For a 100 kg vehicle with 40-45 minutes of endurance, still it's not available. Even a volocopter or recently E-Hang has shown in Dubai Air Show, it's just short flights they were showing. So it is a little confusion. So we have started formulating this one. So to beat this with battery, in our performance calculations, we are unable to meet any kind of combinations with the about 200, 220 watt-hour per kg. That 400 whatever we showed for the HAPS, the C rating is quite low there. 0.5 is good enough there because huge battery bank they are carrying, and the amount of power you draw is very less, about half a CEV, right? Whereas in the multicopters, we normally draw about 5. The power density is quite less in the lithium polymer or lithium ion battery. So we have talked to one French company which said they promised us to give turbo generator, aerial turbo. So we would like to install there and use this one. And lot of work again in this multi-body dynamics. Somebody wants to work along with us, you are welcome. Yes, 100, about 75 to 80 kgs is moving like not even like a regular pendulum. You never know how, with the winds where it goes. So we started modeling them using this Simscape. I think maybe you people know, with MATLAB and Simscape together, we are making those models. You are welcome to collaborate with us in this. It's a big vehicle, so good name. Let's hope we succeed in this. Thank you. This is my email if somebody wants to.
We can have time for one question if somebody would like to.
Hello. So I work in distributed swarm robotics. So our objective is to design distributed algorithms. So is it feasible to design such a swarm of your products, which actually helps us to simulate our distributed algorithms?
Definitely, no issue. No issue. We can see. Our vehicles will give you the independent control. The swarm algorithms should able to give us the next waypoint, and the speed and the direction in which I have to move. You understood?
Yeah.
The loops are defined properly. One is
because
that
the cooperative nature, that's the system is
let it
distributed
see,
and
whatever the cooperative nature. See, even our algorithms, how do they work? Control algorithms. We have an inner loops which mostly take care of the damping, frequency, that kind of stuff we take care. Okay. The outer loops will give the speed and all those things, little slower loops. Outermost loop will give me the waypoints where I have to go. That we convert into this one. In a swarm, what happens is that outermost thing, the demands will come from the swarm algorithm.
Yeah.
Therefore, if you can provide that, our vehicle will take care of those things, this part.
Okay.
So we can work together. There's no issue in that.
Thank you.
So some 3 aircrafts and all we have flown up because we had no that fancy of 1,000 and all we cannot create. There's no.
So are you interested in, simulating such a distributed algorithms
Sure.
with your product?
Sure.
Okay, then
Please
I
write
shall
to
write to you.
Please
Thank
write.
you. Thank you.
If time permits, we can take question.
Yes.
Yeah, please.
Do you foresee role of private industries in time to come as far as Indian aircraft businesses are concerned? Because major roles have been paid by HAL and NEL.
No.
And there are other government organizations as well. But do you see private industries come up and then?
See, as far as NIL is concerned, we are a research organization. We don't want to produce the vehicles. After 1 and 2, we would like to transfer the technology to at very, very cheaper price. We transfer the technology. So it is the private industries who take up and make the aircrafts. And regarding the research, there are so many private industries. They are also doing very well. But only thing is unique things we are taking up. Oh, LCA. LCA, now you are seeing a lot of Rafael is going to be manufactured by again is for the production organizations, private industries are coming up, not for the design and development. Maybe design and development still holds with the government organization, DRDO, NAL and all those things. But ultimately, see, today our production partner is HAL only for either LCA or SARS, whatever it is. Now that scenario will change. Private industries will take over.
Thank you.
You're welcome. Thank you.
One more question.
Yeah, good evening.
Yes, ma'am.
Yeah, I have a question. Actually, I had this question from the previous speaker, but I couldn't ask, and now I just need your views on that. So you said that the previous speaker said, and you were also speaking right now, that the research and development in the lab to the product development for commercialization, there's a huge difference there. And he also said that while we may have ideas, we may have the software, but when it comes to actually producing, we don't have the sensors or the components or the parts. So does this mean that we'll always lag behind? It's sad that we have ideas, but we don't have the components. And what role do you think the MSMEs can have a role to play, especially with the Atmanirbhar?
Okay.
Thank you.
Thank you. Yes, census wise, we have a problem. Actually, we started making the census in our own CSIR laboratories. Siri also started making the accelerometers, gyros, and all that. What happened is the quite good census they made, but it has become a little heavy. We could not use them. We could not integrate with our computational board for the autopilot. But I'm sure down the lane, if they work continuously in miniaturizing those things, someday we will meet. Till that time, maybe sensors we will buy, but other hardware we will take it. There's nothing wrong that we have to do everything.
I think after the session, you would have enough time to pose your questions to Dr. Murthy.
Yeah, I'm not going like our director to home today.
Yes, so he's around during the tea break and during the poster session. You should surely meet him and talk to him further. So thank you so much.
Thank you.
Next, we especially thank Dr. Murthy for the interesting presentation with so much practical applications. And drones is something which we have a lot of interest in, and we also have people working in the area of drones. And to understand about the activities that is happening at IIT Jodhpur, I invite Dr. Niladri to present briefly.
want to say?
Good afternoon. To pursue research in the field of robotics and mobility systems, IIT Jodhpur created an interdisciplinary research platform named as IDRP Robotics and Mobility Systems. The primary objective of the IDRP RMS, which we usually define that robotics and mobility systems on IDRP, develop an ecosystems to promote research and technology development in ground, air, and water-based mobile robots, and collaborative robots for defense and civilian applications. To pursue indigenous research, to cultivate technological solutions addressing growing demands in electric vehicles, autonomous vehicles, and drones, to produce professionals with in-depth knowledge and analytical and experimental research skill to handle robotics and mobility systems problems, to establish collaboration with industries, R&D, organizations, and the government. So in robotics and mobility systems, we have currently more than 25 faculty members. Those who have joined from various departments like electrical engineering, mechanical engineering, computer science, civil. Various faculty members has joined to solve the problems related with the robotics and mobility systems. So I view the activity which we actually do in IDRP RMS, it has two parts broadly. One is the offering academic program, and another part is the pursuing research in that field, right? So currently we are offering a BTech specialization on robotics. Besides, we are also offering MTech specialization, MTech program on robotics and mobility systems. I'm quite sure that based on these two lectures, it's quite clear to us that how robotics and mobility system is connected, right? So quickly we can also understand that it's not working. So even if we can also think that the future mobility systems, will not be only mobility systems, that's the conventional one currently we are using. We can also see that the changes are coming in terms of the energy, in terms of the autonomy. So we are also saying that Google car and also the EV fields. So the future mobility systems will be also embedded with several tools and techniques of which will comes from the robotics domain. Looking this program, we also think that the area we are covering in this MTech program is a very huge domain, and that's the reason we have subdivided in three micro-specialization. The students, those who will actually opt this MTech program, they can have a micro-specialization in the area of autonomous mobile robots, unmanned aerial vehicles, and EVs. So they can choose any one of them and do the micro-specialization. So currently we are running this program, the MTech program, in regular and executive mode. So the regular students and the executive students can, of this master's program. These are the key objectives of this program, and the eligible branches which can, of this master's program. Regarding the research activities, currently we are our faculty members, those who have involved in our IDRP RMS, especially they are pursuing research in these areas, mainly in the bio-inspired robotics, where faculty members are working in the flapping micro aerial vehicle, medical robotics, mainly teleoperations, rehabilitation robots, mobile manipulators, cooperative robotics. So swarm, multiple robots are performing certain tasks, formation control problems, autopilot for drones, amphibious robots where robots can have a mobile, it can goes to, let's say, air, water, and the ground. Besides, also the faculty members are also working in the the security issues in the field of robotics. Let's say while robots are working together, there may be some sort of security issues. Faculty members are also working in this area. Human in loop control, mainly in the semi-autonomous systems. We are interested here. Faculty members are contributing. Computer visions and haptics for robotics, the communication technology which will be applicable for the robotics, EVs, mainly in the area of electronics for EVs, the charging infrastructure for EVs, and the motors, traffic management systems. In these areas, faculty members are working, and some of the posters are already up. I think it's posted in the outside of this room. Besides, the faculty members are actively working with the TIH, School of AI, various defense lab, and the DRDO Industry Academia Center for Excellence. Thank you. So if you have any queries related with these areas, please contact the faculty members. In the area of we have the websites where the details are available. So if you have any queries related with this field, please contact.
Thank you, Dr. Niladri, for the detailed explanation. Next agenda is panel discussion. For panel discussions, we welcome Dr. Murthy to the dais. Next, I also invite Mr. Nishant Kejriwal. He is currently heading the computer vision for autonomous and driver assistive systems at the High-Tech Robotics Systems Limited. I am excited to say that Nishant is an alumni from the first batch of bachelor's program from IIT Jodhpur. After bachelor's in computer science, he has over 10 years of experience in the field of computer vision and robotics. He has published several research papers in the field of robotics. I also invite Dr. Suril Shah to the dais. He has been with IIT Jodhpur since 2015, and he currently serves as associate professor and the head in mechanical engineering department. I also invite Dr. Sai Kiran to moderate the panel discussion.
Thank you, Dr. Ribi. So the main agenda of this panel discussion is to see how we can have a more engaging industry and academia collaboration. And also I thank the panel members for taking the time out and participating in this discussion. So without any delay, I'll begin. So the first topic that we framed as part of this discussion is for Mr. Nishant. So what are the current and future research trends that you are looking in the areas of autonomous mobile robots, where those are very much relevant to industrial interests?
Yeah. So first of all, good afternoon, everyone. So it is heartwarming to, to come back at IIT Jodhpur after 11 years. Okay. So I hope it is audible now. Yeah. So, I mean, it's privileged to be here after 11 years of, graduation and coming back at IIT Jodhpur. It's geographically or not, we can't say geographically, it's at a different location. I could not relate, once when I entered the IIT. So, but now slowly while, with having the interaction and kind of work that we are doing here, I can see the how institute has how much institute has grown up in terms of the faculties, courses, the work that you are doing. It's truly inspirational, and I don't think that uh, I mean any other institutes in India is involved so uh, involved at a very cutting edge skill sets that are required in the industry right now. So um, I'm right now working at High Tech Robotics. So I take care of the system software and the computer vision for different robotic application, be it ADAS systems, autonomous vehicle system, or mobile robots. So I'll talk about the kind of work that we do at High Tech Robotics. So basically, at High Tech Robotics, we are transforming the legacy operational workflows with human-centric, AI-driven, software-defined systems. So each of these words has, a, a key meaning around that how we want to take up the case of autonomous vehicles. How do we want to approach the AI? Should it augment or should it replace the humans? How secure it is, how reliable it is. So from that point of view, we have two different themes at High Tech Robotics. So we have one is in mobile robots, where we work on products like forklift, autonomous mobile robots. Then we have pick assist, which then we have cobots. So these are the kind of products that we build in the mobile robots umbrella. Then we have ADAS and AV division, where we work on more towards road logistics, which is basically it can be a driver assistive system products, it can be fully autonomous vehicles as well. So we have experience of around 15 years in autonomous vehicle domain. We have been deploying multiple fully autonomous vehicles use cases for confined areas. We are in production. We have deployed more than 20,000 ADAS systems in India for commercial vehicles. And this system has been in production since 2018. We have around 3.5 billion kilometers of data of Indian roads, where we cater Indian specific scenarios. We cater Indian specific use cases in addition to what global standards is. So in terms of technology, in terms of area, these are the major areas that we work on. Coming to the key problem statements or the research areas that where we are working on, and they are more aligned uh, to the market requirement. So, I mean, you can assume that till 2010, we were mostly working with the defense setups, with some industries for projects and R&D, everything. But from 2012, I mean, it started commercialization. So, right now, I can't say that academia is much ahead of what industry wants. I mean, industry is ready to adopt to whatever technology is available, and there is a huge market pull, particularly in the domain of mobile robots and autonomous vehicles or for assistive systems. So from that point of view, I think the gap has reduced, and maybe industry can easily collaborate with the projects and for the products in terms of the technology that the market is requiring. So I'll just touch upon few of the key problem areas where we are working on when you say mobile robots or assistive systems. So one of the problem areas where we work on is you know digital twin. So I mean, in the morning session, many people were discussing how metaverse should be, how it will be related to Web3 and everything. But digital twin in terms of intra logistic, that means the manufacturing setups and the warehouses, it is a need of the hour to design the solution with the digital twin. That means the customer should be able to design the most optimal solution when it comes to how many robots are required, how should the workflow should be, how can I reduce the cost. All these can be part of the digital twin ecosystem. Second use case around digital twin is you can get the real-time visibility of the what is happening in the manufacturing setup. So this is one of the very core area where we are working on. to provide a real-time visibility and also interact with the industry, with the manufacturing plant in real time with this technology. So that is one of the area where we are working on. Second is one of the, since this is very, fast moving area where customer wants the solution with the help of AI and everything, very, with a very less turnaround time. So turnaround time for any feature is very less as compared to market, as per the customer. So in AI ML generally, it is right now it is data intensive, so it takes a lot of amount of data and everything to come up with a solution. So what we are working on is a deep sense platform, which basically, which has some key properties around that. One is, that it is immunized to the adversarial attacks, because the cyber security things are very, very important when it comes to industries and warehouses. They don't want their data to, get out of their premise. They don't want their processes, systems to get hacked. There are n number of cases. So immunization to the adversarial attacks is one of the key problem in the deep sense. Second is, how can we, reduce the learning time of any AI stack with deep sense? That means, let's say tomorrow I don't want to pick a object of this shape. Maybe I want to pick up a very small nut and bolt to, from a robot. I should be able to do it within iteration. That means a week's time. How can I do it? Can I show it to the camera and, with the deep sense, can I do, okay, this is how you can pick it up, just take it and start working on that. So that is the kind of thing that is we are building in the deep sense platform. Third is, it should have the active learning component. That means you can't say that, you have covered all the use cases that you can encounter in real time. Hence you need active learning. But when it says active learning, you can't have this learning on your cloud, because the data cannot go out of the industrial campus. Hence it has to become an active federated learning, where, many of some of the faculty and the discussions were happening that there is some work going on in federated learning, but that is the need of the hour of the, the current product that we are building. So that is the second theme where we are working in terms of deep sense. Third is, so there is, we are conceptualizing a mobile Novus factory. Right now how manufacturing and warehouses works is, for any kind of new product manufacturing, they set up a huge line in terms of, conveyor belt and everything, even with some robotics help. But what we are talking about is mobile production stations. That means your assembly is going to happen on the mobile platform, which is mobile robots. Your cobots will be also be moving platform. So we are talking about essentially flexible manufacturing platforms, where you don't need a large space, you need very small space, and you can manufacture anything on that platform. Recently, we have assembled, certain use cases for a Ford car, which was, picked up on a mobile robot only, and the robotic arm were also on the mobile robot. So, and you need a very high precision in terms of, localization and the perception stack. It is required in some MMs. So that is, the kind of technology that we are looking for. So that is another area where we are working on. Similarly, fourth is, right now the problem is, for any installation or for any robot, maintenance or anything, you need to go to the site to take care of it in terms of teleoperation, maybe mapping, and there are different use cases that require person to be there. How can we solve this problem reliably with the invent of 5G and other localization solution for this use case? Similarly, many of the people who have worked in robotics, localization as a problem statement. One of the very important problem around it is that if you have there are two types of problem in this. If you have a static and dynamic environment, or a structured and unstructured environment, the problem of localization becomes very difficult, even with sensors like lidar and camera, in case of unstructured and dynamic environment. How do we solve this problem, keeping in mind the performance and cost of the, the product? Ultimately, this thing has to go in product. And eventually, how can we solve this localization and entire perception problem for any autonomous systems with the pure cameras? So these are the kind of areas that, we think that is the need of the hour, and they need some efforts from the academia maybe and the industry come together and solve this real life problem statements for the customer. And when we say that we want to solve the problem, it means that it will be delivered in the product. It's not just an academic research, or with some performance metric we want to do. The deployability index of it is 100%. That means the any research that we do around it, it will go in production, it will go into the robot, and it will be deployed at a scale. So these are the key areas where the kind of work we are doing and can be aligned with the any academia or the faculties who wants to work in this area. Yeah.
Thanks, Nishant. So my next question is for Dr. Murthy. So Dr. Murthy has given an excellent presentation wherein he highlighted the needs of the government, whether it may be the military or the civilian applications. So considering these different needs for the nation from the UAV perspective, how can IIT J, the students and faculty of IIT Jodhpur, can become a partner in in developing the technologies which will meet the needs of nation?
Oh, thanks. In simple sense, what I say is, making a product takes a lot of time. Building the whole vehicle, proving your technology, everything is time consuming. Your students may go off, new students will come and all those things. So what I would say in a simple way, you develop the technology, maybe a small subsystem. You collaborate with us. We put into our own vehicles and we prove the system. That is the easier way of collaboration. And coming to the disciplines, I was just talking to Professor Sai and others. Yesterday I had discussions with Professor Venkatesan and with your director also. Coming to autonomous vehicles, the level of autonomy, there was a question also. So today, whatever we are doing in our drones, the level of autonomy is not high at all, because to improve the level of autonomy, we need a lot of AI. The situational awareness becomes a key role to give. Today, you have seen in my videos, we are landing on, we have taken the vaccines and dropped at a certain place. So to enable that, what we were asking the other person to give me the lat-long of that position. So our vehicle is going there to the defined waypoint, and with the LiDAR, we are estimating the altitude. Even on a rooftop, everything we are able to do that. But the situation will not be like this. The situation will be in the real time, I need to assess where I should be landing. For those things, I need some kind of AI. So that area, if you people can work, we can collaborate each other. The second thing, sense and avoid. For these vehicles, it's a major issue when many number of drones are flying in the sky. Sense and avoid algorithms play a major role, like on the roads. Just now, our colleague, whatever he is talking about the road vehicles, the autonomy. Same thing happens to the aerial vehicles. So sense and avoid is a big topic. And for you people, it is a suitable topic to work on for a limited period of time, which we will again convert into the required shape and all with our vehicles, and we will integrate with our larger frame of work. So that is another area where I would like to see something. And I don't know how many, since aero department is not there, so I will not be talking about aero department vehicles, whereas mechanical systems, again, multi-body dynamics, multi-body joining, and I have seen in the posters, you people are working on robots and all those things. So, and in another project, we are working on robotic arm attaching to the drone to pick up maybe dangerous materials and all those things. So that is where you, if you people can work on, but that the arm, whatever you are developing, it should be compliant with the drone. It should not add another dynamics to the drone. So those are the things we look forward from the academic industries, academic institutions.
Thank you, Dr. Murthy. So, Professor Suril, you have a vast experience in the academic research. So, how do you think, or what is the support you need from the industry in order to make the technology development more focused towards the societal or the market needs?
Yes. So at IIT Jodhpur, we strongly feel that industry and academia, they can combine and it may play very key role in catalyzing innovation and growth in technology development. While industries, they are majorly focusing on addressing problem which address the needs of near future business values. Academia, we are majorly involved in generation of new knowledge through research and training the students. And if we can come together, it may play a very important role in arriving at breakthrough in technology development. So I feel what I would like to briefly talk about is how like we can work together and what are the different possibilities which may eventually lead to what you mentioned. So at IIT Jodhpur, we look forward to having active and strong collaboration with industries where we can work in the form of small research projects where we may work on a problem which would be slightly long term, because industry may focus on short term problems which may have business value for them, but they may not have bandwidth to work on problems which are slightly more futuristic, where we can develop knowledge generation, we can do research, we can have problem defined jointly with industries or research organization, and we can take this to TRL 2 to 3 level, and subsequently industries can help us in doing knowledge translation or translation of technology. And perhaps we can come up with interesting technology and research as a part of this. In addition to that, there is also possibility where there can be active engagement of masters and PhD students, where there can be joint project guidance in the area of mutual interest, where we would be collaborating. There is also possibility that they may also have some extended lab at IIT Jodhpur, and we would be glad to host it, whether it is a technology park or it may be a department, isn't it, where some joint facility can be developed and explored. We would also be interested in engaging undergraduate students, because we have very active a flexible undergraduate program where students can spend one full semester with industries as a part of engineering innovation. And there is possibility where these students can be engaged for engineering innovation. And even there is possibility where master students can start their work at the end of first summer jointly with collaborator from industry and faculty advisor from IIT Jodhpur, and then we can identify an interesting problem which can be taken up as a part of master's project. We also emphasized on IP and system development as a part of our PhD and MTech program, and there are a lot of various possibilities where we can collaborate. We would also be glad to participate in designing some of the courses in the niche area of robotics and mobility system. For example, at present we are running our MTech in robotics and mobility system, and we are also planning specialized certificate courses as well. At present, Cognizant, like we are running executive programs for Cognizant, where their engineers are participating in this program in weekends. So these are various possibilities where we can engage
and that may help in further knowledge and technology development. Thank you.
Okay. So any other panel members would like to add anything?
Thank you. Actually, normally we invite students, either master students or bachelors, but not at first or second year. Maybe probably third year it will be ideal for us because you should have learned basic engineering by that time. And masters, yes, if you identify a good problem, we can host you for a semester. There's no issue. But the problem has to be defined properly, and with your guide and with us, it should be mutually agreeable. And let's aim to solve one problem at least in that 6 months period of time. So you're all welcome to NAL. We have almost the kind of disciplines you have here. We have kind of same departments in NAL. We can connect you to the proper scientist over there. Thank you.
Okay. So my next question is a general question for the panel members. So currently the Indian companies are no longer a national players, but rather they are becoming global players. But their investment into the Indian academic research is not still up to the mark, or it is yet to improve. So what can be the methodologies that can be thought of which can improve the current investments into the Indian academic research?
So I think, as I mentioned, that the gap between, I mean, since academia is also interested in what the nation wants and how they can help the industries to provide the better value proposition to the final customer, become innovation. I mean, do innovation rather not just invention. So I think now industry also understands that it will not be just a project, but it will have its outcome in terms of some commercial value in terms of product or anything. So maybe since this gap has reduced, and with the help of the kind of coursework and the interdisciplinary, transdisciplinary coursework that many even IIT Jodhpur are doing, I think this will eventually be this gap will reduce, and I mean everything will fall in place. So I mean the time has come. I think industry is well aligned, because one of the problem that industry faces is right now a skill gap. These are the niche skills, and not many specialized people or engineers or are available with any experience. There are but they are in scarce. There is there is limit to it. So hence with this, if academia is interested in aligning it with the industry, this will solve the investment problem or any other thing, and both will be aligned, and I think it will be a win-win situation for both of them.
Other panel members would like to add anything?
Yeah, one thing I'm looking at it is today the government is no longer asking institutes like us, yeah, we are publishing so many papers, so many this thing. They are not caring about it. What you are giving to the society is more important for them. So the best way to involve the involve the investments from the industry is if we have a collaborative project with them, with the industry, the government is supporting our part. So that way, the bigger projects can be executed. Maybe we should invite more industries in our own area and combine with them, and so that at least 50% of investment comes from them. We are trying a lot in this area. So maybe you should also look into that.
Okay. I just wanted to add briefly to this that as an academia, now we are more open and we are looking forward to work on a problem which are of mutual interest rather than problem coming only from academia. And I'm sure this will lead to more funding and more active engagement of industries and projects which are of collaborative nature, where there is equal partnership from both academia and industry.
Okay. So before opening the audience questions, I'll have one question. So In these 2 days of Industry Day program, have you seen any foreseeable collaborations that can be made with the teams at IIT Jodhpur?
So I see there is a definite synergy when it comes to the kind of work that we do at the organization and the kind of work that you are doing. Um, there are problem statements that we want to address, and I think it will have some synergy with the work that the work which is happening here. So we can't right now say that the exact work can be picked up, but but as far as my understanding in the discussions with different faculty members is concerned, I think there is a synergy, and we can take it up from here, and it will be a joint. There can be joint discussions around the problem statements that industry wants to solve, and the problem statement which academia wants, IIT wants to take up, and wherever our synergy is there in terms of the project that we want to take up, uh, we can go ahead with them. Yeah.
Yeah, I agree with him. The ecosystem is good in your IIT. That's what I have observed for the last 2 days. I think specifics have to be worked out.
Sure.
So let's be in touch. We will work together a little.
So thank you very much. I'm hoping there will be soon some collaboration areas we'll be working on. So any questions from the audience? Yes.
Thank you for sanctioning, sir.
What sort of lump sum amounts you got from these 5 industry to whom we have transferred the technologies? Some rough idea, not the exact, or the kind of royalty which you have offered.
It's not, it is like two parts. One is the one-time payment, like on technology transfer, one-time payment, and the second one is the royalty. So we have selected MSMEs, so we have offered them at very, very reasonable cost. So that the idea is, see, to come to the mature level of this one, they have to invest for another 2 years of their time, manpower, and everything. So we have subsidized quite a bit, sir.
Well, agreement. One announcement actually. IIT Jodhpur has already signed one umbrella agreement with CSIR. I think 1.5 year or 1 year back when DG CSIR visited here. And NAL being the part of CSR headquarter, one of the laboratories, I think Dr. Murthy, which he is suggesting that cooperation can be initiated. So this is a good opportunity for the MTech and BTech students to visit them and do their projects over there. Thank you.
Any other questions?
I'll give it.
Good afternoon, everybody. As Nishant sir pointed out, cybersecurity and attack detection and mitigation is a very important aspect of the systems these days. So I wanted to ask Dr. Narayan Murthy sir to elaborate on the security aspect of the octocopter that he discussed.
Yeah, there are two things. One is anyway, between our ground control station and the aircraft, point-to-point contact. So every message is checksummed and sent from here to there. That is one level of security we have. And that standard AES 255 compression will be there with the key. That is another security we are giving. Beyond that, we don't have any other security features on our octocopter. But normally, if checksum is not matching, it will throw away the message.
So thank you. In the interest of time, you can meet the panelists offline. So they'll be here for today. And thank you for all the panel members for participating in this engaging discussion. So as a token of appreciation, I would like Professor Suril to present a memento to Dr. Murthy. Also, thank you, Mr. Nishant, for taking your valuable time out and spending 2 days here to understand the possible collaborations area with IIT Jodhpur. So I would like Professor Suril to present a memento to Mr. Nishant. I would also like to thank the audience for participating in this session, and sorry for delaying the next session that is supposed to happen now. Yeah, we can next.
So this concludes our session. We'll continue with the poster session, and during tea, you can have a look at the poster session. Thank you so much for joining.
This is what you want.
Can you delete that presentation?
Yes, sure. So what was it? This is, I think, I don't know.
पहले आप एक बार पेन ड्राइव देख लो यार कहाँ गया वो होस्ट वो होस्ट करेगा तो लैपटॉप लेकिन इसमें बहुत सारी आईडीज हैं No, no, no. No, there is an empty port there, no problem. Connect with this chat. You're connected with this. No, sir. Just that will be better. You put the pen drive in that system? Yes, sir. Yes, sir.
मुझे तो
Okay, we have to. Okay, so he's I'm the pen from doing that. As a pandemic, he's a pandemic.
कौन सा वाला है
इंडस्ट्री में अच्छा वो मैम
आप देख लो एक बार ये तो रवि सर की भी वीडियो होगी ये फ्रंट स्लाइड है नाम चेंज कर इधर इधर लिख के है रवि ये रवि सर की
एक मिनट मैं कॉपी कर लेता हूँ।
अच्छा आपको कॉपी करना है कॉपी करके
कॉपी तो करना पड़ेगा।
अच्छा अच्छा ठीक है where is my anchoring
Same. Yeah, this one also. The Word document can keep it safe. अब करो नाम जो भी करना है।
रवि किया ये रवि सर की और वो मुकुल गुप्ता की नाम चेंज करो यार
Can I set up my laptop? I am the next speaker. So he will set up his own laptop.
Yes, sir.
No, he will need his laptop because he will be demonstrating something physical. He has his device.
Okay, sure.
Which is connected to the laptop.
Okay.
And on the laptop, the simulations will run.
We will actually assist it after I start actually the
No, he want to check also.
Okay. Yeah, sure, sir. Definitely.
Whether you have PowerPoint?
Yeah, he actually we can put maybe this thing.
There is one more if you want, because this will drain your battery when you connect.
So, sir, if sir wants to connect to a laptop,
He will no, you are first. No, you are the keynote. So Ravi will introduce you, and then you will start. You are Suresh Peringili. Carry कर भी देखे. No, that's why.
Maybe you can.
I don't want that. No problem. So that is where you will be basing the will need that. Huh? You're not getting internet? Yes, hotspot. No. It's mobile Wi-Fi. When connect this not. It doesn't need internet. So he is going to mirror my iPad. Mirror the screen. इसको थोड़ा निकाल. जैसे what we do in TV, no? So we mirror the screen. Oh, I have to connect to the. No, that is broken. It's broken. We connected to online also. It's also. No, what webs we need to share on. So you, sir, I have given you a link. You share the link with us. Yes, sir. इनको share कर दिया. So they have shared the link in your email. Correct. So if I connect, then I should be connected to internet, which is good enough. Yes, sir. So they will. I'll log in your through my Wi-Fi. But that's a problem. I tried with Gaurav's. When I'm trying to connect your Wi-Fi, this one and this one, this is not better. Because because you are using Wi-Fi frequency for that. Okay. It's team has. Let's see the content. It's for PowerPoint. Or alternatively, what can be done? You can give us the. You will need a software. Okay. To demonstrate the software screen. Then you have to then what you can use the LAN cable. No, because we need other connection for Webex. Right. Webex में तो stream ही करना है. Stream के लिए चाहिए ना. Stream के लिए चाहिए. यहाँ पे दिखाने another laptop. यहाँ पे दिखाने के लिए. No, we will try with your connection. We have LAN connection also. Oh, you LAN connection also, Suresh. Wire. वो तो है. Wi-Fi भी कनेक्ट करना है. एक मिनट. We'll try with your Wi-Fi. Then it is okay. मैंने गौरव का लॉगिन से किया. Some reason I didn't. Alexa से laptop. पीछे. इसको इधर रखो. Like that. Keep it this way. Okay, now I am connecting to my. Trying to connect over internet through your cell phone. If I connect to your Wi-Fi, oh, let's try. What happens? What is this? Is Yes, IIT. Connected. I have to put the credential. Sir, it will again ask for. No, I'll give mine. No, मैं अपना login डाल दूंगा. मैं इसे बार-बार मांगता रहता हूँ. IIT J बना. IIT J कौन सा है? ये आपका वाला faculty का. उसमें तो ऑथेंटिकेशन बार-बार नहीं होता. किसमें? आपके वाला. मेरा faculty आज तक चला नहीं. I have been writing to them, but anyway, 1 घंटे तो नहीं मांगेगा. मेरा किसी का भी डाल सकता हूँ. No. गौरव का मुझे पता है. Which Gaurav? No, don't give it to Gaurav. Gaurav will have a copy. Let me give mine. Because data bandwidth restrictions will not be there. Yeah, you're on now on this. This is working fine. Fresh. Yeah. Now you give me this. Okay, then. Now am I checking this? That is done, right? Yes. Same. You have to connect both same. No, same only. It's also same. But same login में करके देखेंगे. Forget कर लेता हूँ. से आ रहा है validity. Should ask yes. It is very different. How can we change the keyboard to a computer keyboard? What do you want now? I want letters over here, which I remember it by on what number it is. No, you want this, not this. Which one you want? I want this. No. You want upper letters? Upper letters on these numbers on a computer keyboard. So usually they do it from here. Yeah, upper letters. Yeah. Search where are they? Because there is a keyboard. This keyboard, different keyboard settings. Confirm keyboard settings. Because it should be something similar to this. Okay, anyway, don't worry. How can you open this? अभी आ गया ना? आ गया ना? वो वाला कहाँ चला गया? That present at least. Oh, take it. JM नहीं कर रहे ना इसमें edit अभी है. If required, then you know it has come. So how will you do it if it doesn't work? Then? So I'm looking numbers here. How do I go here? Dollar sign. Ampersand. Dollar sign. Dollar sign. Ah, okay. Ampersand. इसको डिलीट करना पड़ेगा एक क्लास लेटर. So it's so simple to do it on computer. Because everything is in sequence. Yeah. Some number sequence. Okay. Yeah, but now the problem starts. Connect तो हो गया इतना कष्ट करके. Air server is on. Air server is on. Little mirror. And आप लोगों का network में mirror नहीं हो रहा है. You know, it maybe they will not have allowed some firewall issue or something like that. Can it be? But what is the? ठीक है. Okay. So उधर भी connect हो रहा है. हाँ, so they have sent you a link. वो email. हाँ, email. That will not be a problem. Where is it? अब भेजा? कहाँ भेजा? Can you refresh? Okay. Okay. ये है ना? हाँ. Yeah. That is. You have a Webex here in your system? ये है ना? हाँ, yeah. It will automatically install when it. No. They are company systems. They cannot install anything. It's not an institute kind. Cisco Webex we have used before. Yeah, you just do it through this. The browser. So now I am connected to yours. Yes. If I switch to my mobile, will it connect back without all this authentication? Should be. No, this to you use this for internet. So I have the movie equivalent embedded in the PPT, but I want to show. Okay. But there is a three levels laptop. If we unmute your one, it will be equals on all over the system. Unmute. Yes, sir. Okay. But we have three level system. So if you unmute here, then the would be the other WebEx system, why it should be on? Because we from that WebEx system, streaming live, you know, this is getting live streamed on YouTube channel. Oh, so they are using that WebEx to fuse it with YouTube. So this bot currently is only online. If once they push it online. So what I will do is everything will do in the system itself. That is why he's installing WebEx. So that we need not to change the system again and again. What is this? Password. It will be pen and this one to three. I have it. Otherwise, log on. Let that system also not connect. Right. So enjoy. Yeah, computer already. Software is there. This is being recorded. System. No. Now it will. Hello.
They will be able to hear.
Yes, sir. From in the system.
Now I have to share this, right?
Yeah.
Share my PPT.
Yeah, from here.
Share.
Yeah. Or what you do, Suresh, is share entire screen. Do entire screen share.
What about share computer audio?
Okay, that's even.
There's some video.
Try once that playing thing. Yeah, minimize this. Yeah. Play the video, then I will.
Where is this one?
Yeah, it is not coming there.
I will increase this size of this.
Oh, वहाँ जाके करे. Yeah, no, side. हाँ वो आ रहा है लेकिन वो स्क्रीन हम बिलाते हैं ये ठीक है
But yeah, those times try to switch.
हाँ I'll be here only.
So what I will do, I'll keep this connected to that fellow. Wi-Fi.
And you are putting this to what? Your mobile?
To my mobile. Okay. And if I connect this to my mobile, this gets mirrored.
Yeah. Okay. In that you put pen drive.
Already we have transferred actually. So,
No. So if you go down, they will invite you for the talk. You're ready, right?
Let us speak from here.
Yeah. You want to call a mic?
I can.
Okay. They will put a color mic. Suresh, when you come on the stage, they'll put a color mic and keep it here. Yeah, you can put it here, no problem. So that you don't forget, you know. वो आएंगे तब आप फिट कर देना पहले सर इनवाइट करेंगे उनको दूसरा वाला कहाँ है उनको बुलाओ कॉल पे लगे ये देते हैं है ही नहीं हाँ बोलते हैं सर सुबह बुला ये आऊँगा no they should make it no there's a problem actually we have bought a system they are supposed to do it क्या कर रहे हैं अच्छा ये है नहीं ऐसा
Government is not connected to their system.
No, these are student volunteers. They are searching the staff who can enable in that system. They reject what I did. Again, maybe problem, real problem.
Air server. Can I minimize this? Can't minimize this, huh?
It will not be seen, Suresh. That's okay. Screen, to they will see this.
No, but for me, this is becoming a.
You can hide it like this. Yeah, no, hide it here. No problem. You don't need to see that. And then you make the screen active. Yeah, that's it.
Hello.
भैया
Hello. Good evening to all. Hello, everybody. Once said by respected Prime Minister of Malaysia, Dr. Mahathir Mohamad, in Beyond Paradigm Summit of 2019, the fourth industrial revolution will change the kinds of jobs needed in industry. Our strong view is that as a nation, we must create the jobs of the future. Our goal must be to automate work, but humanize jobs, allow machines to do the dangerous part and repetitiveness, and ensure we humans have the capability and the capacity to do the creative, empathetic, and interactive. With this, I would welcome Honorable Director Sir, Chief Guest, industry experts, delegates, faculties, and students for this auspicious Day of Industry Day 2023 celebration and to the section Industry 4.0. Technologies that are emerging today will soon be shaping the world tomorrow and well into the future, with impacts to economies and to the society at large. Now that we are well into the fourth industrial revolution, it is critical that we discuss and ensure that the humanity is preserved by these new involvements so that we can continue to prosper. And just to offer a flavor of it, I would invite Professor Ravi K.R., Associate Professor and HOD Department of Metallurgical and Metals Engineering, to introduce us to Industry 4.0. Sir, kindly have the rise.
Thank you. So good evening to all. So first of all, I would like to thank the industry experts coming all over from all over the India and coming here and they're going to give a lecture, and also thank faculty colleagues, students, and other members. So when you look at any industrial revolution happens not only based on the field what we are talking about, the field, the allied field. In allied field, what are all the revolution, the changes take place that decides what kind of evolution it is going to happen in industrial revolution. If you ask me, like, we have moved from industry 3.0 to industry 4.0. I hope we are all aware of what is the difference between industry 3.0 and 4.0. So some of them, if it all, they are very new, then I can say industry 3.0 talks about automation. Means suppose if you have a robot, it can be autonomous robot. You have any system, it can have closed loop control. It can actually correct on its own, but that is within a machine. But when you talk about, suppose you have two machines, one machine had problem, then other machine can solve that problem. That is where the industry 4.0 comes into picture. That means there is something sensing, there is connectivity between one machine to another. So that is what we call the difference between industry 3.0 to 4.0. That is possible mainly because of the revolution that took place in sensors and IoT. So that led to the development of industry 4.0. So now not only one machine to another machine can interact, in an industry, all the machine can interact with each other. Not only from one industry, one factory to another factory, a machine can interact with the human can interact with the many machines. So that is what we call industry 4.0. So it's basically a cyber physical system where you have cyberspace comes from this revolution that took place in IoT, like machine learning, deep learning, and AI. So that led to this particular development. So in today's talk, we have three industry experts. They're going to share their experience, how this industry 4.0 changed their industry. So what kind of expertise or what do you call the people they required in the industry. So that kind of information also will be given during this presentation. I hope audience will take some takeaway from this particular next 1.5 to 2 hour of program. Thank you.
Thank you, Professor Ravi K.R. With this, actually, I will invite to our keynote speaker, Sri Suresh Peranjari, who is the Manager of Solutions Consultation in PCT India, who has a educational background of Bachelor's in Mechanical Engineering with MBA in Operations Research. He has over 27 years of experience in industry with 18 years around in PCT, establishing his expertise in Industry 4.0 and digital transformation consultant in automotive, agriculture, defense, industrial, heavy engineering, and educational organizations. Simultaneously, he is very good at CAD, CAM, CAE, PLM, IoT, and AI solution evangelist. Other than that, he is a very driving partner business person. He is good at partnering coaching and technical advisor, training and development for sales ecosystem and South Pac Rim. Also, he has an expertise of 1 year as a project manager in engineering services, leading a team of 15. 2+ years as R&D engineer in tractor industry designing, higher HP hydrostatics in steering agricultural tractors, and 6 years as aeronautical engineer or mechanical, as his background goes, in Air Force India. With this, I would like to invite with this, I would like to invite Sir, kindly proceed for your talk.
What's your name? Thank you, Aishwarya, for the introduction. As she said, PCT, it is not PCT, it is PTC. I think I should. Can somebody reduce this? Okay, thank you. So, Industry 4.0, I believe, is a very common terminology which everybody knows. So, I thought I will just spin out a different topic, which is called as digital twin. I don't know, you must be also familiar with this, but then I would like to weave in digital twin with digitalization and Industry 4.0. So thank you very much, IIT Jodhpur, all its faculty, students, for giving you this opportunity. The last speech which I gave was in IIT Madras. So nowadays I'm very privileged that IITs are calling me to give some sessions, and I'm also privileged to give to esteemed students, the chosen ones who are in IITs, to give my piece of experience. So the topic goes like this: accelerate digital transformation with digital twins. Just a quick introduction about my company. It is PTC now, but originally it was Parametric Technology Corporation, a company based in Boston, Massachusetts. We have been there in the industry for the past 35 years. We are present in the Americas, Europe, Asia Pac, etc. And we do cater for various industry verticals like industrial, electronics and high tech, automotive, aerospace and defense, retail and consumer, life sciences, etc. The series of solutions which we talk about are in the field of CAD, computer aided design, which of course if mechanical engineering students would be more aware of it. Then product lifecycle management, which is an enterprise solution which manages the entire information of a product from its concept to its death. And then Internet of Things. We are the only company which has got a purpose-built platform for Internet of Things. And augmented reality platform. We have the largest market share in the world. And spatial technologies. You will see some glances of all this. So we have all these different technologies. We say with CAD, the digital defines physical, because in CAD, we create the physical form, which further ends into a physical product. ALM is something to do with software and software data management.
So nowadays, all the vehicles are having more software codes than the electrical or electronics or mechanical parts. So we also have solutions which will manage the entire software and its data. Then PLM, as I mentioned, is an enterprise system which manages all the information. That's why we say digital manages physical. IoT is the technology which will connect the physical product or the physical equipment back to your digital system through sensor technology and internet technology. That's why we say digital connects physical. Then augmented reality is, unlike virtual reality, is a digital experience which is superimposed in the physical context. So that is being used by human beings, and that's why when they interact with the physical equipments, it will augment the experience. That's why we say digital augments physical with AR. And finally, we don't stop at just design and manufacturing. When it is being used in the field, when there is a requirement of service related requirements on the field, we also provide solutions for that. It's called as service lifecycle management. Simple things like creating the catalogs, product catalogs, maintenance catalogs, the warranty catalogs, the spare parts planning, those kind of things we do here. So we say, because we are able to give service, we are saying digital sustains physical. And to support all this, we also have a SaaS business model. Now, if you have heard of Industry 4.0, this term has been coined in Germany. When people are in less numbers, we wanted to automate the machines so that the productivity is not affected. That's how Industry 4.0 came up. But it has been very nicely documented by this article in Acatech, which has clearly described the different maturity index of Industry 4.0. So while you learn Industry 4.0, when you go and work in an industry, you can assess from this at what maturity level are you as part of the Industry 4.0. Now, the first requirement for Industry 4.0 is that you should be completely computerized. Do you think in India, every industry is computerized? No. We are in that state of affairs. Then, if we are computerized, then we should be also having high connectivity. Industries are not computerized, but we are highly connected because of mobile phone technology explosion. Even in huts, we have mobile phones, which are smartphones. But unfortunately, we are not computerized. But however, in Industry 4.0, we need it to be computerized and then also to be connected. That's where our World Wide Web will help. So this phase where you are computerized and connected, it's called as digitization. This is a must, prerequisite for Industry 4.0. Then your different maturity level starts. The first maturity level is when you are able to connect all your equipments in the factory and you get very good visibility of their performance in their operations. Then we say we can see what is happening. That is maturity level 3. Maturity level 4 is once we see what is happening, then we will be able to understand why it is happening. There will be analytics done on top of the data which we are seeing. The maturity level 5, with that data, we can also understand what will happen so that we can be prepared. That is maturity level 5. Most of the premium companies worldwide, they are in maturity level 5. And they are going to the maturity level 6, which is completely autonomous. Human beings do not have to interfere. Things will take its own course automatically. Machine is going down, the system will take the actions. Of course, human beings will be alerted. Wherever there is an intervention by human beings, it will be alerted and we have to interfere. What is the advantage of being autonomous? All the day-to-day mundane activities, repetitive tasks can be taken care by the autonomous systems, and human beings can spend their time in innovative ideas and products. So this is the different levels of maturity. So when you go out in the industry, you assess what is the maturity level index of that industry, and you try to strive or try to work to make them to the next maturity level. So for Industry 4.0, digital transformation is must. So dt is equal to dt square. What we mean by this is that digital transformation is only possible when you have digital twin and digital thread. What is digital thread and what is digital twin? I'll just quickly explain. Digital twin means you are trying to replicate whatever is happening to the physical product or physical equipment or the physical context exactly in your virtual environment. That is digital twin. The purpose of Industry 4.0 is also something like a digital twin. A machine is doing some operations, you're able to see on a computer screen exactly what is happening. That is a digital twin. So I'm going to elaborate on digital twin in my further presentations. But along with that, if I go back, digital thread is also there. It is a thread, but it is digital. From concept till the death of a product, there is lot of digital information which flows. But that information should not be separate. There should be connection between all that. You should be able to connect from concept to the death. You should also be able to trace it back anytime. That is why we say there should be a digital thread. So these two combinations will make it a digital transformed environment. That is what dt is equal to dt square. Now, you have a smart connected product here, right? Now this smart connect product, what it does, it sends sensor data through an internet infrastructure to a cloud or to a high performance computing center. It could be a local data center as well. There, the cloud or HPC, it does a lot of analytics. Once it does analytics, it can also control or optimize back the smart connected product. That's the purpose of doing analytics. Then, through computer vision, you can also see what is happening with the smart connected product, where in such mobile devices or such eyewears, maybe it could be a HoloLens. How do you do that? Through augmented reality experience. We'll see a glance of all that. And plus, in this augmented reality experience, you not only see the machine, but you also see the parameters of the machine. Like here, if you see, temperature is being seen, the weight of the machine, the vibration, etc. How is it happening? From the smart connected product, it goes to the cloud, and from the cloud, it comes back to your AR experience. So AR experience, IoT, cloud computing. These are the three major elements which work together to make smart connected products, smart connected processes, and smart connected human beings. A human being who is using augmented reality as an experience to interact with a process or a product will become smarter than the human being who is not using all this. That's why we say it makes human beings smart connected. Now, in the industry, when you go, this is where we are going. All our product development is becoming Internet of Things and augmented reality based. How? Even if you are in design and engineering field, we are using 3D printing instead of physical prototyping. There are technologies where you just print and start using it. You don't even have to make a physical prototype. Other day I was speaking to some customers like Tata Motors. You know what is their vision? There should not be any physical validation. Just virtual validation, virtual sign-off. Do you have the guts to do that? Is the question. Can the chief engineer say that if I virtually validate, I can sign off and do the manufacturing? The only obstacle is, does the engineer can take the ownership, and does he have the guts to do so? Otherwise, if you look at companies like Boeing and Airbus, do you think they have prototypes which is destroyed and not used? No. Their first aircraft itself is the first production aircraft. They cannot afford to have a prototype like a bicycle. or make 10 of them and break it by testing and then make the final, the 11th one. No. Their first product itself is the one which goes into the market. So they have to use a lot of digital technologies, virtual sign-off. So that's the vision. Similarly, we use for design reviews or collaborating between designers or manufacturers or anybody in the industry which is concerned with the product using augmented reality. You will design at the design stage itself, you will design the products with sensors. It's not that you just fit a sensor somewhere on the product and you get the data. No. In the virtual environment itself, we need to design the sensors and place it in the right place so that you get the right value. So those kind of changes you will see when you are in design and engineering. When you're in manufacturing, instead of paper-based instructions or videos or presentations on a TV, you will find the people on the shop floor using augmented reality-based work instructions. They will be interacting with the machines on an iPad or a mobile device or even a HoloLens. Similarly, a lot of automations, you keep collecting data from the machines, you come out with digital quality analytics, etc. That's in the manufacturing space. In the service and maintenance space, you are not talking about preventive maintenance. You're talking about predictive maintenance. In the maturity level index, if you remember, you can say what will happen and why it will happen. Predictive maintenance. There's one more thing, prescriptive maintenance. Just like a doctor says, do this, don't do this so that you remain healthy, the machine can tell, or the software can tell the machine, or tell the human beings interacting with the machine that you do this and don't do this, your machines will be uptime all the time. Similarly, remote diagnostics in service field itself, predictive service. Do you know in the health field, the engineer who goes to rectify maybe a scanner, he cannot afford to go there, find out the problem, come back and take the spare part and go and rectify. He should be already aware what is the problem. He should be already aware what are the spares or what are the other equipments required to rectify it. And in the first time itself, he should be able to rectify it. That's all possible because of predictive service. And finally, in the IT OT, you deal with cloud, you deal with a lot of security protocols. You also have edge analytics, analytics happening on the machines, at the product. And then, of course, a lot of app development. So this is the kind of environment you're going to face when you come to the industry. So what do we say is that an engineer cannot be complacent to be good in his own discipline. He has to be multidisciplinary. As part of multidisciplinary, mechatronics evolved, but mechatronics also is not enough. A mechanical engineer should understand how does a software interact with the mechanical systems. I don't know how many of you have heard of this Tesla story. Tesla, when it launched, it had a problem. You know, in US, the roads are very good, the ground clearance is very small. Tesla too had a very less ground clearance. Whenever it was taking a turn, you know, the banking which is there on the road, the bottom portion of the car was hitting the road and sparks were coming. What is the danger? Battery is positioned or placed at the bottom. It is a hazardous situation. But before even any of the Tesla user came to know, Tesla themselves came to know this because it's a smart connected car. So what did they do? Did they recall the cars? No. If they recall the car, it will come in big news and then its prices may go down, sales may go down. What it did, it just sent a message. It also can monitor who are the different drivers who are idle, who are all on the move. So it just sends a message saying that all those who are idle, please be idle for a few minutes. All others who can stop your car and be idle for a few minutes, please stop the car. Others can continue, we will deal with you later. And those who are idle, they sent a software update. The entire chassis of the Tesla was raised by 2 inches. Problem solved. Have you seen in airport, the buses? It comes down for you to board and it goes up. Of course, that's a mechanical system. The software interacted with the mechanical system and solved the problem. That is smart connected products. So this is the kind of environment you're going to see in the industry. Here I have taken an example of a Royal Enfield bike. Of course, it is applicable to any other product. From the planning stage to the aftermarket, it's all connected. It's a connected digital landscape. And information generated at any stage passes on to the next, to the next, the next. You would come across these kind of softwares when you go there, CAD, PLM, ERP, etc. And once we design all this, the physical product is created. We don't stop at that. It is connected through Internet of Things back to the IoT platform to make sense of how it is being used. Is there a scope for improvement? Not only the products, the machines which are responsible for manufacturing is also connected. You do a lot of analytics on the data which you get. You look at parameters like overall equipment effectiveness. You can manage the assets. You can control them. And all this again going back to these systems. It's like a closed loop traceability. And for the human beings to interact with the physical products, you use augmented reality. This is the kind of connected digital landscape you're going to face in the industry. And this is what we all strive for. And parallelly, from the CAD, whatever you virtually model goes directly into 3D printing. I was amazed when I went for one of the big events which my company conducts called LiveWorks in US. In that guy who is from our augmented or reality lab, what he was trying to do is he opens a laptop, he searches for a component, he takes his iPad, focuses on the component, it just comes up in his iPad, and he adjusts its size and all, and then he takes it to a nearby 3D printer. I don't know what he clicks, the 3D printer starts printing. It's like a magic. I said, you're doing some black magic, show it to me again. Again, he did that. He searched the product, scanned it, it came in his iPad, he's taking it, clicks, goes to the 3D printer, and it is getting printed. This is the kind of environment you're going to face. Connected digital landscape. So be it two-wheelers, four-wheelers, aircrafts, ships, drones or UAVs, missiles, tanks, radar systems. Everybody is in this path of getting into the maturity level 5 or 6 of Industry 4.0. Now let's go deep down into what is digital twin. It is nothing but it's a dynamic digital model of a product or a machine which will replicate the exact operation in the digital environment. That is what the simple explanation of digital twin. So what we say is that with digital twin, there is a possibility of physical and digital convergence, just like a yin-yang symbol here. And what helps the physical environment connect to the digital? Internet of Things. And what helps the digital environment connect to the physical? Augmented reality. So industry projects that by 2023, global 2000 companies will invest almost $16 billion for digital twin. And it's not far when we say no more physical testing, only virtual testing and sign off. So digital twin are of 4 types. One is digital twin of the product, where you capture the entire product definition into the digital world. Next is digital twin of the process. The manufacturing operations or the production activities are all captured digitally in real time. Then you have digital twin of people. If I am an expert, can my knowledge be captured and transferred to somebody as a digital experience? That is digital twin of people. And the last one is digital twin of place. Can I capture an entire auditorium like this with the people And can I get a digital model of that? And can I do a study on top of that? So let me go into details. What is digital twin of product? Basically, it is to have the exact replica of the product to analyze real world problems. Things like root cause analysis, optimization of the product, data-driven decisions, etc. So it clearly gives a visibility into the behavior of the products in the field. And you can also analyze that I designed it this way, but then the product is being operated or used this way. So is it okay, or do I have a scope of improvement? Again, if I have to give a humorous example, is that I don't know how many of you are from Tamil Nadu. If you look at the Tamil Nadu buses, none of the buses ply horizontal to the road. They all are tilted to the left. Why? Because youngsters like you, they don't like to travel inside the bus. They want to hang on to the door. So does Ashok Leyland or Tata Motors build it in such a way that the left side suspension is stronger than the right hand side? No. It's all the same. How do they survive? Because they give factor of safety of 4. But that increases the cost. So if we can do a study of the buses in real time, that this is the state of bus, can you think of a design? Let the bus be like that. Can I optimize the suspension? And look at the driver. He's not sitting straight. He's also lifted like this. So can we have a technology by having, even if the bus is made to tilt this way, it will auto adjust and come back. Right? Similarly, in north, on the train, chaya chaya. So that's how we do in India. So can we do some jugaad engineering through these technologies and bring back the product to behave the way it should be? Also, we can create outcome-based design. I say my product has to behave this way. This is the outcome which I should understand, so I will design that way. Not that I design and then have no control over the outcome, just like the bus. So that is digital twin of the product. Let's see an example. Here's a cycle. This cycle has got a lot of physical sensors. From the sensor, a digital twin of the cycle is created in the IoT platform. Our IoT platform as ThingWorks. It is capturing many parameters like the front wheel speed, the steering angle, the pedal speed, the rear wheel speed, etc. in real time. And it is capturing a host of data in real time here. It can also analyze the data pattern. You can do analytics. And from there, the data can go into a CAD model, which is doing the motion analysis of the cycle, as if it is being, driven on the actual road, potholed or roads of India. So it's real time. And from there, once we get the data, it can further go down for structural analysis, vibration analysis, etc. This is what we call it as virtual validation. But we are connected to the physical cycle once. One prototype, we generate all the data which is there on the field. Thereafter, whatever iterations we have to do, we will only do it in the digital because we have captured everything from the physical. This is one example of digital twin. And it is not limited to the physical product being in the lab. It can be that the product is being tested on the field. This is a live example of Santa Cruz bike, a mountain bike. So it's being tested on the field, and in real time on the left, you can see the digital motion analysis happening. Those arrows which you see, they are the reaction forces which is being shown, which will eventually lead into mechanical analysis. So that is one example of digital twin of product. Now, how does this digital twin, if I bring it into an augmented reality experience, help me for customer self-service? So this is a medical device, and I have an augmented reality experience, a digital experience, which is superimposed on the physical product and viewed through an iPad here in this case. It is giving me a step-by-step instruction, and you can see at the bottom the text also how to clean that aperture of this medical equipment. So I don't have to refer to any catalogs, 2D instructions. It's right there in front of me, superimposed exactly on the machine through a tab. This is one example of augmented reality coming into picture as a digital twin. Now, this is the example which I wanted to show live with this. This is a 3D printed model of a Howden compressor. Actually, the compressor is quite big. I can actually scan this with iPad and I can see the compressor operating with all its parameters. Technology problems. I cannot mirror my iPad if I'm connected to your Wi-Fi, but if time permits, I can show you. But let me show you the video. What you're going to see here is that I am having an AR experience. I am viewing it through an app, an AR app. I am also having a silhouette or outline of the physical product. I match it with the physical product. Automatically, the digital experience is superimposed on the physical product, and it shows me the entire product details, its operations, parameters. So what is happening is this digital experience is already created. The sensor data is going, like you saw that graph, smart product, cloud, AR experience. It goes into the digital AR experience and you're seeing it live. So this can be initiated by different ways. I can match a silhouette with a physical product, or I can simply scan an object. How many of you have TVS Apache bike? Anybody? RTR? Okay, if you don't have one, just go to the showroom, download this app called TVS Arrive, ARIVE. You will see all the different Apache series of bikes in that. Click RR310, which is a high-end bike. Go and scan an actual RR310 bike in the showroom. The digital bike will be superimposed and you can actually interact with the bike. Just for fun, do that. So something like that. I can scan an object and I can have a digital experience superimposed on top of that. So in this video, what you're seeing is you match the silhouette with the physical product. The digital model is superimposed. Now you're seeing the different parts of that Howden compressor. It was solid, it was opaque, but now I'm seeing the internal components. It is also giving me an explanation of all those different products. So I can interact, I can visualize the product well. It can be used for training, it can be used for sales. So one by one, you click. Next is, you're also looking at the safety regions, where all the electricity, the electrical hazards are there, the temperature hazards are there, the high pressure areas, etc. You can see that as well. It is required for an operator. Thereafter, you're also looking at the operation. So here, you are seeing that the function of the Howden compressor, the actual operation. That is also simulated in digitally and superimposed on the physical product in real time. And while it is operating, you will also see some parameters, and then you're also alerted saying that there is a broken diaphragm because of some pressure increase. If that is the case, then how do I service it? So now you're changing a role to a service engineer, and you're getting a step-by-step instruction as to how to replace that diaphragm, which has got punctured because of high pressure. So step-by-step instructions, right there on the model, with all the tools which is required to be used, the sequence in which the nuts and bolts have to be removed. So there is no confusion. It's right there in front of you. You see it, you do it. So that's a typical example of a digital twin, connected digital twin. You're also seeing those parameters. Wish I could show this. Otherwise, when I'm outside, I can show you. Going ahead for digital twin of process. Digital twin of process is combining and analyzing the different processes what the machines or equipments go through, and even other operational inputs, right? So there the KPIs are different. You want to see how the machines are operating, can we detect problems before they occur, can we prevent unplanned downtime, etc. Plus, it can also predict when it has to be maintained, so that your assets uptime is always up. It can also identify bottlenecks because of which the production is having a lag. Plus, it will also give you the as designed product information when it is being operated or used in the real world, basically the equipments. So let's see an example of this digital process. This video is little bigger, but I'll just explain upfront. This is a pump from a famous company called FlowServe. This pump's digital twin is what you're seeing here. So as it is operating on the field, maybe in a very hazardous condition, its voltage, its current, vibration, temperature, pressure, flow rate, everything is being monitored in real time. And the good thing about this IoT platform is that you don't have to create a learning model. It automatically learns what is normal and abnormal after reading a series of data over a period of time. And as soon as something goes abnormal, it will flag it. Like for example, somebody tried to reduce the pressure of the valve. By closing the valve, the discharge pressure increased. So it is shown as an anomaly, and then the efficiency of the pump also comes down. Plus, it says that if this situation continues, then it does predictive analytics and says bearing will go into a failure in 297 days. More seriously, the impeller will go in 6 days. So you have to take immediate action. Once the action is taken, it comes back to normal. So this is a digital twin of process. I'm running this thing is a 6 minutes video. Similarly, if it is a medical lab example, you can have a dashboard of the entire lab and its equipments here. What is their status? What is their maintenance due? If something is happening because it can fail, all those kind of different graphs you get in the medical lab. So if I advance this, let me just run this.
In industries where operational efficiency is necessary for success, having an enterprise where the workforce can't access information they need can set back day-to-day operational effectiveness. For a medical lab, having tools to assign and track lab and asset operations is crucial to ensure testing is completed on time and to quality standards. Lab managers often spend their days monitoring procedures, people, and equipment to ensure quality tests are completed within required timelines. Without a connected interface, managers can spend an excessive amount of time simply locating information. ThingWorx, however, provides the ability to create custom, role-based applications, enabling those labs to connect their disparate data, monitor their fleet of machines, and interact with their systems, all from a single user interface. With the manager's own role-based application through ThingWorx, they can view equipment, people, and processes information, regardless of where that data is housed, drastically cutting time spent searching and increasing time spent working. In their overview dashboard, the lab manager can ensure their lab is running efficiently with views of equipment performance KPIs, failure or maintenance alerts, and predicted issues. Managers also have access to equipment scheduling summary views and can reassign assets already scheduled for maintenance to avoid testing conflicts. This keeps the lab fully operational and on schedule without compromising needed maintenance. And by tracking warranty and certification expiration events, lab managers can plan around these upcoming equipment commitments. But if a lab is overutilized or doesn't have a specific machine for a test, they can view other labs right from their dashboard, providing geographical information, temperature and humidity levels, layout, and device locations. Managers can effectively send their test to the most optimal lab without compromising the integrity of the test. Not only can the manager view temperature and humidity readings from the outfitted lab sensors, but alarms can be set to automatically alert the manager when these readings fall out of range. More detailed information about a facility's equipment, like planned or predicted maintenance, warranty and certification information, and logs for ongoing and historical asset utilization, such as supply refills, are also available. Within the lab, knowing how equipment is functioning and coordinating scheduling is crucial for completing tests on time while ensuring optimal utilization. In the equipment view, lab users can view this information to inform decision-making. With location and equipment type filters, managers can easily find equipment they need and review planned service, upcoming certification or warranty expirations, and required personal protective equipment to use while operating. And with utilization and health data, lab managers can determine the best equipment to reserve for a test or schedule maintenance.
I hope you got the idea.
Operational.
Same thing goes for a factory. This is the digital twin of a factory. In operations, various parameters seen on the digital twin. You can also then go into a particular subsystem of the factory and go and interact with them, understand what is happening, those kind of things. So you can have production level details, production history, status, various monitored properties in various ways. So the scale with which you can connect to multiple machines or the entire factory or so many other factories gives you tremendous advantage, right? So that is digital twin of process. Now this one is not a process, but then I want to show you that it is showing a process wherein you can make your catalogs, the 2D catalogs come into life with digital experience. So what you're going to see is that it's an HBR, Harvard Business Review app, wherein you scan an image of a paper plane factory and suddenly everything comes up live as an AR experience. So a 2D documentation brought into life as an AR experience. Coming to digital twin of people. If there is an expert who has got a lot of intrinsic knowledge, if he can capture all that, and if that can be published as an AR experience where others can consume that using a mobile device or a HoloLens, then that is called as digital twin of people. So we have a lot of use cases in COVID period by which the expertise of the people was transferred to others and others could pitch in right in time. If you go and search for UK ventilator challenge, you will see that story, wherein there were only 2 ventilator companies, a lot of demand for ventilators, but they could not meet the demand. So what did they do? The government appealed to other industries from automotive and aerospace who were working at 50% less capacity to pitch in. They said, sure, we have the facility, we have the people, but how do we do it? Then they used our AR solution called Vuforia Expert Capture. That means the expertise from the ventilator company was captured, whatever he's doing for assembling the components, testing them and packaging them. And that was created as an AR experience given to these automotive and aerospace companies. They did exactly verbatim and they could meet the demand. So in this case, you will see one example of Vuforia Expert Capture, wherein an expert is doing certain activities. Whatever he speaks, whatever he does, everything is captured. Later, it is garnished with additional details in the editor, published as an AR experience, which is then consumed by any of the eyewear or desktop machines exactly.
Vuforia Expert Capture is a new workforce productivity solution from PTC, which captures the tacit knowledge of frontline experts in situ, where and when they do their work, and then makes it available to any worker to effectively and efficiently perform that same procedure. Using the Vuforia Capture app on a head-worn device, the subject matter expert can record their work procedures step by step, in real time. No tedious written documentation work is required. By using intuitive voice or gesture commands,
next step. Ensure voltage selector is on 120 volts.
The user can control the recording of the video, take photos, and mark important moments to edit later, all hands-free while they work. The captured knowledge can then be revised and configured in Vuforia's web procedure editor before publishing. Once published, captured instructions are consumed via Vuforia View on a HoloLens, RealWear, or mobile device. This gives a clear and immersive first-person perspective of what to do and how to do it best. PTC's Vuforia Expert Capture solution saves your company time and money associated with the creation of traditional training and documentation methods, which ultimately results in significant downstream benefits in areas like quality, safety, and overall workforce productivity.
So that was digital twin of people, and the last one is digital twin of place. So if you see, it's basically a technology to compute the spatial things. You may have to have good cameras which can take 360-degree capturing. All that what it captures is converted into a scan data with all the details. Then maybe, I don't know how many of you mechanical engineers may know, like time study, method study, etc. You can do on top of that, optimization of the space, etc. So you will understand that with this example. So basically, optimizing the space, digital twin of place. And this technology is coming up to a great extent. In fact, this is what is making the planners of a smart city to plan it upfront. They can scan the entire city and they can have a very good digital view of the new city which they are planning to. Maybe in a scaled model, of course. So let's see here. Whatever is happening at this lab, there are certain equipments, there are certain robots with which she is interacting. All that is being captured using a camera. And as you capture every single movement of the human beings, the equipments, etc., in the space is being captured, the volume which is being used by the human beings and the equipments is being captured. And while it is being captured, the system can run it, replay it, and try to optimize using method study and time study technologies to optimize the space. So they may come out with outcomes saying that if this operation was done this way, if this table was kept here, or this, or the sequence of the processes, if it was this could have been better. So even it's being used in data centers, racks and racks of computers. They want to optimize the space to put maximum number of racks which can hold the computers. Spatial computing is the answer. So that is digital twin of space. There are a lot of customer case studies like this who are adopting digital twin technologies and have got a lot of benefits out of it. So the key benefits of digital twin, you'll get deeper insights into the product behavior of the field. You can accelerate new product introductions into the market. Your time to market gets less. You can enable new business models. If you see LensCart, which is scanning your head and, that's a new business model. Extends manufacturing relationship with customers, improve operational efficiency, service efficiency, and faster time to resolutions. In the healthcare field, it is being used very much. So the three pillars of success is that there should be the right technology and a conscious approach, but more importantly, an executive leader responsibility. Like I mentioned, if I have to have a virtual sign-off, who will take the ownership? Can the chief engineer take the ownership? Can the CEO take the ownership? So there needs to be a very good executive leader responsibility, and there should be a mix of top-down and bottom-up processes or initiatives, right? And it is seen that if there is digital technology, then you will have a better digital thread. You can have closed loop of digital processes and informations. Better leaders, outcomes missed is less. And if there is a cultural change which is required, anything which is new, there is a culture change required. That also really helps, right? So in the interest of time, I just finished. So the same thing which I have shown there, I have one Howden compressor, I have a KTM bike. Thing is that these two customers, they have implemented, designed everything in our technology. So I am partial in bringing these. But there are a lot of customers who are doing this, okay? So with that, I end my, if you call it as a keynote. I didn't want it to be a just presentation, I wanted it to be live. Thank you very much. disconnect?
Sure, sir. Just a minute. So, sure, sir. Yes, sir. Yes, sir. Yes, sir, I will do it. I will do it, sir. Thank you, sir. Thank you for your insightful technical information, and I pardon for my mistake. One, please. And
For my company well.
sorry, sir. And I'm sure today each of us would have definitely overcome the desire. Can actually digitalization be amalgamated with manpower and industrial production to the fullest limit? I think the answer is yes, probably yes, and it's digital twinning. And with this, I would request Professor B. Ravindra to kindly proceed to the stage for felicitating Sir with a memento. Please.
I think there's one more. Yes, yes, yes. I can take it.
Sure.
Those needs and give it to me. That's all I.
Memento.
Yes, sir. I will.
Some other PPT.
इसको पहले कोई वो गेट के साथ बनाना
वहाँ पे बॉटल ये भी ले लीजिए।
With this, I would like to invite our next speaker, Mr. Mukul Gupta, who is the co-founder of Dynapt Inc., a technology leader in digital transformation, systems integration, data and analytics, as well as application development. Also, Mr. Mukul has also holds a diploma from Harvard Business School, USA in strategy and leadership. As a result of which, we can say Mr. Mukul's expertise comes from over 2 decades of service in leadership position at Microsoft, Citizens Bank, and CSC. His roles in leading engineering, product development, and project management have given him the depth of experience that has made him a strong architect and CTO. Before devoting his full-time work to Dynapt Inc., Mr. Mukul was a principal architect for successful and large-scale artificial intelligence and deep learning-based cloud-scale state-of-the-art platform as a service, offering an end-to-end service for users to remotely store, manage, record, play, and monitor surveillance footage along with the real-time IoT sensor data, all of which resides entirely in cloud. With this introduction, I would like to ask sir to kindly come over to present.
Thank you very much. Am I audible? Thank you. Good evening, Jodhpur. Great to see you all. Digital twin, which we were discussing in the last session, is really relevant, and I'll tell you how it's going to work. How many have seen this movie called Avatar? There are a lot of hands raising, right? So that's very good example of digital twin, right? I mean, they kind of like reincarnated the humans and then moved into machines and then using them, right? So we'll talk about that further in the fag end of my session, because we are also working on digital twin, which is very relevant now, and how we are leveraging that, right? So with that, I have few slides. Want to talk about myself, the company which I have. Great. How to move? Which one? Okay, good. Thank you. Okay, so Dynapt got founded around like 8 years back. Of course, we started from Delhi and then we moved to Austin now. We are roughly 600 people across the globe, and around 100 we are in India. We have recently recognized as a Microsoft solution partner because we are very closely working with Microsoft. So they have been recognized. There are very few partners who work in the area where we are working right now. And we have different locations headquartered in Austin. Delhi is our offshore center. We have our offices in Egypt, Canberra, Canada, and of course in Dubai as well. They are more like the sales work. Some of the customers whom with we have worked in the past, you look some nice logos here. I would like to call out Tesla. That's one customer we worked really closely when they were launching their Model 3 around like 3 years back. And then of course Microsoft is one of the very close clients we work with. Gap, NASA, there are a few other companies who we are like providing services, especially on the data analytics side. Okay, so this forum is mainly for Industry 4.0, and I want to talk about, how companies like Dynapt, we are mainly in that small segment, the boutique companies we want to call, and how we are helping bigger manufacturers to go adopt Industry 4.0 and then deliver the results. So my talk is mainly focused on the case studies, very niche case studies we have delivered for the customers and how they got benefited out of them. Right. So the case studies are like focused on healthcare and especially on HVAC, which I want to focus right now. The first one is J&J. I mean, all of you heard about Johnson & Johnson. Johnson & Johnson being a premier healthcare company, they are also manufacturer of healthcare apparatus instruments, right? So they have a factory and they were running through a challenge. They were not able to do they were not able to get the efficiency, operational efficiency for their instruments. So of course, they are more into reactive maintenance than being a preventive or a proactive maintenance, right? So they were like putting a lot of cost for that, right? So what we have done, so of course they already have sensors installed in their factories, and they were collecting data. So they were having Of course, they were using SAP for collect all that data, the terabytes of data they have collected, but they don't know how to use it, and then increase the operational efficiency of their factories. So what we did this work for one factory. We picked up one factory, we picked up the data, the historical data for many, many years in the past, and we kind of like created a safety score using a predictive model. And then based on that, we kind of like ran the model on the old data and then predicting how they can go. I mean, how and when the next anomaly is going to happen in their machines, they're going to break down, and how they can go work and then take a preemptive measure to make sure that the problem is not occurring, right? So if you look at the savings, why this is relevant, the impact which we are creating using these technologies like IoT and AI. For this one factory, we got around like $200,000 savings per week for Johnson & Johnson. If you look, they have like so many factories around the globe. And then if they go implement that all across the places, what kind of benefits they're going to get, what kind of dollar revenue they're going to save over the period of time. The next one is Churchin and White. It's a $1 billion company. They are more into manufacturing I would say the cases for detergent and all that stuff, right? So more like plastic manufacturing kind of work they do. Their challenge was more on like collecting data from all over the places and then use it for the leadership boards, I mean, to take the decision. So they want to collect the data, want to show to the leadership team so they can go and take decision based on that. The turnaround time before implementing the solution was more than 2 weeks. Right? It used to take like weeks to get the data and then show to the leadership, and they can take action. Okay, this factory needs this kind of improvement, this factory needs something else, right? Or if some preventive measure needs to get taken. So what we did, we kind of like created a data lake house for them, collected all the data from different places, put that into one place, and then of course we ran some Jing Bang machine learning, right? And then created dashboards, nice looking dashboards, leadership team, to show them the KPIs, how they look like, so they can take the decisions, what need to get done. So if you look at the impact, sorry, it was like 10 weeks earlier, we reduced it to 2 weeks. So there was a huge gap. I mean, 3 months to 2 weeks, they are able to take better decision and make, I mean, of course, they can make the changes if there is required. The third one is very, very relevant, Stelco. Stelco is #1 steel company in Canada. It has been acquired by American Steels later. So they have like a lot of HVAC machines, which they use for compressing the steel and then fabricating and shipping, changing the shapes and all that stuff, right? So if you look at the challenge, this again related to the equipment efficiency. There were challenges in measuring the equipment efficiency, though they have the sensors. They were collecting temperature, they were collecting pressure, they were collecting all kind of data, but they are not able to make decisions based upon that. So again, the same thing what we did here. So our objective was to reduce the turnaround time and then operational efficiency here. So what we did, we use Azure, the Microsoft Azure. There's a cloud platform. And then again, we collected all that data there. We created a model. Again, the same approach, creating a safety score, and then trying to measure the performance based on that safety score, and then taking proactive actions. If you look at here, the impact was again more than 50% improvement on overall equipment efficiency, which we were able to get for the customer. So you can see these 3 case studies from the field of manufacturing, how they kind of like making impact, the smaller or the bigger impact to the company, so they can go have a better efficiency, driving things forward and have better profitability. By the end of the day, what counts is the profitability, right? So there's a one slide which I kind of like put here, how we can go leverage machine learning and then take advantage of that. So we have like 3 different dimensions for that. And then of course that has been divided between different verticals or horizons, I would say. So there are certain challenges. We had certain approach, how we can go target and then make it work. And the last one is what kind of outcomes we can expect from that when we go take a certain approach to drive things forward. With that, I'm almost done. One thing which I want to bring up back, we started working with this company called Cubisme. It's a recently funded company into healthcare segment. And they are working on, so you must have seen like all healthcare I would say, diagnostic reports, they are generally 2D, X-rays, MRIs, everything is 2D, right? The radiologists really have tough time to go diagnose based on those reports what the real problem is, right? So QSME, what they are doing, they are using, of course, these two-dimensional reports, and then using machine learning data and convert everything into 3D modeling, which is very close to the digital twin what we were talking about, right? So digital twin is not a far side thing, it's the reality, okay? Other countries have already started adopting it. In India, of course, the more work we do towards that, the more adoption we will have on that. With that thought, I'm just closing here. Thank you very much. Okay.
Hello. Thank you, sir, for such an engaging presentation with very practical examples and solutions. And with this, actually, we'd like to move on to our next speaker, Mr. Navi Kansara. I'd like to invite sir to the I'd like to invite to the stage. And giving a brief introduction about him, he is a bachelor's in engineering or mechatronics and bachelor's of computer science from University of Melbourne, Australia. By profession, he acts as a director at Kansara Modular Limited and CEO at Panipuri Software Limited. Kansara Model Limited is an Indo-German joint venture company committed to manufacturing high-precision world-class rollers for bearing using precision grinding. And Panipuri Software Limited is a product development software company that makes ERP solutions for the MSMEs with specialization for handicrafts industry. And simultaneously, he has a personal interest of cycling, deep health and fitness, and towards neuroscience. So I hope with this insight, we can start our presentation.
Good evening, everyone. I think most of them are sleeping. Good evening, everyone. Yeah, that's better. So first of all, I would like to thank IIT Jodhpur, its director, Professor Desai, and the team that's conducting Industry Day today. Since it's already quite late and it's a Saturday evening, so I would like to thank all the students here. आप आज अभी तक बैठे हैं. A big thank you and a big round of applause for being here. I'm going to be very brief. I'm going to be very quick and hit on the points why we are here. So this is going to be the layout of my presence here. First, I'm going to talk about who are we. हम कौन है? Then I'm going to talk about what is our association with IIT Jodhpur. And finally, the mixture, us, IIT Jodhpur, and Industry 4.0. So far, you have heard two gentlemen who have been showing what they can do as a solution provider for Industry 4.0. I am on the other side. I am the user of Industry 4.0, and I'm going to show what us, our company, and IIT Jodhpur can do in-house in Jodhpur to reach that goal. So let's move on. Our company is called Kansara Modeler Limited. It's an Indo-German joint venture specializing in ultra-precision grinding. So the next question is, what does Kansara Modeler do? Well, the short answer is, we move you, all of you. Anybody who has used a mode of transportation has been touched by our product. And you would ask a logical question, how do we touch you? So as we know, a picture is worth 1,000 words and a video is maybe 1,000,000 words. So let me show you. You need a support here. It's from that. Just unmute it. No replacement for technicians, huh? Yeah. Go back. Sound. Hmm?
Okay, no problem. Okay, no problem. So this is a small video of what we do. Unfortunately, the sound is not getting transmitted, so you just have to imagine your favorite song. There is no actual spoken information in, just the background music, so I think it should suffice. So this was a small, quick presentation of what we do. We are based in Jodhpur. Everybody is invited to visit if you feel like. So we talked a little bit about our product, but most important is its quality. So the precision that we are achieving is 1/50th part of a human hair. All our production is produced in plus minus 1 micron range. Very, very precise. So to make such a precision component, you cannot do it by hand or by human intervention. You need a very good control system. And we use a lot of machine vision in our factory to control this. In fact, we have camera systems that are of the order of 10 nanometer accuracy. So as the product comes out of the line, every product is measured. That information is transmitted over a Profibus, something related to Industry 4.0 to a machine. That machine then uses that information to make decisions on what to do further. And when you are making it at such a high precision, you need to make sure that what you are committing, you are already actually achieving. So we have a very precise measurement equipments that can do measurements of wavelengths of sub-angstrom accuracy. So that is about Kansara modeler, what we do. And now comes into IIT picture, IIT Jodhpur. So what we do with IIT Jodhpur. So in that quick video, you saw a slide that says big responsibility. What does that mean? You have seen that our product is used in an automobile, in a railway, in a windmill. Our product is very small, but a defect on our product can affect a very important equipment in its service life. Imagine if my roller is not okay and gets fitted into a bearing, that gets fitted into a car. That small roller, maybe 20, 25 rupees roller, can impact the life of the car, can impact the person sitting inside the car. So that responsibility on my product is very high. A 10, 20 rupee roller can lead to a recall of a car that may be 20 lakh rupees. So you can imagine the scale of responsibility that lies on our product. We have heard of the term zero defect, very popularized these days, but we have been working on this for last 20, 25 years. Out of 20 lakhs of rollers, I don't want to supply a single defective roller to my customer, because that single defective roller can go to your car and can affect the performance of your car. And nobody wants a defective product. Major hurdle in achieving that zero defect is surface defects that we generate in-house or that are due to the raw material. And we need an automated smart system to detect that defect and take that roller out of the channel so that it doesn't get shipped to the customer. And this is where IIT came into picture.
We have been working with Professor Desai for last couple of years in developing a smart system, a machine vision based system to detect that small defect and take that roller out of the system. It's a joint project. We have done some hardware work on our end, and now the software is being done by IIT Jodhpur. The idea is to use a lot of AI and a lot of big data to detect that defect and maybe prevent that defect. So again, a video is worth a million words. So let me show you the current status of the project. Sorry, there is no sound, so you have to just imagine the. So this prototype is currently in the IIT lab. Okay. Again, some issues, they cannot play the video. So there is already a prototype in the lab where we have already started testing our rollers. The hardware is fully complete. The software is being tested, and we are working on achieving the required accuracy. The next term comes is Industry 4.0. So where does this project go? First question is, we are already detecting the defect. Why do you need an Industry 4.0 platform? It's something like analysis after postmortem and preventing death. It's just like a smartwatch for a machine. Earlier, whenever you had a problem, dard hua, kuch hua, you went to the doctor, and the doctor did the diagnosis, wrote the test, and you found out that there is an issue or not. Industry 4.0 is, in my view, is like a smartwatch for the machine. It will monitor the data and predictively tell if the problem is going to come, predictively prevent a problem. And that is our dream with this project. We are at the moment working to detect the defect after it has been generated, but that's already too late. After the defect has been generated and I detect, I am losing that roller. It's a loss of money. It's a loss of time spent on producing that roller. What if I could detect the generation? What I could use the system to pre-warn me that, okay, if you go to this path, you will generate that defect. So if I prevent the defect generation, I save money, I improve my quality. And that is the aim of this project. And lastly, in the Western world, there are a lot of consortiums, there are a lot of standardization of smart manufacturing. But unfortunately, India lacks that. And I would like to suggest IIT Jodhpur takes up a initiative and work with the Union of India to make an India stack. I named it Bhishma. Everybody knows BHIM, I think, yeah? That's the India stack for the financial sector. And I say, let's, एक कैरेक्टर आ गया महाभारत का, एक और से भी बड़ा ले आओ, भीष्म. Bharat Initiative for Smart Manufacturing. And IIT Jodhpur, I would request, take up this initiative with the Government of India, and let's start a Bhishma initiative so that in coming 10 years, we can be the great granddaddy of manufacturing in the world. Thank you. That's all I have to say.
Thank you, sir. Thank you so much for showcasing the advancement between our industry and an educational institution. With this, I would like to just briefly say that Industry 4.0 does bring a sense of gloom and doom, but don't be focused on the threats, focus on the opportunities. With this, just expose some new sources of value and growth, opportunities, businesses, and markets. And today, to ensure that we shall take the fullest opportunity to ponder and query the experts. For this, I do request Professor Ravi K.R., Mr. Suresh Parinjari, Mr. Mukul Gupta, Mr. Naveen Kansara to kindly come to the stage for panel discussion.
Good evening to all. Considering the time constraint, so we'll actually restrict the panel discussion for 10 to 15 minutes. So I start with the a question from audience to the industry, the panel members, so that then we'll ask some specific question to the panel members. So I request from audience, let's start the panel discussion. Okay, so let me start. Okay. So we have seen several case studies. So based on your experience, if you can suggest one case study where like use of this industry 4.0 has given a significant benefit in terms of what do you call a defect reduction or performance increase or maybe a cost reduction. You can start means yeah, Suresh.
Hello. Yeah. So since I'm a user of all these technologies, I do see a lot of reduction in processes using this technology. Just to give you an example, at the moment we have 3 production lines. The first production line was installed in 2000, and at that time there was no machine vision, there was no sensors were not so accurate. Still, we were able to produce in plus minus 1 micron range. When we installed the second production line, we had something similar to what we are talking right now. We have a machine vision camera that measures every roller and sends that information to the machine to control. We have seen a drastic improvement in the level of quality and in the level of rejection due to this technology. Because the decisions are taken so quickly. Earlier, the operator was to take the decision based on the sensor's input. Now that operator's role has been reduced, and this technology has helped us achieve even better product quality control. So there is definitely a big advantage on using these technologies.
So again, it depends. I mean, what is the parameter you are judging on? So if you talk about the numbers, the dollar numbers, Johnson & Johnson, the case study which I was talking about, that was the biggest, I mean, the significant savings using IoT plus the predictive analytics was significant. But again, I mean, Stelco being Stelco and HVAC ACE, the operational efficiency is also very, very important, right? So that was also significant in his own terms, in terms of like measuring whether it's effective or not.
Okay, thank you. I'll put up question. So being a user to Kansara, so in industry we have people with different level and different mindset. some of them are willing to adapt technology, some of them are reluctant to use technology. How do you convince, like being a industry 4.0, which is, it is not very familiar for them, how do you convince them that to use this technology?
Yep. As we saw in the first presentation, it has to come from the top-down leadership. And for the top-down leadership to make an investment in these kind of technologies, they must have some technical background and must have a vision to do better than what their competitor is doing, what the world is doing. That is the essential component. The final implementation is not the major hurdle, or the cost is not the major hurdle. It is to visualize what advantages it can give you in the future and what competitive advantage it can give you. That is the necessary component. And in that perspective, I think institutes like IIT Jodhpur can do a lot. They have to educate. I see a lot of institute and industry interaction, and you have to educate the industry that this is what is coming and this is what it can be useful for. Another point is we have been adopting a lot of Western tech. We need to now gear up India in a way that we can make our own tech. That not only reduces the cost, that also helps the industry to gain more confidence, because otherwise there are a lot of closed platforms like Profibus and Profinet, and we are not able to fully utilize them because of lot of export restrictions. So India needs to gear up, and the academia has to take the step to make this research and make this tech available for India, made in India.
I will add on to this. There was a time when the industries had a lot of data, but they didn't know what to do about it. We have crossed the stage. Now we are at a stage where we want to brainstorm as to what all things we can do with this data. So the main challenge is, how do we prioritize the different things with this data? What is the company's first priority, second priority, third priority? Is it that I want to increase my top line, or is it that I want to increase my bottom line? Or is it that I have to be globally competitive? Is it that I have to be as competitive for me to be able to sell in Europe and US? What is your priority? Business level. Secondly, if you all know, all the CXOs are connected. They have their own WhatsApp group. If one CXO is successful, the word spreads around. And in fact, I have seen that you propose a solution as a solution vendor, you propose a solution to a CXO, he will listen to everything, he said, I'll come back. And then you go to another CXO, already this CXO would have already have consulted the other CXO that you have already implemented this solution, what is the success rate? What should I do about it? So the problem is that everybody is trying to see who will do it first. And then if he is successful, then I will be successful, which is a wrong thing actually. This implementation of IoT is different for different customers. Even if it is a two-wheeler industry, if it is a TVS motor and a Royal Enfield, if you compare with them, or a KTM bike, the requirements are totally different. The internal business objectives are different. Of course, the products may be similar, the processes may be similar, but the business objectives may be different. So what we tell them is that you can take a cue from the success of other customers. That's why we always present with use cases or customer references. But please do prioritize with your own business objectives. So it will be helpful if there is a CEO who has got this the guts and the will to go with this forecasted or the vision of that benefit with all the data which we have. That is what is going to make the Industry 4.0 success. And as he said, make in India. In fact, we are a US company. Whenever we try to go and sell in aerospace and defense in India, they will ask you, what percentage of your software is made in India? Fortunately, we can answer that. 80% of the software is researched and developed in Pune. Right? The biggest R&D after US. So Make in India definitely works. And even if you see all the laurels which my company gets, there is an Indian lead who is responsible for that. So it will really make a difference. So with that, we are able to reach out to A&D, government and public sectors. So I feel it's just a matter of corporate visibility and the will of the CXOs.
I want to add two thoughts here. One is from Dr. Clayton, one of the most famous strategy professor from Harvard Business University. He wrote in this book called Innovator's Dilemma, if you read about that. It's always a challenge for a leader to pick up what is right for the company, right? And if they don't pick up on the time, there will be no time they'll be gone. I mean, for example, Blockbuster is a company in US who used to be pioneer for giving the video cassettes, right? Netflix wiped them up in like 4 years because they couldn't change the way how they were doing the business, right? Same way you have heard about Mojaware, right? The company which was the number one making CDs in India, right? They got banished because they couldn't really adopt to the new trends to adopt them. The same thing, and again, for leaders it's difficult, right? I mean, they have like certain capital. If they go invest on something which is challenging and it doesn't work out, they are risking everything. They cannot do that. Especially, okay, founders still have those guts, but again, the CEOs of the companies which has already been established for a long time, it's always difficult for them to do that, right? So Jim Collins is another very famous author. He writes in this book called Beyond Entrepreneurship 2.0. What you should be doing as a leader, you should not be doing a big bang investment in something. What you should be doing, you pick up like 5 initiatives which you think they're going to work and do a small investment in them. And then see incremental growth. And then if you see it's working out, then you go ahead and then move forward and then adopt it, right? So that's the way how we can do that. Industry 4.0, IoT and AI adoption is already, so you know the S curve, right? So S curve is like this. Early adopters, when things are maturing, adopting them, and then when it's like post, right? So we are on the mature side now. If you don't do it now, it will be too late. So go ahead, I mean, buckle up and then go ahead and then do it.
Thank you. So my next question, I think to Suresh. Digital twin we can do for product design, we can do a process design and factory design. Where it is, we really can make a big mark. And I have just added one more question together. In factory design, you have equipment. Say if you are considering a factory which has a history of like 30, 40 years, you have equipment at a different time. Let's say that some equipments are bought are installed in 30 years. Some equipments are newer equipment. How do you actually put everything together and make you make a digital twin? So it's a big question, but it has two parts.
Yeah. So you said what are the benefits of digital twin?
Exactly.
What was that?
In which let's say process, product, or factory design, where digital twin make a big mark?
Yeah. See, in different places it's different. Like for example, if it is in factory, they look at parameters like overall equipment effectiveness. The KPIs goes like that. How much of downtime can I reduce? How much of uptime? And material wastage, operational efficiency, etc. If it is product, customer satisfaction is the first parameter. If it is a product, customer usability, those kind of parameters. So everywhere it is important, provided we give impetus to these particular parameters. Now coming to old machines, we saw just a live example in IIT Jodhpur itself. Kudos to the department headed by Kaushal Desai and his students, PhD students. Old machines retrofitted and very nice parameters is being captured. Me and Naveen, we just had a live demonstration there. So any machine, whatever it is, 30 years, 40 years old, as long as it is working, if it is a rotating component, we can sense its RPM. If it is a moving component, we can, if it is a cutting component, we can sense its speed and depth of cut, etc. So the market of sensors has so matured, even in agriculture. we have our IoT applications implemented there. Humidity, fertilizer level, tractor performance, everything can be measured. So sensors are there, so many in the market. We have to choose the right sensor, retrofit it, like here he was using the word clip-on. Retrofit it onto the old machines, connect it through the necessary equipments, and then you are up and running. So it's not a problem. Latest machines, yes, of course, they're already smart. It is just a matter of understanding what is the protocol by which they are giving the output, and then you just get it into your IoT platform. So it's not a problem at all.
Okay, thank you. So next question. See, when we talk about Industry 4.0, Industry 4.0 can be benefited by the startup ecosystem. So a lot of things can be done through startup. So at the same time, Industry 4.0 also can give opportunity to startup. How do you look at it?
Yeah, startup, that's a very good question. See, there's a lot of medical nowadays. Even when I went to RMK College of Engineering, IIT Madras, and here in IIT Jodhpur also, a lot of impetus is given to medical and medical field. You know why? When it comes to pharmacy, we are number one in export. But when it comes to medical equipment, we are almost down the list. I was told that even at that small strip which we use to, measure the sugar level, even that is being imported from China. So the government of India and the industries have realized that there are a lot of entrepreneurs who can make everything in India. But the problem is that they come up with an idea, working idea, but then they are not able to sell it. Not selling the idea, the product which they make, they're not successful in selling to the market. So there are organizations like AMTZ, Andhra Pradesh Medical Technology Zone. I've been fortunate to go and visit there. There are some 76 plus entrepreneurs associated with that. They make all the facilities which is required for an entrepreneur to be successful in the to make medical device is available there. But the biggest thing which I liked is the entrepreneur uses that facility, makes the medical device, the idea is working, they make the prototype. Thereafter, whether it is a tender-based selling or whether it is direct selling, AMTZ takes care of that. So if the entrepreneur is bringing up an idea which is workable, it will be surely sold. Even Niti Aayog is also involved in that. So that is where entrepreneurs can really leverage Industry 4.0. But what we have to do is we have to facilitate such common facility centers like the AMTZ. And I was told by Kaushal there is an initiative here also, right? So that's how. And then people like Naveen, who is already showing success, he's also an entrepreneur. Years maybe. Now you are a established company. So they can be a role model to other entrepreneurs. So students, in fact, I think present day generation, they say, I don't want to work under anybody. I want to run my own company. Even my son is saying so. So I said, yes, please run a company because a lot of impetus which is given to the entrepreneurship. And the other day I was in an Airbus event. Some 15 entrepreneurs are associated with Airbus today, completely on different technologies. And I was told that some 200 companies are there as entrepreneurs in the drone area. 200 Indian companies. So it's a very good environment. Very good environment for entrepreneurs.
Okay, so I have one last question. So how this, so you come from two different extreme, one is solution provider and one is user. So what way IIT Jodhpur can help, or what way IIT Jodhpur can benefit out of your expertise, or like what way IIT Jodhpur expertise can be utilized in your industry, or in, and say the overall picture of Industry 4.0?
I have some input. I'll give it to other speakers also. In fact, he mentioned that in his slide. Us, Industry 4.0 and IIT Jodhpur. So it's a chicken and egg story. We say like that. I am a solution provider. I go to the industry and say, please use this. You will be benefited. He said, fantastic. I'm convinced. Now I want the people who can help me. Where do I get the people from? From IIT Jodhpur. Right? So there needs to be a very strong industry academia collaboration. It is, I would say, industry's selfish requirement that we need to bring up academia wherein they are already aware of this technology, they are already trained in that. As I have shown in my slide, the way the industry is going off, you cannot be, complacent with your own branches. You have to be multidisciplinary. So unless we set up center of excellences, and I think we were talking to the deputy director, he was saying it's not just industry and academia collaboration, industry, academia, and R&D. These three bodies, if they come together, we can do wonders. So the interest of industry is we will nurture the future engineers in IIT Jodhpur who will eventually come and implement and come out with better ideas in the industry, so that I, as a solution provider, will have these IIT Jodhpur students going to the industry and demanding my solutions. So that's my selfish attitude. That's how I look at it.
No, I see is a twofold approach. One is the old one, the classic approach, like we come, pick up the brightest mind and then employ them and then work with them, right? But that's the old approach, right? The new approach is what Suresh was saying here. Let's work together right now. Let's set up an incubation center, right? We'll bring the problem statement. You go provide the solution. Let's take it them together to the industry, right? So that's the approach which I see is going to be very, very effective. And honestly, I tell you, the ecosystem for startups has completely changed in India now. I mean, how it used to be 10 years back, what is today. I mean, there's so many facilities, there are so many grants, there are so many people to guide you, mentor you to drive things forward. I think this is the time when job should not be your priority. The excellence of the work should be your priority going forward.
Yeah. So actually, we are a live example of the problem statement that you did. I think the academia where it lacks is it does not know. It may have the theoretical knowledge and what's coming, but does not know where to implement it. And that's where the industry comes in. The industry has its own constraint. I know that this solution can be implemented, but I do not have the resources and the time to devote other than manufacturing. So that's a very win-win situation for both of us. I know that the solution can be implemented, the hardware is available, the software technology is available, but I'm so preoccupied with my day-to-day activities, my manufacturing, my processes, that that future project is somewhere down the priority list. And that gap can be filled by the academia beautifully. When we started this joint project, it's been on my mind for almost 10 years. I think even 5-6 years ago when I came and I met people at IIT and I discussed this, and then that's what I said, that okay, I know this is implementable, all the solutions are available, but I cannot do it alone because I don't have the time and the priority to do it. But it's a good project for IIT to get exposed to. And when you do a real life problem solution, the exposure is totally different than you write a paper. It's two worlds apart, I think.
Thank you. So now I request one or two questions from audience. Mike.
So my question is like, in Industry 4.0, like suppose you want to incorporate very challenging manufacturing or various kinds of adaptability in the manufacturing. Say, for example, you want to have a micro hole and a nano hole, or a kind of a something which is an conducting and a ceramic. So such a thing, how do you incorporate, and how you want to show that it is compatible with, like, in the various sectors which can be applied? Yeah.
Yeah, I'll just quickly. So, Suresh ji was saying that the industry is usually very well connected. A person who is working in a particular industry, he knows what's going around in that industry, what's coming up, what's getting out. So if it's an implementable solution, the word travels very fast. As he said, it depends on the guts of the top management, whether they want to be the first mover, whether they want to take that risk to maybe do a prototype analysis or do a feasibility analysis. The feasibility analysis is usually not that expensive. The feasibility analysis can be done quickly, can be done in collaboration with academia, can be done in collaboration with subject experts. So the feasibility analysis is done, and it gives a good idea whether the solution is implementable or not at a very low level.
He mentioned about microns and nano, etc. That's what I think he presented in his PPT. What is your tolerance levels?
Plus minus 1 micron.
1 by 50th of a hair. Of a hair.
Yeah.
So 1 by 50th of a hair. So it is possible. All these kind of tolerances, and you said about conducting paints. I think I was talking to the deputy director again. He was talking about conducting polymers for a stealth technology. So technology doesn't come just like that. I think necessity is the mother of invention. So there is a demand in industry, and academia and R&D can pitch in for bringing that into a reality. And then, of course, you need some, early starters who can adopt that, and then word spreads around, and it is happening. And as my friend said, that you cannot be complacent of not adopting that technology today. Otherwise, you will become a BlackBerry, you will become a Nokia, and you will become a Moser Bear, right? So it's a time is already short. People should adopt and move forward.
As you rightly said, time is very short. So we'll wind up this session. Thank you, panel members, for giving your time and answering all the questions very convincingly. Thank you. Thank you all.
I would request panel members to be here, and thank you for your insightful deliberative. I would like to request Professor Kaushal Desai to kindly come to the stage for felicitation. Thank you, sir. And thank you to our experts. With this, I would like to invite Dr. Chandan Pandey, Assistant Professor, Department of Mechanical Engineering, for the vote of thanks.
Good evening to all of you. It has been an honor to be the part of this wonderful event. On the behalf of IIT Jodhpur, I would like to express my sincere thanks to Mr. Suresh Perinjari, Mr. Naveen Kansara, and Mr. Mukul Gupta. Thank you all for the joining. Thank you.
Thank you, sir. I can just say at the end, the fourth industrial revolution is still in nascent state, but with the swift pace of change and disruption to business and society, it's time to join with right now. With this, I'd like to adjourn this session of Industry 4.0. Thank you all for your presence. Should I need to announce, sir? Hello? The validatory function will be commencing in next 5 to 10 minutes. Everybody is requested to be seated. Thank you.
Okay, Nas.
मैं शुरू करता हूँ, ठीक है?
Hello, everyone. A very good evening. I'm sure all of you had amazing 2 days and great sessions. So we have come to the concluding ceremony of the event. For that, I'll invite Dr. Gaurav Bhatnagar. He's Associate Dean, International Relations and Outreach. I'll invite him to the stage to give the concluding speech.
A very good evening to all of you, all the dignitaries sitting over here, Professor Shantanu Chaudhary, Director IIT Jodhpur, Professor Vadera, Deputy Director IIT Jodhpur, my faculty colleagues, all the staff members, students, and ladies and gentlemen. It gives me immense pleasure to welcome you to the concluding session of the third edition of Industry Day 2023. I also welcome all the viewers who are joining us online. So when I say the last 2 days were phenomenal in building, strengthening, and enduring the IIT Jodhpur, industry connections, I'm sure, I say that for the entire IIT Jodhpur fraternity. The event provided an avenue for potential collaborations, opportunities between industry and IIT Jodhpur, creating awareness about different research projects, resources of industry interest being undertaken by IIT Jodhpur in form of projects. It also provides a platform to discuss the technological challenges industries are facing and eventually initiating long-term relationship with industries to solve those problems. Uh, this industry day witnessed plenary talk, key talks, panel discussion sessions about the institute progress under various themes and a poster symposium. Event took place under 10 different themes, namely medtech and healthcare, technologies for sustainability, sensors and IoT, resilient and smart infrastructure, dependable and responsible AI, robotics and mobility, intelligent and neuromarketing, AR, VR and metaverse, hydrogen economy, and Industry 4.0. I am glad to report that we have received more than 130 posters from the students in the poster symposium across the themes, and it is time to announce the result. So moving forward, I would like to take this opportunity to invite our Honorable Director, Professor Shantanu Chaudhary, IIT Jodhpur, and Mr. Pradeep Khanna on the dais. Sir, please come on the dais. So it's the time to give away the awards to the poster symposium winners. So I'm going to call the winners theme-wise. So the best poster awards in the medtech and healthcare. Tilak Chakravarti, he is getting the first best poster award for the development of hydrophobic self-healing anti-fogging coating for endoscope. Harishran R. and Katayini Sharma for the poster development of an office-based treatment device for an anterior deviated nasal sputum. Best post. Okay. Best poster awards in sensors and IoT. Harishran R. and Katayini Sharma again. For the poster, micro electrode based device for cutting issues reshaping. Anupam Kumari for the poster fabric based wearable humidity sensors. Best poster awards in resilient and in smart infrastructure. Tej Kulkarni for the poster dynamic model development of water distribution system. Shally Singh for the poster synchronous for data-based disturbance monitoring and tire-based spatial localization. Best poster awards in intelligent and neuromarketing. Gargi Majumdar and Arpan Banerjee for the poster Aging Research Prefrontal Code for Emotions. Gargi Majumdar and Arpan Banerjee. Kartika Chaudhary for the poster Do Women See Differently Than Men? Measuring Attention Using Heat Maps. Best poster awards in AR, VR and Metaverse. Satyam Kumar Gupta for the poster Design of Haptic Sleeve for AR, VR experience. Basant for the poster Upsampling of Personalized HRFT for Spatial Auto Rendering, why deep learning is problematic. Best poster award in Dependable and Responsible AI, Jayant Vyas for the poster Federated Learning Based Recommender System for Next Generation Transportation. Prajwal for the poster Vision Augmented Table to Text Generation. Prajwal, are you here? Oh, maybe then you can come, please. So we have the proxy for Prajwal. Best Poster Awards in Industry 4.0. Prince Kumar Rai for the poster Integrated Electrochemical and Photocatalytic Degradation Based Textile Wastewater Recovery. Garbit Chugh for efficient method for automated non-smart devices using IoT-enabled based smartwatch. Sorry, smart switch. Awards, Best Poster Awards in Technologies for Sustainability. Akansha Mishra, the algae for the poster Algae Carbon Capture Cells. Akansha Mishra. Okay, Shikha Pandey, Shushma and Ritesh Mishra for the poster cold plasma-based nitrogen fixation for global agricultural needs. Best Poster Award in Hydrogen Economy, Abhishek Yadav for the poster PV Assisted S2 Production. Shashwat for the poster Sea Water Electrolysis. Best Poster Awards in Robotics and Mobility, Deepak for the investigation teleoperation of your robot for different network configurations. Akash Vyas for the poster Robust Operational Space Motion Control of a waste assistive powered exoskeleton. My apology, I have missed one poster in the session of dependable and responsible AI. Because scenario is there are 3 papers chosen for this theme, and there is a tie in these 3 papers. But mistakenly I have forgot that. So now let me call the name Anubhuti for the poster Attacking Vision Transform Based Object Detector. Anubhuti Jain.
Sorry for missing out your name.
Okay, now I request Professor Chaudhary and Professor Pradeep to please take the seats. So on this note, we would like to thank everyone who participated directly or indirectly to make this event a great success. We really look forward to seeing you again in the next edition of Industry Day next year, 2024. Till then, stay connected. Thank you once again and have a great evening. Thank you very much.
Thank you, Dr. Gaurav, so for such succinct summarization of the 2-day-long event. Before we call it a day, I would like to invite Professor Surajit Ghosh and Professor Richa Singh on stage.
Let me just take a minute. Thank you everybody for participating such proactively in this session. Gaurav has already given, and Dr. Vadera has already given the vote of thanks, but we just wanted to finally thank Gaurav as well, because this Industry Day could not have been organized without the monumental efforts of Gaurav. So thank you so much. A huge round of applause for him. And thank you so much for the wonderful food you have been giving us for the past 2 days. Thank you. So that is all that we wanted to say. Thank you, everyone. Have a good evening.
Thank you.